Good morning, everybody. Welcome to day 3 of GopherCon. Final day, unfortunately, of GopherCon.
I know, right?
We've had some good stuff so far.
We've had some really good stuff so far, and some more good stuff to come.
Yeah, today's going to be no different than the last days. Maybe some more exciting stuff even.
Maybe a little warmer, too.
Yeah, I mean, we're starting on a high-ish note.
It's
today.
gotten up to just a blistering 60 degrees in here.
I'm starting to sweat.
We've also convinced Aaron to introduce a slight bit of color.
Step it up a little bit.
I hit everyone. I hit you all with some blue and some maroon.
That's some teal.
Is there teal in here?
That's what's still looking out for me.
Little bit of orange stripes in there.
Johnny, you upstaged me though with your white and light blue.
I mean, it wasn't hard though, right?
I'm setting the bar pretty high. I'm just saying, you know.
We don't
You
have
really
to do
went
much.
for it.
It's just, pick a shirt, any shirt.
Wardrobe suggestions welcome. I go pretty deep as you can see, but wardrobe.
Yeah,
suggestions
next year we promise to get wardrobe and makeup.
Yeah, absolutely. Yeah.
So, first of all, I want to thank all of our sponsors for making this happen. Please go check them out on the websites. They're doing all kinds of giveaways. Talk to them on Discord. Talk to them in Gopher Town. Many of them have VMSs, virtual meeting spaces, that are running in parallel with parts of the conference. Definitely go check those out. They're running workshops and little game shows. There's a lot of fun stuff going on.
If you're in the market for a new job, lots of them are hiring. There's some exciting stuff. We have Tom Lyons on stage. Did one of these. We're hiring. So CrowdStrike is hiring for sure.
So almost all of the sponsors are hiring. So now's the perfect time if you're looking for a new gig. Go talk to them. If you want to attend any of the virtual meeting spaces, you do need to have a virtual ticket for that. Just go to gophercon.com and register there. You can also see the schedule for the talks today and those virtual meeting spaces on the agenda page. We've got Go Time coming up with
Gophers,
the episode I've been most looking forward to all week. Mm-hmm. They're going to do a Family Feud style game where they ask you, the community, a bunch of questions, and then they make the Go team compete to guess what the most popular answers to those questions are. And accurate or not accurate, they are the answers. If you want to participate in that survey, go to gotime.fm/GS for Gophers Say. All right, and who do we have up?
Yeah, let's get to it. Our first talk of the day is Mathilde Raynal. She's going to talk about quantum computing today. We've had some novel
I'm going to
uses.
feel really dumb.
Yeah, oh yeah. I'm going to just be sitting in the corner crying while I watch her talk, because it's just way over. It's not even like here over my head, it's like up here over my head.
So when you say quantum, is that like Quantum Leap, like with Scott Bakula and with Ziggy and stuff? Am I dating myself here?
Yeah.
Anybody know what I'm talking about?
We've got dad jokes.
I have no idea
We've got.
I've never heard of such things. What is this?
It's gonna be interesting. We've got some novel uses of Go. We've seen some at this conference, but we're talking about quantum computing. This is a new frontier, I think, for Go that has been not explored maybe at all. So I'm really excited for this one.
Yeah, me too.
Yeah, Mathilde is a, I believe, newly graduated PhD student. at the Swiss Federal Institute of Technology. So we're really excited to see what she's got in store for us today. Yeah, so with that, let's get to it. Mathilde, take it away.
Hi everyone, my name is Mathilde and I am super happy to be here and to welcome you to my presentation, Taking the Quantum Leap with Go. So before we start, just a quick word about me. I am currently a PhD student living in Switzerland, and this is why you will see throughout the slides some pictures about the Alps and the mountains and all this kind of stuff. Regarding my research interests, they range through many applications and topics, and for example, like privacy-enhancing technologies or applied cryptography. I also enjoy looking at some machine learning when needed. And today we're going to talk about a topic that is very dear to my heart, which is post-quantum cryptography. So it might sound scary and overly complicated, but I will try to make it as fun, may I say, and simple as possible. Today, really, we're going to try to answer three main questions. So, of course, we're going to start with an introduction, and I'm going to explain really what is going on, right? So everyone's talking about quantum computers, but what does it mean? What is these quantum threats, really, that people are getting so worried about? And after explaining a bit what is going on, I will motivate, really, the need for what we call post-quantum cryptography. So I'll explain how this threat is going to impact you and your project, and why you should be interested in this presentation, basically. Finally, I will not leave you hanging with an existential crisis, and I will conclude with the presentation of one library, which comes as a solution to address the threat. And spoiler alert, this library was developed and is available in Go. Okay, so quantum. Right, quantum computers. On the right, you can find a picture of a quantum computer. And other than being, I think, kind of pretty, they are a true technological marvel because they can perform some kind of computation ridiculously fast, faster than any kind of supercomputer could even dream of. And they will benefit many research areas. So like I think about chemistry, I think about finances, healthcare, and so on and so on. So this is a good start. But the issue is that because of these computational powers that enable people to compute things very fast, they threaten the security of the publicly cryptographic algorithm that we know and use nowadays. Something about RSA, PGP, all those algorithms will not protect our sensible information anymore. So that means, for example, that if you're sending like an encrypted message to someone, an attacker who has access to a quantum computer can just run a very powerful attack and just crack your message open like if it was not even encrypted and read it in clear. This is disastrous, right? We don't want that. And as a side note, I think it's very interesting that because of the time frame, I won't talk about it. Not only the public cryptography is impacted, right? Symmetric cryptography and hash functions also suffer from a drop in security. Yet they are not completely broken the way public cryptographic algorithms are. So this is going to be out of the scope of this presentation, but nevertheless, if you have questions about that, be happy to answer them. The public cryptographic algorithms that we use nowadays are not going to protect our messages anymore. And so what? Do we even need public cryptography, right? Can't we replace it? And the quick answer is we need public cryptography. So those of you who might be working in the security-related field might directly interact with encrypted data. Some others might be sending encrypted emails at work, relying on the VPN solution, digitally signing some documents, looking at certificates, and why not, who am I to judge, buying some cryptocurrencies such as Bitcoins. All those technologies are only a sample about everything that we're doing in our online life whose security really relies on public key cryptography. And there is no replacement for that. We need public key cryptography. You might be now having a follow-up question, which is, okay, we need public key cryptography, but we've been using this trick for many years of slowly but steadily increasing the key sizes, right? It was at first 128 bits, then 256, and so on and so on. Can't we just keep doing that? Unfortunately, we can't, because the way we foresee quantum computers to scale and the powers we think they'll have, we calculated, the researchers calculated that, for example, if you want to use RSA, you will need 1 terabyte keys for your system to be secure. This is not memory friendly, this is not efficient, you do not want to go through the trouble of handling 1 terabyte keys. So, okay, we need public key cryptography, and we need solutions that are not going to come at the cost of unpractical, unrealistic key size or other consequences. And those alternatives are called the quantum safe alternatives, or as you might have heard of, the post-quantum cryptography. So post-quantum cryptography has this very nice property of, in addition to being secure against the classical adversaries that we're used to, they are also secure against adversaries that have access to quantum resources. So meaning that even if this adversary was trying to run this very fast operation against public post-quantum cryptography, it would still be secure. Just as classical cryptography, there exist different flavors of post-quantum cryptography. So we can think about lattices, hash-based functions, isogenies, and so on and so on. All of these flavors have different properties. So some are really going to target efficiency in terms really of speed and performance, while the other are going to look and minimize the output sizes. So really work with very small signatures, very small public keys, and so on and so on. So my guess is that according to the requirements of your project or the technology that you're trying to make quantum safe, there is a solution that is going to work with your objectives, right? If you're trying to be very bandwidth efficient, then I would suggest maybe to have a look at Rainbow and all this kind of stuff, which is a multivariate technique. So maybe something that is also in the back of your mind is, okay, so now I'm talking about the threats, I'm talking about we foresee things. Is there something that exists now, and why should we talk about this now? So to answer the first question, what exists? Well, for now, quantum computers are at the stage of prototypes, right? And why we should talk about it now is because we know that we are super slow to integrate new tools and new technologies into whatever we're working on. So even Git, I think it's a nice example because they have the manpower to make things move if they wanted to. So Git knew back then that SHA-1 hash function was broken, but they took their time, right, to change it to SHA-256, and they took so much time that actually some bad guys, just to prove a point, implemented an attack, targeted the repo, and completely destroyed it. So that might not be super, impressive, just to destroy a repository. But if you think about it, okay, I have a database of my password which is being encrypted. Well, you don't want anyone to go and look at that and encrypt them and look at your passwords, right? You would not want that. So this is why it's important to anticipate really the fact that there are going to be quantum adversaries and go the fastest we can while still making reasonable decisions. So in front of you in the slide, there is a very simplified version of an integration process. So of course, it starts with some research, people designing new tools, new algorithms, and the standardization process. So community looking at what has been proposed, assessing their properties, and deciding, agreeing on a few of them, which are going to be deemed as standards. So this step, the standards are going to be announced by the end of this year, and I think maybe beginning of 2022. Afterwards, after the standards are being announced, there's going to be an army of developers that are going to look at deploying the system, bringing them from theory to practice. So I'm thinking about supporting different languages, hardware, software, and so on, to make really them accessible to anyone. And anyone being the project owners, which might then decide to create a fork, test the technology, and after a certain point, maybe eventually complete the transition and use this new tool, this new cryptography, as the main component. So this is what we want with post-quantum cryptography, right? We want it slowly to replace what we've been using until now. And the issue and why there is this sense of emergency is that we don't know how much it's going to take before scalable quantum computers are built. Huge companies are putting even huger amounts of money into this research, and I think it's going to go even faster than anticipated. And if it is a case that scalable quantum computers are accessible to people with malicious intentions before the transition is complete, well, you're exposing yourselves to the risks that we just went through, such as, for example, exposing all of your passwords online. When should we care about that? A quick and very marketing-like answer, maybe yesterday. We should have cared yesterday. If you want my personal opinion, I think you should care about it from like a developer point of view as soon as standards are being announced, because at this point you're going to be able to see, okay, I can work with that. Let me see the feasibility. So I think this is better answer, more honest. So okay, so maybe by now I've convinced you that the quantum threat concerns you and that you need post-quantum cryptography in your project. But I can understand that you don't want to have to go through the trouble of implementing it, testing it yourself, and so on and so on. We went ourselves through the trouble and we developed a post-quantum cryptography toolkit. So you can access it via the QR code on the slides, and I guess the slides themselves are going to be available online. So, or you can email me or ping me and I'll be happy to send you the link. So we made our toolkits open source, right? So you can really see what's happening inside them. You can try and understand what we did. And we implemented two algorithms. The first one being an encryption scheme whose name is Kyber. The second one is a signature / authentication scheme called dilithium. Both Kyber and dilithium are part of what is called the Crystal Suite, which is a finalist in the NIST standardization competition that I mentioned, like this standardization competition that I mentioned a moment ago. So what it means is that people have valued really their security. They have looked at it, assessed it rigorously. Also, they say that it was not coming up too much of a performance issue, and so on and so on. And of course, as I said, what a surprise, we developed these toolkits entirely in Go. We had a specific focus on security, right? So if we're talking about security, we were like, let's go all the way. So first step is to look at the algorithmic security. And this has been done by looking at the proofs, the following carefully the pseudocode that the algorithmic designer put online, and this is as very easily checkable. We can run like this little a known test answer, vectors test, and all of that. So this check. In a second step, we were also thinking, okay, it's cool to be algorithmically secure, but there is also another point which is of concern, which is practical security. And practical security is enabled when really looking at the code, right? And how do you evaluate if one code is secure? This is very suggestive, right? I think there is no tool yet to ensure that one code is very secure, whereas the other is very not secure. So what we did is that we enable practical security by implementing countermeasure against a very specific class of attacks that are called side channel attacks. So it might get a bit technical at this point, but I think it's very interesting to look at these kind of attacks because they are super interesting. And for those of you who are developing security algorithms, it's very important that you know that they exist and how do they work. So you're playing a poker game with your friends, and really one key idea of poker is to keep your cards secret. Because if you're showing your cards to your opponents, they're obviously gonna win. And even if you manage to keep your cards secrets, you might still be kind of leaking some kind of information. So for example, if I look at the two guys playing poker, my guess is that this guy first beaming himself, maybe he doesn't have that much of the good game he is expected to, whereas the guy smiling all teeth might have, I don't know, like a sweet or I don't know what. And so this is the same way that side channel attacks work. You can gain information about a secret, so in this case the cards, by looking at all these little external signs, right? So it can be the emotion, it can be like how is your adversary breathing, does he look stressed, and so on and so on. And if we go back to our setup, now we can understand that the laptop is not going to try and hide some cards, but a key, and he's not going to be leaking some information through his smile or stress, but maybe through the time it takes to compute some operation or the power it consumes. And those are physical measurements that can be measured by an adversary and correlated back to the key. And if the key can be inferred, well, your algorithm, it can be the most algorithmically secure algorithm that exists. Once you know the key, you're allowed to do everything you want. So there is not much security left. So this is something very important to consider, these side channel attacks, right? So to reread what I said, what we did is that we looked through all the attacks targeting both Kyber and Dilithia, the algorithm that we implemented, and one by one we implemented the countermeasures. So we ended up with something that was very secure on top of just saying post-quantum security. And I think this is a great add-on. Finally, as the last point to conclude this post-quantum topic, I think it's interesting to look at the cost, really. So we will need post-quantum security, but what is going to be the cost of that security? So what we did to assess the overhead is that we compared our algorithms against two algorithms that we picked from the Go official crypto library. So we picked the same level of security, of course, in the classical setting, because if you followed, you should know that what we've been using, ECDSA and RSA, are totally broken when facing quantum adversaries, so we don't want to go that way. So for the same level of security in the classical setting, we compared both the performance in terms of speeds and the size of the outputs, right? And we can see actually, quite surprisingly, that regarding the performance, our library performs way better than the algorithms from the Go library. So in the very light blue is our the runtime per operation of our library, and in dark blue it's the time it takes per operation of either ECDSA or RSA. So of course, the smaller the better, right? And okay, so far so good. We have post-quantum security and we gain performance. What's more to ask, right? And I wish I could stop here, but actually there is a trade-off to this nice increase in performance, which is the bandwidth. So the bandwidth necessary to run Kyber and dilithium is actually quite big. It is orders of magnitudes higher than what we're used to. So if we compare, for example, dilithium against ECDSA, I mean, you cannot miss it, right? So this is something to keep in mind. So this is not going to be as disastrous as using a 1 terabyte key, right? But still, it will have an impact that it's good to know in advance. Because I wanted to conclude on, on a brighter and most positive note, I'm going to now present a little test that we did to make sure and to further evaluate this overheads. And what we did is that we took WireGuard, which is a VPN solution, which is available in Go and is open source. So we looked at the code, we identified where is the public key algorithms being used, and we replaced them by the alternatives offered by our library. We ran some tests, some benchmarks, and what we noticed is that the overhead is not that big, right? There is the theory and then there is the practice. So every 2 minutes or so, you can expect an overhead of 2 extra IP packets being sent over the network. And regarding the time, there's going to be a little delay of half a millisecond. I don't know about you, but I can't notice half a millisecond delay. So I don't think I would even be able to tell which cryptography is being used if you're just giving me the software, which is actually the goal, right? We don't want to have to sacrifice anything in your application to have post-quantum security. On this very good note, on this very, experimental demonstration of the practicality of our library, I think it's a good step to conclude. The takeaway message really that I've been trying to content today is a bit explaining what quantum is, and that it's neither bad nor good, like all the technologies are. It's neither black or white. There's always this bit of grayish thing that depends on the context. And if you care about security, well, there is all those things that you can't really, do anything on with these big tech, building softwares, except if you're working for some of them. But at your level and for your projects, you can start having a look at what exists and how you can incorporate it into your infrastructure, right? And when still I would repeat my personal opinion of caring about this kind of thing as soon as standards are being announced. And moreover, if you're interested in having something which was developed in Go and has a very strong level of security, I would also another suggestion, which is very personal, I would suggest you to use our library. And at last but not least, I think if you want to help, well, there are many things that can be done. This practical security process that I mentioned, it's a continuous process. So attacks are going to be implemented. We will have to find defenses and implement them. So we would be very happy if this could be done in a very interactive process. So we welcome any kind of pull request or contribution on this side to make our library even safer, which is the, of course, the end goal. Thank you very much for your attention. And if you have any question, I'll be hanging in the Discord chat. So yeah, drop me a message. I wish you a very good day.
Hi, my name is Rinki Sati. I am the Chief Information Security Officer for Twitter. Praetorian always brings the most amazing talent when we need to engage with them on a project. And what's always been interesting too is they probably have had the most number of women that I've engaged with out of any other pen testing company I've worked with. And that's always meaningful to me. I'm always championing more women in tech and more women in cybersecurity and how we need to get more diverse as a cybersecurity industry. And so I really appreciate that about Praetorian.
Thank you so much, Mathilde, for that very, very fascinating talk. And as expected, I feel not so smart.
Same.
Yeah, if you've got questions about quantum in Go, I know I do, please jump on the Discord. If you're not on there already, you can get to it through discord.gophercon.com. Mathilde is actually in the Discord right now answering your questions about quantum. So definitely go check that out.
Yeah, don't forget some of our other channels in Discord too. Obviously, Peanut Gallery. People have not been shy in the Peanut Gallery to give us, what should we call it, feedback, commentary?
Johnny and I were trying to be pretty forgiving
Yeah.
this morning on your new attire. They are
They have not. There is a screen grab of me though where I don't look too ridiculous. I'm smiling,
Right.
you know, like my eyes are open. That's always a plus,
I mean,
right?
not nearly as good as the screen grab of Johnny yesterday.
Yeah,
though.
this one, yeah.
Yeah, Nirvana.
He does look. He
No, I
did
meant
look
the other one where you were actually laughing.
Oh,
Like,
yeah, that was
good
a
picture.
good one.
That one
That
was
a
your
good
new
one.
profile pic for sure. Yeah, yeah. And there's, you know, we've got dad jokes. We got a mainframes channel. There's been some other new ones by popular demand in the Peanut Gallery. So,
Yeah,
you know, make a difference. Change the world in the Peanut Gallery. You know, get in there. You can also heckle us, obviously, which is we didn't really
Always
have to
welcome.
tell folks.
In particular, Aaron.
Aaron,
Yeah.
he needs it.
Leave Johnny and I out of this.
Bring it on. I wore my thickest armor today, so let's bring it on, everybody. Do your worst.
Help him out with his self-esteem.
Bring me back down to earth? Is that what we're trying? Yeah. Yeah. Well, but seriously though, we've got some virtual meeting spaces coming up too. We've got Gophers of Microsoft. They've got an AMA session coming up, which would be pretty cool. You know, you can go there, do your worst there as well. They can take it. And then we've got Buff coming back. They're going to do a weightlifting seminar. Just
Yep.
kidding.
Yep.
They're going to do.
I'm into it.
The one today is called Buff Helps You Go Faster. That'll be super interesting too. Proto-Buff stuff, gRPC stuff as well.
Yeah.
So what have we got next?
Well, when it comes to distributed systems, eventual
One of my favorite
consistency,
subjects.
I know,
Yeah.
right? One of all of our favorite subjects. Eventual consistency must inevitably enter the conversation, right? So lots of ways to go about it, but we're going to have CRDTs enter the conversation as well. And who better than our next speaker to tell us about how CRDTs can play a role in eventual consistency in Go. So Arash Bina is a principal engineer at the Bread, and he's here to put some knowledge on us. Go ahead and take it away, Arash.
Hello, and welcome to my talk. My name is Arash Bina. I am a principal engineer at Bread. I've been spending a lot of my time over the past few years building decentralized or distributed applications and distributed platforms, and most of that has been in Go. Recently at Bread, we used sort of a new approach, or approach that I wasn't familiar with a lot, using CRDTs to build a service. And I thought it was very interesting, and I want to tell you a little bit about it. At Bread, to give you a little bit of context, we have a multi-tenant platform, and we provide the capability to our clients to create highly configurable payment products and offer them to their end customers, to their buyers. And then during the process of the checkout, we allow them to do credit decisioning, fraud checks, and various different types of sort of workflows. And when the checkout happens, we allow the clients to sort of service those payment products using the platform. The talk is mainly divided into 4 sections. I'll talk a little bit about consistency, what that means in distributed systems, but I won't dive too deep into it. I just want to mention where CRDTs sort of fit in that spectrum. Then I'm going to introduce CRDTs, what they are, and how we develop them. In the 3rd section, what different categories of them are, and how, what are the advantages and disadvantages of each of the categories. And at the end, I'll talk a little bit about, our experience overall. How was it building the system this way? So as I mentioned, I won't get too deep into consistency here, but the type of consistency we all very much used to is a sort of a strict type of consistency where we either provide that with some sort of a database. For example, different replicas of a service, they all talk to the same database. And that's how they coordinate sort of agree on a sort of a strict sequential way of events. And it's important because at that point, all the replicas can sort of agree on the exact time that events happened. And so if you ask any of the replicas what the state of the system is, they can all sort of agree and they return the exact same response, hopefully. In contrast to that, we have a causal or eventual consistency where we allow the state of the different replicas to be mutated. And so when you make a call to a replica and mutate the state, that replica's state will be different than the state of other replicas. In that sense, we allow the system sort of to get out of sync. And then we have, instead of coordinating that in a sort of either with a database or in some sort of a leader, sort of a follower type of architecture, instead of that, we sort of allow these sync events to happen between the different replicas. And what that does is that it allows the replicas to sort of converge, their states to converge. In a weaker sort of a eventual consistency system, there's only a probability that convergence will happen, and it's not necessarily a guarantee. If there are two events and one of the replicas, interpret that event as the first event happened before the second event, and another replica interprets that as the second one happens before the first one, it's possible that the state of those replicas sort of diverge. And so there are different techniques that you can use, for example, to fully sync between the replicas, compare them, and then choose one of them and tell all the replicas that this is now the state of the system. And so there are different techniques that you can use. And in contrast to the sort of a weaker eventual consistency, there's the eventual strong consistency, where through a specific type of merging function, which is a lot more deterministic. So if you have two events, the result of the merge of those two events is always the same thing. And through something like that, you can sort of guarantee a stronger eventual consistency, where you know that all the replicas will eventually get to the same state. And this is really where CRDTs fit, and that's the type of guarantee that they provide. So what are the CRDTs? CRDTs stand for conflict-free replicated data types. They're essentially, it can be anything, but for most common examples are a structure that provides methods for sort of querying and mutating, the state of a replica. And the second part of it is what we call a monotonically increasing function. It's a merge function, and what that does is that it has that deterministic sort of behavior where you have a CRDT, you have a replica with a state, and another replica sends its state to this replica. The sort of the result of those merges will always be the same thing. And a very simple example of this is, for example, a max function. Imagine if you have multiple replicas, each of them are holding a counter. If when we are syncing between them, if you always pick the maximum of the values, after a certain point in time, all the replicas will end up with that maximum value among all of them. And so that's how they converge. And that's that monotonically increasing function. The other thing that's important about CRDTs is that every CRDT would have a full perspective, a full view of the whole system. Now, their perspective, the different replicas' perspectives could be different at any point in time, but sort of the behavior of the system overall is that all those states converge to the same thing eventually over a period of time. So CRDTs are essentially a way to build a system and replicate, data without centrally, coordinate between these replicas. And so instead of that, we do periodic sort of synchronization. So there are two major categories of CRDTs, the state-based CRDTs and operation-based CRDTs. In a state-based CRDTs, which are relatively simpler than operation-based, what we have is that each replica essentially holds the full value or full state of the system of all replicas. So for example, if you have two replicas, the first replica knows about the state of the system at replica 2 and vice versa, or at least has an idea about what the state of the system is at other replicas. Now, what it thinks it is between different replicas could be different at any point in time. But the hope is that eventually they all come to the same conclusion, to the same state. The other thing that's important about the state-based CRDT is that during synchronization, the full state of all the replicas that a replica knows about is transferred or communicated with other replicas. So if I am, replica 1 and there are 3 replicas in the system, for example, I will communicate not only my state, but what I know about the other 2 replicas' state to everyone else. And then the merge function takes care of that sort of the merging between them. As opposed to that, there's the operation-based CRDTs, which are essentially, instead of communicating the full state of the system and storing the full state of the system, each replica only holds its own state. And instead of communicating the full state, it only communicates what that mutation was. So for example, if I have a counter and we increment the counter by a value, let's say by 1, if that happens in a replica, instead of sending the actual value of the counter, it sends the operation that happens. So for example, I incremented the counter by 1, and the other replicas are supposed to receive that and do the same thing, to replicate that operation. One of the important aspects of operation-based CRDTs is that message needs to be sent, be received essentially. The message that is sent by one of the replicas needs to be received by all replicas. They don't have to be received at the exact same time, but we want that message to be received by everyone so that everyone can do the same operation. So in order for everything to become a little bit more familiar, I was thinking of starting from a sort of a very simple CRDT concept, and then we're going to build on top of it and make it a little bit more complicated. So the simplest thing that I could think of as a CRDT is a Boolean flag. And let's say we want a flag, and the value of the flag, we want it to be true if the flag has ever been set to true. So if a flag has been set to true once, then we want that true value to be carried over and not be flipped back to false by a false event. So the way we can define the merge function for this CRDT is that, as the value, if the value of my flag is true, then I'm going to keep that value. And if it's false, then I'm going to, accept the incoming value. And if it's true, then I'm going to flip the value of the flag to true. So let's look at it from the perspective of different replicas. Let's assume that we have a system that has 3 replicas. Each of those replicas holds a flag value. In this case, the flag starts from a 0 point, it's false, and then we can see how that value is mutated over the system. Now, in this case, I want to mention that although these 3 different replicas have a flag in them and they have a value, these are effectively the same flag. It's just been replicated 3 times. These are not 3 separate flags. And so when I ask one of the replicas what the value of the flag is, my hope is that all of them can give me the same answer because they're effectively the same flag. Now, that may or may not be true at different points in time, but we will see that eventually we want all of them to become the same. So let's say a client makes a call to one of the replicas randomly here at replica 2 and sets the value of the flag to true. So in this case, if at this moment in time, if a client asks replica 2 what the value of the flag is, it returns true. But if it asks the same question from one of the other replicas, it will return false. So obviously there's an inconsistency in the system at this point. Now let's allow the system to synchronize. So, each replica picks 1 or 2 of the other replicas and sends a message, broadcasts its sort of state. It communicates its state. And in this case, replica 2 is sending a message to 1 and 3 is sending it to 2 and 1. And so you can see because replica 2 communicated its state to replica 1, now replica 1 also has the value of the flag to true, but no one really communicated to replica 3 here, and so the value of the flag stays false. If we allow another sync event to happen, maybe one of the replicas of 1 or 2, they communicate back to replica 3, and so now the whole system has the value of true. So at this point in time, if you ask any of the replicas, they all return true. Now, I want to emphasize that this happens exactly because of that monotonically increasing merge function, right? Because we are keeping the true values and we are not flipping the flag back to false if we receive a false event. And because of that, eventually the system becomes consistent. If we were to not have that rule and flip the value back to false, the system does not converge. And so it's possible that they may all end up with, let's say, the value of false, but that's not the actual, that won't be the true value of the flag, which in this case should be true. Let's look at a sort of simple code example here. And like I said, we're going to build on top of this regressively. But I have a flag here and it holds a Boolean value. And so, it's zero value. Essentially, when we create a flag, is going to be false. Now I have a merge function. So if another flag sends its state to the receiving flag looks at its value. And if it's false, then it accepts the incoming value. And if it's true, then it sort of returns without making any changes. And so if you look at the main function, I create a sort of a zero value of a flag. I update it to true with an incoming true sort of state, and then I will attempt to update it with an incoming false state. If we run it as we expect, this is a very simple example. It was initially false, then it became true, and then it stayed true. Okay, so let's look at it as something that's a little bit more useful. In this case, let's assume that we want to implement a counter. And the value of that counter is, we want the counter, so let's say count the total number of calls that are made to a service. Now, in this case, because the calls will be made to different replicas, so the total value, the true value of the counter would be the sum of the values of all the replicas. However, because we want those calls to be made to different replicas, and because we want to be able to ask any of the replicas for the value and be able to get an answer, then all the replicas, as I mentioned before, will hold the values of the other flags. So rather than having just one value, we will have a slice that keeps the value of other replicas. And when we are merging them, the way to do it is to use a max function, as I mentioned, which is an increasing function to sort of update our own state and always keep the sort of the max value for all the replicas. And so if someone asks for the actual value of the flag, we can add all the values together and return the answer. So in this case, let's say we have the same three replicas. Each replica has a slice, and the green sort of shows the element that a replica increments if a call is made to it and asks to increment its counter. So in this case, let's say replica 2 receives 2 calls to increment the value of the counter by 1, and replica 3 receives 3 calls. So replica 2's value is now 2, and replica 3's value is 3. So at this point in the system, obviously, if you ask different replicas for the total value of the flag, replica 1 would return 0, replica 2 would return 2, and replica 3 would return 3. But the true value that we know, because we made 5 calls, should be 5. So let's say a sync state happens, and replica 3 communicates to replica 2 first and sends its state. So now replica 2 knows about the 3 calls that were made to replica 3, and then replica 2 makes a call to replica 1 and updates the state. So now replica 1 has the correct state of 5, replica 2 has the correct state, but no one really communicated to replica 3 in this case. And so the value from the perspective of replica 3, the total number of calls is still 3. And now let's allow another sync to happen. In this case, replica 1, for example, communicates to replica 3, but it could be replica 2. And so after the second sync, all 3 replicas agree that the total value is 5. This sync, in this case, this specific example, will happen in 2 steps. But depending on how the replicas communicate, obviously, it could happen with just 1 step, or it could happen in more steps. So we don't really know, there's randomness here depending on our communication layer. And so although the system will eventually become consistent, it may, there's no guarantee that it would become consistent in 1 step or multiple steps. A simpler example of this, let's assume that we are implementing this in just 1 replica, but 3 instances, sort of, with 3 elements in our counter. So if the counter has a slice, I can initialize the slice, or create a new counter and initialize the slice, and then I can increment the counter. But when I'm incrementing, I send which replica's value I want to increment, and then I increment that. And when I'm calculating the value, I add all the elements together and create that. And so if I'm in the main function, I create a counter, I increment R1 and then R2 and then R3. And in this case, because I'm using 1 slice, I would have the full value here. And so if I increment R1, R2, R3, and then at the end R1, the total counter value would be 4. And so if I run this, you see that it gives me 4. Now we can implement what we actually discussed about 3 replicas and create actually 3 separate replicas, and each of them holding a slice. And in this case, I need the counter to know which replica it belongs to. So I add an ID to the counter. And when I'm creating the counter, I would send it which replica it is for. And when I'm incrementing, because the counter knows the replica that it belongs to, it can use the ID, so I don't need to send the ID in the increment function anymore. The value function stays the same. And I implemented the sync function. So essentially now, because we have 3 separate instances, 3 separate replicas, we need to be able to sync between them. Otherwise, the values will always stay, different. So I implemented a sync function. And so a counter can send its state to a receiving counter. And the way these 2 get merged is through the max function. So if the receiving replica's value is lower than the incoming value, it picks the higher value. And in this case, I mutate the receiving counter, but obviously the send counter stays the same. So now if you look at the state of the system, so I increment 3 counters, I increment 1, and so from perspective of counter 1, the total value is 1, but at this point, the total value of the counter from counter 2 and 3 obviously is still 0. So I increment counter 2, now counter 2 has a 1 for its element, and then I send a sync message from counter 2 to counter 1, and in this case, counter 1 gets updated, and now it has the correct value of 2. I increment counter 3, and the 3 sends a message to 1, so counter 1 now has the correct value for the whole system. Now I increment counter 1, it becomes 4, and counter 1 then communicates with counter 2, and then counter 2 communicates with counter 3, and then I print the state of the system. The code, so we can see that, as counter 1 got updated, and then a sync happened between counter 1 and 2, now from different replicas perspectives, the counters values, are different. And then it goes through, incrementing the counter at replica 3, and a sync happens, and then incrementing the counter at replica 1, and the sync happens. And so eventually, at this point in time, at the step 3, replica 1 and 2 think that the total value is 4, but replica 3 thinks that it's 1. And then after another sync, all of them agree on the same counter value. So that was a G counter, which is a grow only counter. But what if we wanted to implement a counter that we could decrement its value? If we just have 1 slice, if we implement it the way we implement the G counter, and decrement the values, because we are always taking the maximum, the decrement events will be lost because we are always picking the highest number. So the way to implement this PN counter, which is a positive negative counter, and we can decrement it, is to have two separate slices. So we use one slice for the maximum increment values, and we use another slice for the maximum decrement values. Let's look at the code for a PN counter. So we have 3 replicas, same IDs, but now here I have added a negative counter in addition to the positive counter, or as negative slice in addition to the positive slice, sort of. When I create one, I initialize both slices, and when I'm doing the increment value, I am basically incrementing the positive counter, positive elements in the positive slice, and when I'm decrementing the counter, I am still incrementing but the values in the negative slice. And so when I want to calculate the total value of the counter, I add all the positive values together and subtract from that the total value of the negatives. And when I want to sort of sync, or the merge function looks at the positive elements separately, finds the maximum for those, and then it looks at the negative values or the negative counter, and it still picks the maximums. And that way it merges the two states together. So to make it a little bit more automated and interesting, I implemented a sort of a naive gossip function here. And the way it behaves is that each replica picks one of the other replicas as the replica that it wants to send a message to. And in this case, sends a message to the other replica and sends a state, and then the states gets merged. So there's a sort of a simple pick function that that the gossip uses to pick another replica randomly. And I implemented a utility initialize function so I can initialize everything in there. And then the main function basically seeds the randomness for the functionality to pick a random replica, initializes all the nodes. And then really it's the part where we are incrementing the counter. So in here, replica 1, I'm incrementing the value of the replica 1. And so you can see the positive counter for replica 1 becomes incremented to 1. And then I do the same for replica 2. In this case, 2 gets incremented, and replica 3 gets incremented. And the negative values are obviously it's 0 because I haven't decremented yet. And now I decide to decrement the value for replica 1. And in this case, instead of decrementing the positive counter for the replica, I increment the negative counter, right? So in this case, you can see that from the perspective of replica 1, the value is 0, but from the perspective of other replicas, the values are 1. And actually, none of the replicas are correct at this instance because I've incremented 3 times and decremented once, so the actual value should be 2. To make the gossip function more automated, I create a ticker, and that ticker ticks every 1 second. And then at every 1 second, it does the gossip functionality, and then it prints the state. And after 5 seconds, I want the application to be done. After the initial increments and the decrement, this is the state of the replicas, and then after the gossips happen every 1 second, the values converge, and so all of them agree on the same value. Now it's possible that if you run this multiple times, because they pick random values. Now in this case, you can see, for example, after the first gossip that these two values are different. So after the first gossip, for example, the counter 2 also knows the correct value, but counter 1 is not updated yet. So if you run it multiple times, you might get different results. So I modified that same implementation for a PN counter, but to make it a bit more interesting and see how the system functions in more of a live sort of system, what I did was I created 2 other tickers. So there's an increment ticker that ticks every 600 milliseconds, and what it does is that it picks one of the nodes randomly and it increments its value. And then there's a decrement ticker which picks one of the nodes randomly again and decrements its value, but that one runs every 1 second. And then the gossip ticker ticks every 200 milliseconds. So it's possible that it may tick before an increment or after, or before a decrement or after, or multiple times between those, because it's a shorter time. So you can see that the sort of the go function here is a little bit more involved, but fundamentally, when one of the tickers ticks, it prints that it incremented that value. And then when the gossip happens, the communication happens. So let's look at what happens when it runs. So you can see in this case that initially the system, starts at the 000, and then an increment event happens in this case at replica 2, and the value of the replica 2 is increased to 1. But as you can see, replica 3 also shows 1, and that's probably because after the increment happens immediately after, before the state was printed, the communication between replica 2 probably sent a message to replica 3 and updated its state. And in the next step, the replica 1 also has the correct value, and then we decrement replica 3, which becomes 0, and then increment replica 1. And so you can see that it's difficult to predict exactly, unless we print all the exact timings of the gossips and increments and decrements, it's difficult to predict what result we should expect. The important thing is that, the values don't diverge. The values keep converging to the same values, sort of, for in all the replicas. And at the end, before I kill the application, replica 2 and 3 agree, but 2 doesn't agree, probably because the application was killed before the last sync, or before the full convergence happened. Okay, so that was the last state-based CRDT I want to talk about. And so I just want to conclude the part about the state-based CRDTs and take a look overall at the advantages and disadvantages of them. On the advantage side, I think the state-based CRDTs are a lot simpler to implement, as you will see in comparison to the operation-based CRDTs. But on the disadvantage side, obviously, every replica needs to hold the values at full state of all the other replicas. So for the space complexity, you need more space than if you're only holding the value of your own replica, essentially. On the communication side as well, each replica communicates the full state to all the other replicas. And so because of that, the bandwidth for the communication is a higher bandwidth. You need more data is transferred between the replicas. Okay, let's look at an operation-based CRDT. So for operation-based, I wanted an example of, let's implement a set. And the way the set functions is that, you add an object to the set, it stays in the set until you remove it from the set. And so similar to the PN counter, we can't simply remove something from when we add it to the set, because that function will not be increasing. So similar to the PN counter, I will have two separate sort of sets. One is an add set and one is a remove set. And when I want to add something, I add it to the add set. And when I want to remove something, I add it to the remove set. And the net value of this set is sort of, it looks at the items that are added, objects that are added, and if they don't exist in the remove set, then it concludes that those objects exist. I wanted to make it slightly more interesting. What if we wanted to be able to remove objects, re-add objects that we have already removed? So if you add an object and then remove it, that object will exist both in the add and the remove sets. And so there's no way really to re-add something that I've already removed. So in this case, what I did was I created a sort of an arbitrary rule. So when something is added, I will remove it from the remove set, but I'll also timestamp everything. And so if there is a case where two concurrent sort of events have happened, one is an add and one is a remove, I allow the addition to win over the removal. And now that's a completely arbitrary rule because I want this CRDT to function specifically this way, but you could, for example, build another one that the remove wins over the addition. And so that clock, the increasing sort of clock, that is what provides that sort of monotonically increasing merge function. So if you look at the implementation for that, I reduced the number of replicas to 2 just because this is a longer example and wanted to be a little simpler. But so we have R1 and R2 for the IDs. And now here I've implemented a clock, and the timestamp is essentially the version value for all the replicas, which is a slice of integers. And the clock holds an ID. That ID is the ID of the replica that the clock belongs to, and it has a timestamp. Now each clock can increment, sort of give the next value for the clock, next timestamp. And then I have comparison functions, less than and more than. And so when a clock is sent a timestamp, it can look at the timestamp and make a comparison and say if the timestamp is ahead or before the timestamp of the clock. And it's possible that it's neither of those. So, and if it's not before and not after, then I conclude that those events from the perspective of the clocks happen concurrently. And that's where I will allow the addition to win. The timestamp returns a sort of a timestamp for a clock. And I have a new function to create a clock. And then I have an update function where when a clock is sent a timestamp, not only it can determine if it's before and after, but it also needs to sync its own clock with that sent timestamp, because we want always to keep the maximum version of the individual clock values. So in this case, it syncs its own internal timestamp with that. So the set is actually the CRDT itself. So it has an add map and a remove map, and I have a mutex here so that I can log it when I'm sort of mutating the values of the maps. The new set just initializes the maps, and then the value, as I described, it looks at the add set and it looks at the remove set. And if something is added and not removed, then it concludes that it exists in the set. Otherwise, it doesn't. So I introduced a node struct here so that it makes the functions a little bit easier. And a node essentially is a struct that includes a clock and a set. So the node can add something to its set, and to do that, I just add it to the add set and delete it from the remove set, as I mentioned earlier, and update the clock of the node. And the remove just adds it to the remove set. So initialize nodes just creates clocks and sets and adds them to the nodes. And here's the operation part of the operation-based CRDT, where I define an action, and the action is just an integer. It's either an add or a remove. And the operation struct has a node ID. That's the ID of the node that's coming from. It has an action that happened, and it has a timestamp, and the object itself, what was added or removed. I have a send function, method that's implemented on the node. And so one node can send an operation to another node. Here, all the function does is that it initializes it creates an operation, and then it sends it to the node to be processed. And so the process is really the core of the logic. And so initially I want, no matter what the results are of the merges, I want the clock to be synced to the incoming timestamp. Then I look to see if a clock, the timestamp has happened after, or the clock is before the timestamp of the event that was sent. And if that's the case, I just update the internal sort of state based on the incoming operation. If it's happened after, it means that, or the clock's timestamp is after the incoming timestamp, then that means that I don't need to do anything. And all happens is that in the sort of defer function, I just update the timestamp, or I sync the clock. And if the code sort of reaches here, it means that it was neither less or more, so they must be concurrent. And so in that case, if it's an add, I add it and remove it from the remove set. And if it's a remove, I just basically add it to the remove set. So if you look at the main function here, I try to manually control sort of the additions and the sync so you can see what is happening in the system. So initially I add just a simple object to the first set. And so for replica 1, I have added A and its remove set is empty. I get the timestamp and I send it to replica 2. And so now replica 2 also has that object. Here I remove it from replica 1 and then I sync it to replica 2. And so it gets added to replica 2 as well. Then I re-add it back to replica 1. And what that does is that it removes it from the remove set. And then at the same time, before I allow the syncs to happen, I remove it from also replica 2. So it was already removed from replica 2, but what that does is that it creates two events. One is at replica 1, that's an addition, and then one is at the replica 2, that's a removal, and they happen at the same time because the clocks haven't been synced yet. So then I sync both of them, and because of that specific rule that I want the additions to win over the removals, both of them should end up with the same object. And if we run it, that's exactly what we expect. So the add happens, the sync happens, the remove happens, the sync happens, and then the add happens and the remove happens, but it hasn't synced yet. And then I let it sync, and now both of the replicas end up with the same value. Okay, the last CRDT that I wanted to sort of mention here briefly, and I don't have an implementation for this, but we actually use this for some of the things that we implemented in our service, is a contextual CRDT, in a sense that with this you can really implement any arbitrary object, and all you have to do is define an increasing, sort of that monotonically increasing function. And the way we define it internally was that we look at the state of these objects and we define a sort of an increasing sequence for those. So imagine you have a ticket and you have a ticketing system and you have a ticket, and the ticket can be only like opened and modified and closed. Now if you have two simultaneous or concurrent states, one is a modify and one is a close, you can say that close should always win over the modify, right? And then that's how deterministically you can merge those together. Now that gets a bit more complicated if, for example, you allow multiple modifications to happen at the same time. And so in those cases, you have to determine which modification should be applied last, or which modifications should be applied. If they're modified, the tickets have been modified, one of them, for example, represents a name change and one of them represents a description change, then you have to sort of have fine-tune those and decide how we want the modifications to win. One simple way to do it, for example, is that you can always allow the last sort of modification to win, but in that case, you may not see some of the earlier events. So it really depends on how you want to design the system. So on the operation-based CRDT sort of conclusion, obviously the advantage is that you have a smaller storage footprint because each of the replicas only hold their own data, and on the communication side, they only communicate the operations, which are probably very small compared to the whole state of the replica. And also you can see that you can probably build more sort of general purpose use cases with operation-based CRDTs. On the disadvantage side, the system is more complex. There are more moving parts. And so you have to write more code. And as we know, when we write more code, we also introduce more bugs in the system. So they are trickier to sort of implement and test and make sure that they are correct. And if there is a bug in the system, it will be more difficult to sort of find and address. And the last thing is that they require more reliable infrastructure because we want each operation to be received by all the replicas. We need to have a sort of a reliable infrastructure that can do that delivery. The way we implemented the CRDTs in the service, we started with concrete implementations. So because initially we didn't know what we want the behavior or what is the common behavior for all the CRDTs. So we implement them in a concrete way. But as we implemented a few, we noticed that there are common sort of a pattern, common behaviors between all of those. And so we created this interface where each CRDT can give its ID, can give its type, has a merge function that can merge itself with an incoming CRDT. Some of them need a timestamp, and so we can set the timestamp this way. And also a CRDT can prepare itself for broadcast. And that means that when I want to communicate my state or the operation or whatever it might be, the CRDT knows how to package itself into a message that gets put on the sort of the transport layer, the communication layer, and sent out. And this really helps to simplify the other layers of the system, the communication layer, or perhaps the storage layer, depending on how you implement it. So there are a few sort of miscellaneous smaller things that I want to mention here. On the storage side, obviously each replica keeps its own storage. They don't use a common storage. And so you can implement that different ways. We ended up implementing a simple sort of a memory-based, which each replica holds the whole sort of state in memory, and also file-based. And depending on your needs, depending on how critical a system is, you can use different types of storage. The other thing is that for tests to be quicker and not have specific dependencies, for example, you can use memory-based and you can use file-based for other use cases. On the deployment side, this can be deployed really as any service as long as the replicas can communicate to each other. In our case, we deployed these as sidecars because we use a Kubernetes deployment. And so the services that require access to these CRDT values, they have a sidecar that is essentially our service that provides the CRDT functionality. Another very fascinating thing that was the topic of the clocks when we were doing research on this, there's a very interesting implementation. I've referenced it on the last slide, where there's a specific implementation where the clocks have three components: a physical clock, a logical clock, and sort of a vector clock. And what that does is that it attempts to keep the clocks close to the physical clocks. As you know, in the distributed system, it's impossible to keep all the physical clocks exactly in sync. And so typically they might be a bit out of sync by a few milliseconds perhaps. There are some certain implementations that, for example, use a specific hardware to keep everything in sync. But in this case, it's an algorithm that they have used, and that's how we that was also our implementation for the clock, and that's what we used. You need a gossip layer, and essentially the communication layer can function different ways. But we use the gossip layer in which each node doesn't broadcast the whole state to all the nodes. It just picks some of the nodes randomly, and you can obviously fine-tune that on how many nodes or how often it wants to communicate. But then through this gossip, all the nodes receive the state. One of the interesting implementations that we learned from was HashiCorp's sort of the member list, and it does a lot of things happen in that library. For example, you have queues that between the gossips, messages can be queued in there, and then it communicates the whole queue, and it takes care of, for example, the maximum length of the messages and a lot of things like that. And some of the messages piggyback off of each other so that the whole system is more efficient. The last thing I wanted to mention is that I mentioned that in the state-based CRDTs, the whole state is always communicated to other ones. But there are some interesting articles as well where they implement the merge functions in a way that you can also communicate delta updates. On the testing side, so the main thing that you want to test on the CRDTs, I guess on the unit testing side, is really the merge function and the value functions, because that's where most of the logic lies. On the value functions are typically a lot simpler than the merge functions, but most of the functionality is in the merge function. So you really, and it's something that's relatively easy to unit test. So you really want to make sure that the merge functions are correct, as it's central to everything. On the integration testing side, as you can imagine, there are a lot of moving parts. The integration testing is a little bit more difficult, but we wrote several sort of utility functions that helped us to build the integration tests a little bit easier and faster. So one of those is, for example, there are functions that can create multiple replicas and establish communication between them. We have functions that allow you to set the values for the replicas directly. If you want to test something that, for example, before or after a sync, the value of a replica is something sort of that you know what it is. You need to be able to manually adjust the clocks to be able to sort of be deterministic about the result of a test function. You want to be able to perhaps create timestamps that happen just before or just after another timestamp. Sometimes you want to be able to manually control sort of the communication between the nodes. For example, you want one node to specifically communicate to another node, and so you want to be able to manually control those in some of the tests. And then there are utility tests where you can assert essentially the consistency between all the nodes. So as the communication happens and the states change, at the end you want to be able to sort of assert that the state of all the replicas are the same. And then you want cleanup functions that can clean up the replicas and such. So in conclusion, one of my colleagues asked me if it was worth to implement this service this way, and I think that's a fair question. It's a lot more complicated than sort of the regular ways we're used to writing services. And although it's a fair question, it's also an impossible question to ask out of context because, you want to choose the right tool for the right job. And so if you have certain performance, for example, requirements, if the eventual consistency is an option for you and all those conditions are right, then yes, it might be the right tool and it might be worth implementing. If it's not, if the function of the service is a lot simpler, if it can be easily implemented, using the sort of regular ways that we implement services, then perhaps no, it might not be worth implementing that way. But overall, CRDTs can provide great performance because you can ask any of the replicas and it can very quickly respond back. And also that coordination on the write and mutation side sort of does not have to exist, and it happens asynchronously. On the disadvantage side, there are many moving parts to CRDTs, and they can be complex to implement. And so the testing is more difficult, and those are some of the things that we have to consider when we want to build a system this way. And these are some of the references. There were many more, but these were the ones that I think we looked at most often, and so I wanted to have them here. And thank you. That was my talk. I hope this sort of give you a different perspective, or perhaps if you knew about it, it added a little bit more to what it takes to implement CRDTs, and I hope it was useful to you.
All right. Well, thank you so much, Arash. That was amazing, actually. I mean, I really enjoyed how practical that talk was. CRDTs can be
conflict-free.
You can tell it's our last day,
It's like the jokes start getting cornier.
Oh, man. I was going to say CRDTs can be a complicated subject, but, they're also, technically they're conflict-free. Yeah. But, it was really practical. It was talking about deploying it and all the pros and cons and the pitfalls and everything. And, that's really cool to hear because some of us don't want to read it in a white paper. Some of us want to deploy it and, use this stuff to improve our systems and add reliability and, all that good stuff. Mm-hmm. So he also kind of mentioned it's complex to implement. So I hope that complexity gets kind of removed as better libraries and higher quality software, reusable software, comes out and it lets us take advantage of this stuff more easily.
I mean, I think anything in distributed systems is complicated. It doesn't even matter how many times you've built a distributed system. They're all hard.
Mm-hmm.
I mean, we've been chatting about that a little bit behind the scenes with even like how all of this stuff works in the video when, it's like, oh yeah, press a button and we're live. And you're like, you start learning about how some of these things work. You're like, oh, it's amazing. It works most of the time.
Most of the time it works.
Right. I always loved starting to work for companies and seeing like how the sausage is made, and you're like, whoa. So that's how that works.
You put that in there?
You sell this to people?
Well, then you always see like those pieces where you're like, why would you do that? And you hear the context behind it, you're like, oh, I'm so sorry. I'm so sorry you had to
You
do
almost
that.
you get blinded, right? And so when reviewing people's code, you almost have to have empathy for that, right? Where you have to think like they were traveling down a path and were making decisions as they were discovering things. And it's so much easier to kind of sit on the outside and
Yeah.
think, oh, well, why would you go that direction?
Yeah. And then, you think you know better, you don't.
I like to tell people
You
like
don't know
solving the
context.
problem is the hardest part. Like
Yeah,
looking at something
yeah.
and be like, how do I make that look cleaner or more performant?
Yeah.
That's much easier. Your solution is influenced by the fact that you even saw the other one.
Yeah, you got to work with older code or older systems or stuff people built 10 years ago or whatever. That's harder, than building something greenfield. You got to work with, like you said, you got to work with people who made that decision 10 years ago. You got to work with that decision.
I think we should just be able to come into a company and throw away everything and start over. Right? That's
That, I don't know.
and use all bleeding edge software.
Speaking of the fields in green, so I do have a question for y'all though. If the Earth is made up of 70% uncarbonated water, does that make it flat? So the latest from the Dad Jokes channel, folks. Yes, we're here all day, literally.
Literally, yeah. Whether you like it or
Whether
not.
you like it or not. But on a serious note, though, if you are having issues with the Microsoft live stream, we do have a backup. There is the YouTube Gopher Academy channel that you can switch over and see if you have better luck there. Like we said, not everything.
And while you're
works all the
there,
time.
subscribe. I want one of those plaques.
Smash the subscribe.
Seriously.
Erik wants his plaque.
I'm not mad. I'm just disappointed.
We have less than 1 day of conference left. We need 75,000-ish.
Just shy.
Yeah,
I mean,
shy.
we picked
Only.
up a couple. Yeah, it's
Only
just a couple of
75?
you.
Yeah, it's not a big deal, everybody.
And if you were to make a cool bot,
We're not,
Just-
again, we're not saying to do it. and
But
we're
if
gonna
you
leave it at
did,
that.
but if you did,
But if you did, yeah.
we'd probably, so we do have some VMSs still ongoing. We have a buffer. They're going to help you get buff with protocol buffers, that is. So they do have open office hours, so go check them out. We also have Course Hero with the open office hours. You do need to be registered to attend those sessions. However, registration is free. Just do your thing at GopherCon.com, and you are in like Flynn.
and then later today we have the Go Time podcast coming up. They're going to do a Family Feud style game where they're asking you, the audience, a bunch of questions, and then they're going to make the Go team compete to guess how you answered correct or incorrect. Feel free to join that survey to make the responses more fun. You can do that at gotime.fm/GS, short for Gophers Say. We also have lightning talks coming up again today with Mark Bates. So that's always fun. I don't believe we have any more room, so you missed this year, but I encourage you to submit next year or any other conferences that do lightning talks. It's a great opportunity to kind of test out your content and see how the questions people have,
Develop
what
skill.
they're interested in it.
It's a low pressure environment.
Dip your toe in
Yeah,
public
exactly.
speaking.
Yeah.
Yep.
Yeah, I mean, all three of us do lightning talks. We've done a decent amount of public speaking. I don't know if this counts as public speaking, but we've gotten up on stages
It's
too.
public gesturing. We're jesters.
I'll gladly
That's-
take talking in front of a few thousand people than sitting in front of a camera
The jesting.
talking like to nothing.
We're jesters.
and then
That's a
and then
good
you
word.
get like we're having a conversation and somebody in your ear is like, we got 8 minutes to fill, and you're like, oh great, what are we going to talk about? We're already on camera.
But regardless, we do these lightning talks too. It's a great low pressure environment to try out some new content, tell the world about an idea that you just kind of thought of a little bit. You haven't really gotten deep into it yet. Obviously, if you're a new speaker, to get used to speaking in general, that's another way. Another reason you might want to do lightning talks.
Or
as well.
even if it's a topic that you know well, one of the best ways you can figure out how well do you know this topic is, can you distill it down to 7 minutes? Can you get the core idea across to somebody else, right, in a much shorter time constraint than normal, right?
Yeah.
So that forces you to really reduce it just to the important bits.
Yeah.
So
Just one slide. Trust
Just
me. You know what I'm talking.
Yeah, 7 minutes. That's a great point. 7 minutes is tough to get, anything substantive down to 7 minutes.
I mean, content and code simplicity is actually really hard.
Yeah. Oh, that's one of the Go tenets, right? Simplicity is hard.
You know what? You know what's not hard to do in 7 minutes, though? We could go over your wardrobe color scheme. We think we could do that within 7 minutes, I bet.
We've got
Are you all ready to screenshot?
So outside the studio, to warm up, Aaron puts on a coat and a hat. Anybody want to take a guess what color that hat is?
To be fair, the coat is green. That's a new one for me. I
Like
was
dark
really
green,
going
though.
dark green.
So from
yeah.
afar, it looks gray.
Yeah. But I was outside my comfort zone when I bought that coat because it close up is green. And I'm like, I don't know if I can pull this off, but that's why I went with the dark. Looks gray. It's on brand for me. Yeah. So who do we have next?
And that's what I'll do.
On that note.
So our next speaker, I'm actually particularly excited about. I've got a bit of nostalgia here thinking about our first year with GopherCon and showing up at the Marriott Hotel, just 700 of 750 of our closest friends. So next up we have Aaron Shreve, who is the founder, creator of ngrok. And he spoke at the very first GopherCon. We actually have another speaker later today who spoke at the first GopherCon as well. And so he's here to talk about how we can write less code by writing code that writes code.
Oh, let's grok it.
So take it away, Alan.
Hello, GopherCon. I'm delighted to be here today to talk to you about one of my favorite topics in software engineering, which is code generation. We have a lot to get through, so let's jump right in. What we're going to be going over today, we're going to start off by talking a little bit about what code generation is and why you might choose to use it. Then we'll kind of get into the meat of the talk, surveying some of the practical applications of code generation, some of the popular tools in the ecosystem to do code generation, and talk a little bit about how to use them and why you might use them. Also, jump out a little bit and survey some of the other ecosystems as well and code generators that expand beyond Go. Then we'll work on actually writing a code generator together, and we'll wrap up by going through some best practices here. So let's talk a little bit about what code generation is. But before that, just wanted to introduce myself. I'm Aaron Shreve. I'm the founder and CEO of ngrok. If you're looking for me on the internet, I am at Inconceivable. So, code generation. Very succinctly, code generation is about building programs that produce other programs as their output. For newcomers to programming, that can sound like a very intimidating definition, and it really shouldn't be. Code generation at its heart is actually quite simple. When you think about it, you might be saying well, if I'm generating a program as an output, isn't a program just text? Isn't it source code? If you kind of put aside the meta discussion about what is a program, and focus more on the concrete implementation of it, our programs are source code. So building a program that writes other programs is really just about producing the text for that other program. And even when you're really just getting started, you're very used to writing programs that produce text outputs. So if you're just getting started and really getting into this, that's a really easy place to find kind of a point to hold on to really get into this. So this is the simplest version of a code generator, right? It is a program that produces some output, which is text that would compile as a program. But there are very few code generators that work like this, that you just run and you get a program as an output. Instead, when we're talking about real world and practical code generators, they tend to have two main sources of input into them. One is the source code that they're using as kind of the reference input, and then some kind of configuration. So a code generator will often read source code and then use some configuration to decide what to output. really common source of that configuration would be command line parameters of what to generate, but just as easily a configuration file or some combination of the two is a very popular choice. Not all code generators actually read source code for input. Sometimes it really is just reading from some kind of configuration. In that case, the configuration serves as both kind of the source material and the configuration knobs on it. A good example of this might be something from the Rails ecosystem, where you're generating kind of scaffolds and templates as a really quick way to get started without having to write the boilerplate. This is a good example of a piece of code that runs to very quickly generate a stub for you to start filling in there. So before we actually get into surveying some of the different types of code generation, I want to talk about why we would choose code generation. We're going to come back to this at the end. Trying to understand why we do code generation to start with is a little bit challenging without having seen some of the examples. So we'll do this to start with, and then we'll circle back at the end there. But at a very high level, like one of the main reasons we choose code generation is to write code that we as humans don't want to write. There are kind of a bunch of second level objectives in writing, in using code generation tools and writing code generators. These would be things like code reuse or getting better performance, supporting multiple languages. And you can do all of these things as humans, writing code as humans, but it can get very verbose and tricky to write rather than writing something that will write the code for you. So, like I said, we'll circle back to these and kind of tie them back to the examples that we're going to go through. Let's get into some of those examples here. We're going to go through a survey of practical code generators. We're going to focus starting just on code generators in Go, and then from that we'll kind of jump off to some of the other code generation tools that you're probably familiar with in other popular ecosystems. Getting started, we want to talk about pretty much the de facto intro code generator for any tutorial in Go that introduces you to code generation, and that is the Stringer tool. So what Stringer does is, given an enum or as much as of an enum that you have in Go, right, a set of typed constants, you often with that constant want the ability to render that constant as a string, where the string value you want out of the constant is the name of the constant itself. And of course you can write that routine yourself, but as you add and remove constants, it's just annoying to really keep that in sync with the method that turns it into a string. So instead, we can write a program that will do that for us. We don't have to though, because there is a first-party tool that will do that for us, and it is called Stringer. Down here at the bottom, I've got an example of using Stringer, where you specify the type in a particular file that you want to generate string methods, and then over on the right, you're able to call that string method to return the name of, in this case, ibuprofen. If you actually look at the code that it generates, this is the code that it generates. You don't really have to understand it. It looks a lot more complicated than you would expect if you had written it as a human, and that's because it's space optimized in a way that humans wouldn't normally write it, and it comes back to one of the things that we were talking about earlier about code generators allowing us to write code that is more performant than we as humans might write ourselves. Let's get into another code generation tool. This one is called GoMock or MockGen. There are a number of tools in the ecosystem that look like this. This is one that we use at ngrok. When you're working on testing code, you want to mock out all of the dependencies so that you can test just the piece of code that you're interested in and not have to worry about calls to external systems like databases or working with the file system. And the way that you can do that is to call all of those other services through interfaces. And what that means is that when it comes to testing time, you can substitute in a mock object for those interfaces that will instead not talk to a remote service and will instead do something else. Of course, you have to write that mock object, though. And that is often a lot of work to just continually write these new mocks, especially as you change interfaces. You have to continually update your mocks to match. So what you can do instead is use a tool like MockGen, which you point at an interface, and it will then generate out an object that matches that interface for you. The nice part about it, of course, is that it also generates a whole bunch of methods for you that allow you to define what it should do when those methods are called really quickly, as well as what to expect. So when you're writing a test harness like we have over on the right, what you can do is, as part of your test harness, instruct the mock what you expect to be called in the running of the test, so that you can guarantee that the object was exercised, the external dependency was exercised correctly. If you take a look at the code that's generated behind it, this is just a snippet of it. There's actually quite a bit of code that's generated to make this happen. It's one of the reasons that you obviously don't want to write it as a human. You can see, like, if you squint like really quickly, you can kind of get a sense of what's going on here, where the code generator has defined methods that record the calls that are going in and record what you expect, so that at test completion it can match what was called and what you expect it to be called. Let's continue on. This is a tool that goes into the category we talked about getting to better performance. When you're using marshalling and unmarshalling functions of Go's JSON encoding and decoding routines in the standard library, those routines actually do that through the use of reflection. That means that they are dynamically inspecting the object at runtime to determine what JSON to output. But doing that kind of reflection can be slow. And so what we can do instead is we can write a tool that will look at the structures that we want to serialize and deserialize, and it will generate ahead of time optimized routines for the serialization and deserialization of those objects. Since those don't need to be calculated at runtime, it allows us to create more efficient marshalling and unmarshalling routines. The FFJSON tool is one example of this. There are many that look like it, where it generates those routines for you. They're actually quite large, which is rather common in performance-generated code. So I've omitted that from the slide here, but that hopefully gives you kind of an idea of where that code fits in. It fits into those functions that are known by the JSON package to indicate an overridden method that provides a specialized implementation of JSON marshalling. Moving on to another tool here. This is the first one that we're going to look at that doesn't take Go code as an input. So the previous tools we've looked at take the Go source code as an input and produce Go source code as output. This tool is a little bit different. This is called SQLC, one of my favorite code generators. And what it does is it reads SQL code as input and produces Go source code as output. For those of you who have written SQL code in Go, you know that it can be quite frustrating for two reasons. One is, again, it's quite repetitive, especially when you're working with large result sets. You need to iterate over many rows, and the code that you write to walk over those rows objects and check all the errors is very repetitive. And the second is that it lacks a lot of type safety. It's very, very common to change the columns in a database or change the type and forget to update your code, have them mismatch, even just change the order you query them out in a SQL query and have them not match and run into runtime errors. So what SQLC does is it takes a definition like the one that you see on the left of this slide here, which is your DDL of the table. It constructs an understanding of what the types are in the table, the types of the queries, and then generates code that allows you to write calling code like you do on the right-hand side. So if you take a look down at the code to actually call getAuthor, you're just passing in a context and an ID, and it's running that query for you without all of the ceremony that I'll show you in the next slide that you typically have to do, which is around querying that row out and scanning it into the individually named columns. Anyways, we use SQLC all the time at ngrok, and it has made working with the databases tremendously easier. Let's move on into some of the other ecosystems here. This is the C preprocessor. The C preprocessor preprocessor is also a code generator. It is a program that runs before you invoke a C compiler, and it is essentially doing processing to determine what is the output program that is then going to be handed off to the C compiler. This is an extraordinarily simple use of the C preprocessor to just switch between two different statements that will be included in the output program depending on some definition that's set on the command line. But actual C preprocessor directives can be quite advanced, including all sorts of other files together and making complex decisions even before the program has been compiled. Jumping a little bit back into the Go ecosystem, I want to start branching out into other areas of code generation that aren't necessarily thought about as code generation. GoFumped is a really good example of this, or maybe diverge a little bit from the things that we've talked about already. GoFumped is a really interesting code generator in that we don't normally think of it as a code generator, but it is. It produces a program as its output after reading a program as input. It doesn't take a whole lot of configuration, and interestingly, it doesn't add anything new to the program itself. It simply restructures the text of the program itself, but at the end of the day, it is still, in fact, a code generator. Branching out even further here, one of the very popular code generators, especially used in the Go ecosystem, but that is multi-ecosystem, multi-language, is Proto-C. So Proto-C is part of the protocol buffer gRPC ecosystem, and it is a compiler, the proto compiler, that takes as input an IDL, an interface definition language, that describes structures that you want to compile, and service definitions of RPCs. And from that, it can generate marshalling and unmarshalling code, as well as the actual server and client-side stubs to call remote services that meet that interface definition, and server-side stubs that can be used to handle calls for those APIs. It allows you as the application developer to focus on just the application code that you need to use to call a service or implement a service. And the really interesting thing about it, compared to kind of some of the other code generators that we've talked about so far, is that it outputs to multiple different languages. The code generators we've looked at so far output to one language or another, but Proto-C and what we'll look at afterwards generate code for multiple languages. This is a really interesting property of some code generators, is that they allow you to write in some ways at a higher level than the languages themselves, by allowing you to generate across many different languages. So in some ways, when you're working with some code generation tools, you're often working around limitations in the compiler or limitations in the language definition, but these are really working across multiple ecosystems, which is quite fascinating. I'd be remiss after mentioning Proto-C to not mention Swagger and OpenAPI. When you zoom out at a very high level, they look very similar. At the end of the day, Swagger and OpenAPI are about defining an RPC layer. It just happens to be REST and HTTP and JSON instead of protobuf, but you're still from it generating the same kind of client libraries and server stubs and documentation and other things that you can generate out of that definition language. So a lot of interesting parallels between those two and finding the similarities there. Let's start talking about some other code generators that maybe are not as well known as code generators. Really good example of this is GoTest. GoTest is a code generator, although from using it, you may not know it, because the output, the generated code output is ephemeral. So when you run GoTest, what's happening is you've written your tests in your Go program, but nothing is calling those functions. But when you run GoTest, what it does is it's actually reading that source code of all of your tests, identifying the names of those tests, and taking some input from command line parameters about which tests you want to exercise, and then it writes a new program, a new piece of source code that invokes those tests. It compiles it, which is the test harness, and then runs it. Interesting way to look at this is all of the Go toolchain has options to really show you what they're doing under the hood. Go test works like that as well. If you pass it the -x flag, it will show you the kind of raw instructions that are running underneath. And if you dig through the output there, you can find the place where it actually like links together that test program and ultimately runs it to run the code that it generated there. Sticking in the testing world, we'll also talk about another code generation step inside of testing, which is the cover tool. Interestingly, the cover tool, of course, being part of GoTest, it's doing the exact same code generation we just talked about in the last slide here. But the coverage tool also does another piece of code generation, which is quite fascinating. The coverage tool's goal, right, is to tell you which pieces of your code ran when a particular test was run. And there are many ways to do this. You can instrument the runtime to let you know when a particular statement was called, but another way to do it is what the Go tool does here, which is that it takes your original source code program and then basically creates a new copy of the program with a whole bunch of statements injected that mark when particular statements were run or when different blocks of code were run. This is a really interesting solution. It's one that in solving this coverage problem, you can implement that in the runtime. You could implement it at compile time, and which you choose to do, really depends on what is most practical. And in this case, the authors found that this solution of rewriting the input source code was a more practical way to solve the problem than trying to add new hooks and instrumentation to the runtime to measure the same thing. Let's branch out into some other ecosystems and talk about other types of code gen here. For those of you who do browser development, I'm sure you're familiar with tools like Webpack and ESBuild that take many different JavaScript files or CSS files and combine them all into one. These tools are large and expansive and have many more use cases than just that, but that is certainly one of those popular ones. And ultimately, what it is doing is it is taking JavaScript as input or CSS or many different files and compiling them all together and generating a new program as an output that is sometimes optimized or minified or combined, but has kind of the same raw source code as it doesn't really cause a behavioral change. It is more of an optimization change. So another example of a different type of code generator that's still moving between two different places, but without changing the meaning of the program. In the same ecosystem, Babel is a similar program here, which is reading one version of JavaScript and compiling it to another version of JavaScript. This is really common when you want to use like the latest JavaScript features, but you want to support older browsers. So what you can do with Babel is write your latest JavaScript code, and it will compile it into code that works for all of the older browsers. And it does so by doing code generation, understanding what needs to be done, and then rewriting the code to make that work and outputting a new program. It can do that for other types of transformations as well, moving between like React JSX files and actually the raw JavaScript that browsers need to interpret, but fundamentally also a code generator. This is an example of what that looks like for Babel, where over on the left-hand side we're using a fancy new spread operator, but older browsers don't understand natively, so it needs to be compiled into something that they do understand there. That type of transformation between like one form of a program and a different version of it or a different language is sometimes called a transpiler, like a translating compiler. Another example of that is TypeScript. TypeScript in the same ecosystem is taking a typed version of JavaScript, right, and recompiling it into JavaScript, but allowing you to add type annotations in front of it. So again, like taking a piece of source code, translating it to another one, this also falls into the transpiler kind of bucket of code generators here. As we've zoomed out into like these different kinds of code generators, things like transpilers, things like the Go cover tool and Babel and the C preprocessor and GoFumped, you start to wonder like, what is code generation really? Like those are very different programs serving very different purposes, and they're like a long way away from where we started with something like Stringer that's generating additional code to compile into your Go program. And you start to wonder, like, what is code? It seems like very broad, like, and there are other things that seem like they should fit into that category. Like, isn't the Go compiler itself a code generator? It reads your Go source code as input, and it outputs assembly or machine language as its output. And that's another program, so that too should be a code generator. There are programs that do that at runtime, like V8 or the Hotspot VM, that are interpreting machine code and rewriting machine code on the fly and doing that translation and outputting a new program. Ultimately, that's code generation as well. There are other examples like Rust macros, C++ templates. Are those code generators? Markdown, like that's not a Turing complete translation, but you're still moving from one type of markup to another. Is that a code generator? You start to wonder, like, is everything a code generator? Are you a code generator? Am I a code generator? Like, I interpret instructions and then produce code as an output, so doesn't that kind of make me a code generator? Probably. And that's a fun little meta tangent to be on, not an ultimately practical one. So pulling it back down to like why we're using code generators and focusing more on the ones that we started with. Generators that produce source code that we will then use in our compilation steps, our future like Go compilation steps. We can find a number of places where the tools that we've looked at fit into the benefits that we were talking about up front. I will tell you that these categorizations are fuzzy, right? Saying that like protobuf like is only about multi-language support does a disservice to it. It also improves type safety and code reuse. A lot of like what benefits you get out of code generation really depend on your alternatives, like what you would do instead. So it's kind of hard to pin down what categories all of these things fall into. But hopefully that gives you a good idea of why where these tools fit in and the benefits that they're providing and why we're looking at them for code generation. So we've looked at a bunch of tools that already exist in the ecosystem for code generation. So now it's time to write one of our own. I really want everyone to walk away from this talk thinking and understanding that code generation is an easy thing to get started with. It's an eminently practical thing to do. And to do that, we're going to write a code generator together. We're going to motivate it with a very practical use case that we have at ngrok, actually, which is user-facing errors. So what I mean by user-facing errors is I want you to imagine that you are implementing a piece of like a web service application, something really simple where like you have to take in an email address. And as part of like working with that email address before you work with it, you obviously need to validate it. Very common thing to do in programs, right? Maybe you need to make sure the email address isn't too long, that it can fit into your database. Maybe you have to make sure that it looks like an email address by matching it against a regular expression, things like that. And when you're first starting to write code for this, you will typically use the standard library methods for working with errors like format.errorf to print out errors when the input isn't valid. However, when you're kind of working in organizations and trying to create repeatable and reusable systems, you have users who use your system and they will say things like, my email is invalid, why doesn't it work? And this is a very frustrating thing to hear, right? Because you don't know why it didn't work, right? Someone just told you that it didn't work, but it's not clear like what problem they ran into. And so one of the things that we've really tried to do is to make it a lot easier for users to communicate to us about why a particular error happened and why they ran into the failure that they did. So one example of how you might do that is to add some kind of unique string to all of your errors, right? Something that is very easily identifiable. In here, I've added, error email too long or error invalid email. And these are unique strings that users can latch onto and see, this is like a very unique error code that indicates my problem that I have. When you do this kind of thing, folks who are using your software will often will take that error and plug it into Google, or they'll send it to support, something like that. This is a very common practice if you're working with large-scale software systems like a database or an operating system that tend to have defined error codes for all the different errors that they can encounter. However, jumping back there, one thing is this is very ad hoc, right? This is just a string that you've embedded inside of another string. There's no indication to anyone else who's going to write the next error message that they need to create a unique error code. So how can we start to get more structured about this? One way is we could, create our own function, which takes the unique error code as a parameter. This starts to get into a place where the libraries that you create help the developers who are building the software to understand that they need to follow a convention to create these kind of errors. And that's a good start, but these are still strings, right? We can still do things that are unsafe with them. It's still easy to not be regimented about doing this correctly. So how can we take this to the next step, the next level? One example would be to actually create unique functions for every single error that you want to create in your software, and have those functions output the string errors that we were seeing earlier with the appropriate formatting and the unique error codes. When you do this, it also allows you to return error types that are specialized, that can include the code so that you can potentially inspect them for observability purposes, or have higher level pieces of the code actually work with those errors and switch on the particular error conditions. So writing each of these functions, though, would be really time consuming, right? If you have hundreds or thousands of errors in your program, you don't want to define a new function every time that you want to write one of these errors. So what's a way that we can get around that with code generation? One example would be to define your errors in a reusable format, like a YAML file, for example, is a place to start with, and that's what we're going to work with here. This allows you to define upfront the set of errors that you want to use. It's very easy to add a new one, and out of it, you can create those functions that we were working with. Interestingly, right, it means that you can also create functions for any number of languages that you want to work with and have a unified error directory of all the errors that your software produces. So what does this look like? We're going to write together the code generator that reads that YAML file and outputs the error definitions that we want to use in our software. So this is the very simplest version of it. We're not going to go into the entire thing, but what I've done here is I've defined two types that I expect to get from reading that errors YAML file, which has an error definition, which has the name of the error, the message of the error, and the variables that I can interpolate into each error message. Parsing out those variables isn't too hard, but that's what we expect this load defs function to do. And then at the end, all we do is we execute a template with all of our error definitions in it. So to look at what that looks like, let's take a look at the template. This is the template that outputs that errors YAML file. It's a standard Go template, which outputs the type that we're going to use for all of our generated errors. And then it ranges over every one of our error definitions and outputs a unique function for each one of them, where each of the parameters into the function is guaranteed to be correct and type safe. Reading this template definition can get a little hairy. It's a little difficult to parse really quickly. So just to kind of like walk you through what that looks like, this is really the meat of it, where we're doing this for each error in our definitions file. If we're substituting in the name, this is where one of those names substitutes in, which is the name of the function and also the name of the struct that we create. The parameters then get substituted in, right, which is both the type and the name of the parameter in some cases, and just the name in the actual formatting of the message. And then finally the message itself. Since there's only one parameter in each of the errors that we were looking at, the loops also disappear. You'll see that there's some extra commas in there, but don't worry about that, that's still valid. And what that means is that at the end, you can call these functions that are type safe and generated with your unified error directory, generate them for all of the different pieces of software, that all the different languages that you use, and still have a unified definition for them all. So that was a really quick way to get started with code generation. A really quick example of how, with just a few lines of Go code and a standard definition in a language like YAML or JSON, can be used as the source for that code generation. And now I want to talk about some of the best practices when you're writing code generators. You may have seen some of those in the example that we looked at, but I want to go over them in more detail here. So there are a number of different best practices. We're going to walk over each one of them relatively quickly here. So the first one was one that you probably saw in the code generator, which was a comment that was at the top of the file. And it said something like this, like code generator by stringer-type pill. This is the generation comment that the stringer utility that we talked about earlier leaves, and it says do not edit. This is pretty important. It instructs humans not to edit the code. If you don't include it, it is possible that it makes for a poor developer experience. When developers look at code, they assume that they can change it or modify it to their needs, but then it becomes out of sync with the source that was used to generate it. The best practices for creating this comment should indicate for humans not to write the code. It should redirect them to the source of truth, where they would want to work to actually make a change to the generated file, and then ideally also help them understand the command that they're supposed to invoke to actually run that code generation step. Sometimes, if possible, if the definition comes from a single unique file, including the source file itself that was used to generate it, can be a really helpful addition as well. Moving on, and in a similar vein of really focusing on developer experience, isolating generation files serves a purpose both for developer experience as well as making it easy to write the code generator. I suggest that when you do code generation, that the files you output use a distinct suffix or put in a separate directory away from human-generated code. Isolating code files in this way really help developers quickly understand what is machine-generated and what is human-written. And that has a number of benefits, one of which is, when you're working with tooling, like grep, for instance, it's really easy to filter out files that match a certain pattern in a certain directory when you're often looking for things that are human generated and not code generated. So that's one reason that kind of good developer experience. There's a side benefit when you're writing code generators that every time you run the generator, you need to remove all of the old files. So making it really easy to remove all the old files becomes a benefit in the construction of these generators as well. Let's talk about the actual implementation of the generator. So in our errors example, what you saw is we used a string template file or a string template to actually serialize out the code that we were generating. It's very tempting when you start going down the code generation rabbit hole to find a couple packages in the standard library like GoAST and GoPrinter and say, an abstract syntax tree. That's what I want, and to try to construct the code that you want to generate as a set of AST nodes and then use the printer package to output them. It's often not the right thing to do, and almost never the right thing to do when you're getting started. String templates usually are a better choice to get started with. That's not always the case. There are some cases where you do want to be working at the AST level, like transformers like GoFumped are a really good example. But the thing to keep in mind is that code generation can often be difficult to read. We walked through that, very simple template, like one at a time, because it's difficult to parse for humans. So trying to keep things as simple as possible to reason about is paramount for the maintainability of your generators, right? So the simpler you can make them, the better. And that often means that just starting with string templates for writing them out is the best choice to get started with. Nice part is you can use those string templates without having to worry so much about the format of your code, because you can always GoFumped it afterwards, which should always be the last step of any code generation tool you write in Go. I would be remiss in a talk about code generations to not mention the GoGenerate tool. This is the canonical way to instruct the Go toolchain to run a code generation step before you compile. Before the Go generate tool existed, it's very common, right? The interesting part about code generation steps is that they exist outside of the normal tool chain of compiling a Go program, right? The Go tool chain is go build, go install, but if you have to run some kind of like stringer thing beforehand or a mock generator, it's not clear that as a developer you're supposed to do that. So what we added to the language was a directive that the Go toolchain understands means that it should run a program before it actually runs its compilation, that it can run a particular step before it runs the compilation step, and there's a command to invoke that will go find those directives and run them. There's an excellent blog and documentation about it. It is kind of functionally equivalent to make, but in a very Go-specific way, and one that works cross-platform without having to make sure that you have any other tools installed. So if you're building these things into your Go programs, definitely the preferred way to make sure that those generation steps are easy to access for other Go developers. Last kind of point I want to touch on is the question about, should I check in my generated code? There's no one-size-fits-all answer here. There are pros and cons to going in each direction. On the plus side, when you check in generated code as someone who is contributing or working on the project, when you download that code, you clone it, you can just invoke the Go toolchain to build or install that program without having to worry about first trying to figure out what are the other steps that you need to run first to generate the code that you want to work with. In some cases, your program, like if you didn't check in the generated code, your program wouldn't even compile without the generated code being checked in there. So that's one thing to certainly trade off. It also, right, it avoids like adding generation steps to the build process where those can be like kind of more human steps if they're things that change very rarely. On the other hand, it does make doing pull request review quite challenging when you're looking at incoming changes and there is, like one line that actually needs to be looked at, but you see that there are like 10 or 50 files that have changed because of generation. That can make reviewing those kind of changes quite challenging. So to address that problem, there is a file that you can use called getAttributes, which allows you to annotate a specific set of globbed patterns as being generated, and some source control managers like GitHub, for example, will pick up on this to know that there are a certain set of files that are generated and will automatically collapse and kind of hide them so that your human reviewers know that they're not things that they need to look at and can instead focus on the pieces of code that do matter, which are the ones that were written by humans. All right, so just quickly recapping here and going over what we learned. Code generation is at its heart about programs that output other programs. There are a wide variety of use cases for it. It can help you solve a tremendous number of problems and make writing more code with less lines of code really easy. And the other thing that I hope everyone took away is that code generation is eminently easy. It is easy to get started with, and it is not really that complicated to get started with. And you can do it to really start scratching your own itches and solving your own problems. It's been a delight to be here at GopherCon. I'm so happy to be here and to share about code generation with you. And I'm looking forward to seeing you all at a future GopherCon, hopefully in person one day. Thank you so much.
All right. Thank you so much, Alan, for sharing all of your knowledge, best practices, everything. This is a super important topic in the ecosystem. We see some of the biggest Go repos out there that are doing code generation as a core feature. It's mission critical for them, which I think just goes to show.
A lot of client SDKs written in one language and generated to others, and
yeah. So I did see a few questions in Peanut Gallery, so do make sure to join Alan in his channel in Discord. If you've got those questions, he'll be there. He'll be there to answer them. So do go join him. Yeah, so one other thing that I noticed was he mentioned start with string templates and not Go AST, which is reminiscent of don't use Go routines yet. When the first run through your program.
Or I'm going to adopt containers, therefore I'm going Kubernetes, Istio, I'm doing everything all at once.
Yeah, you can get pretty far with the basic implementation. You don't need to go Kubernetes, you don't need to go AST.
Yeah, and I love Kubernetes. It's just interesting that it's like all or nothing most of the time, right, when people adopt new technologies.
Yeah.
So one thing I want to point out is we're like super light on the heckling. So either people are like asleep or we're growing on them. They may be starting to like us.
I have a guess which one of those two it is. Well, there was one thing. Dylan in the Peanut Gallery kind of nailed the purpose of the channel right on the head. He just basically said trolling is the primary purpose of this channel.
It is. And yesterday I discovered that the context of what Peanut Gallery means actually is lost on a lot of people, and that makes me feel really old. So if you're not aware, Peanut Gallery comes from back in theater where the cheapest seats up front, where most of the hecklers and stuff would be. They served peanuts because they were like a cheap snack, and they would often get thrown at
the performers.
In disapproval. That's why it's Peanut Gallery.
Okay, so there's no peanuts cannot be thrown over the internet.
They can't.
So Discord is the next best thing, I suppose.
What we can do is we can throw the show over to Mark Bates with the next round of Lightning Talks.
Indeed.
And I'm particularly excited about day 3 because it's the last day that I have to say nice things about Mark. But no, really, we can't thank Mark and all of the presenters enough for putting together all of these fantastic talks. And please, please, please apply to do Lightning Talks in the future, hopefully in person next time.
Yes.
Take it away, Mark.
Hello, everyone, and welcome to day 3 of the GopherCon Lightning Talks. Now, look, I said on Wednesday that we had an incredible slate of talks, and I provided. I said on Thursday, we have an incredible slate of talks, and you know what? I delivered. Guess what I have today for you? An incredible slate of talks. It's remarkable how every time I get to present the Lightning Talks, it's just full of amazing people and amazing new talks. As I always say, this is an honor and a privilege for me to get to bring on fresh new voices and fresh new ideas to the community, because that is how we all grow as a community. And to me, the Lightning Talks are one of the most important things we have as a community. It allows these new speakers to get a foothold in the door and get their voices heard. So, here's what we're going to do today. I would like to go over the rules of the game here before I bring up our first contestant. As always, each speaker has exactly 7 minutes to give their talk and to convince you that their point of view on their subject is the right point of view. FYI, my point of view, always the right point of view. Just kidding. These people are talking about stuff I have no idea about. I'm really excited. So here is, they have 7 minutes. At 1 minute mark, if they will hear this sound. Perfect. And should they hit the 7 minute mark, unfortunately, they will be yanked off stage with these curtains. There we go. Boy, my finger's huge when I do that, isn't it? Everybody at home on a big screen TV is like, whoa, cut your fingernails. Oh, actually, I just did, so they're not saying that. Anyway, with that said, enough about my cuticles. Let's bring up our very first speaker. Andrew, are you there?
Yeah, I'm here. Thanks very much.
It's nice to see you. Where are you coming in from?
I'm normally in Edinburgh in the UK, but today I'm coming from downtown Los Angeles.
Oh, so right next door.
Right, just about, yeah. I was excited to come join you in person, but it didn't work out, so maybe next year.
Maybe next year. So you brought the rain to Los Angeles then?
I think that was my fault, sorry.
That was your fault. Well, anyway, take it away, Andrew. Love to hear from you.
Thank you so much. It's definitely very exciting to be here and presenting today. My name is Andrew. I've been coding Go for nearly 4 years now, I think, and Fine has been my focus that whole time. So today I wanted to show you how we can use the Fine toolkit to get up and running with an app and deliver it to the store in just 7 minutes, although now that's 6.5. So just wish me a little bit of luck. For anybody who hasn't heard of it, Fine is a graphical user interface toolkit for building platform agnostic applications. So applications that are written with Go and Fine will build and run on just about any graphical platform. I'll talk about the specifics a little bit further down. And so these are going to work the same on every platform that you run them on, although they will adapt resolution and match light and dark mode to the current theme and so forth, so it feels about right for the person running the application. And the Fine project aims to be the easiest way to get up and running in cross-platform application development. It tries to be really easy to learn, and also it encourages your code also to be maintainable so other people can pick it up really easily. So first of all, I wanted to run a really quick setup. Now, I know most people will be familiar with this already, but right from the beginning, we want to create our project. Here I'm calling it my project. And we'll go into that directory and run go mod init for my project. So now we're up and running with our Go project. We want to add Fine as a dependency. So we run go get fine.io/fine/v2. That brings the latest version, which is part of the v2 group of versions, into your application. And really that's all of the setup necessary. It does use some C behind those scenes. So if you haven't previously set that up, you might find that there's a dependency or two that you need to grab. There's more details on our website, but I won't go into the specifics just now. If you would like to test that your system is working with Fine, or if you'd like to explore what's available, you can run the fine.io/fine/v2/cmd/fine_demo there, which will make sure that everything's working correctly. The window will appear and it will show you all of the things that a Fine application can do. So we're up and running. I think next we need our hello world. So here is a basic Fine application, probably the simplest one. And for anybody who's familiar with Go application, it should look pretty straightforward. We have our main package. We're going to import the app and widget sub-packages from Fine, and we'll see how they're used. Inside the main function, first of all, we're creating a new application using app.new. Now that's going to do all of the system discovery, wiring up dependencies, and making sure that everything's going to run. And from that application, we create a new window. We've titled it Hello. On some systems, this title will appear above your application. On others, like mobile devices, you may never see it, but it's good to give it a name. Then we give it some content. In this situation, we're just creating a new label from the standard widget package with Hello Fine as the content. And then we pass that into set content, so it's the main element of the window. And we tell the window to show and run, which is basically showing the window and then running the application. It's just a little shortcut. So when we run this code, you'll see this window in front of you, assuming that your current system is running in a dark theme. Probably no surprises there. Hello Fine prints to the window. That wasn't really the most exciting thing. So today I wanted to cover something a bit more. Let's make a markdown editor. In fact, the code isn't that much more complicated than our hello world. You'll see that we've included the container sub-package as well. Let's see how that updates things. So our window this time is titled Markdown Editor. And the widgets that we're creating are a multi-line entry widget, which we're calling Edit. This is where we will edit our Markdown code. And we're also creating a rich text preview widget. We're using new rich text from Markdown. Of course, the Markdown here is empty because we're starting from no content, but you could pass it any Markdown document in there. The key part of the logic of this application is that we're telling the entry that when it's changed, it should pass the data through to the parse Markdown function of our preview widget. And that's really it. Next, we're setting the content of our window, and we're using an adaptive grid from the container package. And what this is doing is putting two items side by side, but when we rotate into a vertical context on a mobile app, for example, the grid will adapt to the size available. And we'll see that. And we pass it the edit for the left or top and the preview for running next to it. And so we run that code, and you can see here we have a Markdown editor running on our desktop. We've got the content on the left that's currently being edited and a live preview on the right. That's pretty good. Now we want to package it because a Go binary isn't really a full desktop application. We use the helpful find tool here, which you can get installed with that command there. And using find package, we build a graphical application, which can also be installed using find install onto the current computer. We could also build for other systems, like using the Windows OS as a parameter, or in fact, we could build for mobile devices like our Android platform, where we need to give just a little bit more metadata. In fact, you could build for lots of different platforms. If you don't want to manage the toolchain, there's a find cross binary that can help you with all of that. And here's a list of all of the platforms that we're currently supporting. Asterisk is a little bit of a work in progress, but it's all in our main repository. You can see here the different applications that have been packaged. We've got on the bottom left, Android. We could double click the app on our Android, Mac, or we could run the Windows. And this is it running in the iOS simulator or in landscape mode, as you can see there, if you've rotated your device. And to release, we're going to then use a similar command, passing in the credentials from the operating system that Apple might have issued us, or perhaps that we've obtained from. And so I can't go into the details of all of the platform specifics, but you can see there that that's how the helper command will get you through. Once these have been built, you basically just take that and do it like you would a normal native app. So we can drag the iOS IPA onto Apple's Transporter app, or we can upload it into the website for Google Play or the Microsoft Store. And really, that's it. We've taken our first application all the way through to the App Store. There's so much more. I wish I could talk about data binding, file handling, standard dialogues, animations, and so forth, but there's just not time today. If you would like to know more, please join the Find channels on Slack or Discord. And if you would like to know even more, or you'd like support for your business or your project, do give us a shout at Find Labs, and we'd love to help you out with your applications. I really enjoyed the rest of the day. It's been great to join you today.
Thank you, Andrew. I have to say that that was a really fine presentation. Sorry, I mugged for the camera, and I don't know why. That was a terrible joke. Let's bring up our next speaker, who hopefully have better things to say than me. Amit, are you there?
Yes, I am.
Welcome, welcome. Where are you calling us from?
I am calling you from Sydney, Australia.
Australia? Wow, we have time zones all over the place today. This is amazing. Excellent. Well, you're going to talk about Hugo and Go Embed, right?
Yeah.
Exciting stuff. Go for it.
All right. Thank you, Mark. All right. Hello, everyone. My name is Amit. So today I'm going to talk about how I converted a static website into a Go executable using the Go Embed package. So I want to start off with the problem statement. And I also want to start off with that there was no problem to solve. I wanted to host, the wanted is the keyword, to host my new static website in the cloud on a virtual machine. I did not want to do, the usual way that I have been doing, and most of you probably have been doing, using, things like GitHub Pages, S3. There are various solutions that we can use, but I wanted it to do it differently, and hence my problem. So I started thinking about the solution. So my initial plan was, okay, I'll just generate the HTML, the CSS files, I'll copy it to the server, put in probably Nginx, and be done. But then I was thinking, okay, I have been working on Go recently a lot. Why not I try to write my server in Go and serve the files from the file system? So that was a second thought. And then, the lightning, excuse the pun, struck me. And then I thought of the embed package, which slowly and gradually, when it was introduced in Go 1.16, has probably become one of my favorite standard library packages. And so this was what I thought will be the solution to the problem that I created for myself, essentially. So I'll write up my content in Markdown. I'll use Hugo, generate the HTML, CSS, and then I'll write my server, with everything embedded, and then deploy or copy the binary to the virtual machine in the cloud. So this was how my first pass looked like. So I created the new Hugo site. I wrote my content. I generated the HTML and put in a nice theme. Got the HTML and the CSS files, and then I went into, so Hugo by default generates the content into a directory called public. So I go into my, change my directory into public. I initialize a Go module, and then I start coding up my server. So this is the first key aspect of this solution is writing the correct Go embed directives. So here you can see that I have got 3 lines of Go embed directives. I wanted it to be this way so that it's just, one line is not like too long. Of course, I could have put it in 1 line. The key is, of course, the site data variable, which is of type embed.fs, which is essentially, in simple terms, it's creating a file system based on the files that you have given it. And the reason for doing it this way is so that we can then essentially create a handler for this file system that we have created using the http.fileserver and http.fs functions from the net HTTP package. And the rest of it is how you'd usually just normally create a HTTP server. We create a new mux. We then call the listen and serve function, passing in the mux, and that was it. And then I built it. So I built my server using the Go build. Now, and then I SCP my server, which is the binary, to my host. One thing that tripped me off the first time I tried it was I just did exactly what I've written here. But then I realized I'm going to deploy this on a Linux system. But hey, we know that Go makes it very easy. So use the Go OS and the Go Arc environment variables. So I was hosting it on Linux on an ARM64 machine. So I just did the Go build and then copied over the binary once more. And I copied it to this location, which I'm calling local bin practical Go website. Now, the naming will become clear in a bit. And so this is a Linux Red Hat flavored distribution that I'm running. So I create a systemd file because I want this program to be running in the background, and it's a long-lived process, essentially. So this is my systemd file, which is init process on Linux systems, and init manager, sorry. And I'm running it as a user nobody so that it has the least privileges possible. And I'm also setting up the listen address to be 8080. So my server is going to be listening on port 8080. I then create a DNS record and pointed it to the public IP address of my virtual machine. So we have the DNS hooked up with the virtual machine. Now, by default, the DNS HTTPS, I want HTTPS, so that means I need something to be listening on port 443, as well as I need a TLS certificate. Now remember, my website or my server is listening on 8080. Okay, so what do? I bring in Caddy. So I installed Caddy via the repository that the project provided, which meant it was automatically a systemd service. I created this very simple Caddy file, the practicalgobook.net. So that's the DNS record. And then the key part, which is the reverse proxy. So all I'm telling it to do is any request coming into this virtual machine or to Caddy on practicalgobook.net hostname, just reverse proxy back to localhost 8080, which is where I started my Go server with all the embedded data in it. And super easy. I started Caddy, and the right that the certificate was obtained successfully. Okay, and the result is, and this is the big reveal, my new book is coming out sometime this month, and that's called Practical Go, and that's the website I created for it. So that is a problem I created for myself. I do encourage you to check it out. I think a lot of you will find this book useful. Now, okay, going back to the topic of this presentation. So, and then when I do a curl, I can see that the server is Caddy. So it's served by, Caddy, it's confirmed. It's also HTTP2 and it's HTTPS. So awesome. Now, I wanted to improve things. So I did a second pass, and that was a lightning talk driven development. So I created an automated way to create this initial server.go and go.mod. I put it on GitHub. It's the simplest of program you can think of using Go templates. And what I can now do is, instead of having to create the go.mod and server.go manually.
Excellent. Thank you, Joshua. And I agree, the Go Embed package. Thank God. As somebody who has maintained a couple of those embed packages, is definitely, I'm definitely very, very happy with that. So with that said, let's bring up our next speaker. Joshua, are you there?
Yes. Hello.
How you doing?
Yeah, pretty good.
Good. Where are you
Early in the
joining us
morning here.
from?
Melbourne, Australia. So
Okay,
Aussie.
so we got another Australia. Wow, these time zones, we are all over the place today. And you're going to be talking about gRPC, which is something I know nothing about. My business partner loves it. I bow to his knowledge, so I'm very excited to hear another person's take on it. So please take it away.
Yeah. So I'm going to be talking about how to automatically generate a CLI for your gRPC APIs. This was a project that I started and I've been doing it in my spare time, and it seems to be really cool. There's links, and the task that we're going to be doing is we're going to be integrating with the billing CTL proto in Google APIs. So this is just a for people who have used protos before. We have a service definition, we have some methods, and we've got some types. And so all the information that we need to interact with this API is right here. And to begin with, we want to just quickly use this. This is just getting some authentication tokens from the G-Cloud API, because that's what we're going to be integrating with. And the tool, billing CTL, is an example using the library that I wrote. So we can go Cloud Catalog, list services. We can see it's all got autocomplete. We can go page size 20, for example. We can add an authorization header in there. So we can go authorization there, and then auth. And there we go. So we've just called a gRPC API. And so now I'm going to go through how that happened. The basic problem, which my library is trying to solve, is when you start getting a lot of teams with proto gRPC APIs, you start having like a whole repo that looks like this. You have a lot of proto files, or maybe they're across different repositories, but you need people to be able to call it easily. The first solution that comes up is using grp curl. But the problem with using grp curl, for those people that don't know, it's just like curl, and you can call a gRPC API. You can specify the address, but you need to know all this information. So you need to have a piece of documentation side by side, or run some commands on the side. And you can add your authorization headers and then all of your information. So it's difficult to write because you need to know what you're actually integrating with, or what you're calling, and it's a lot to remember. So a better solution to this is using a CLI library like Cobra. And how this would work in an organization is that every team would have their own command that they're responsible for managing. So this makes it easier to interact because you can have things like autocomplete and stuff, but it also means that it's difficult to maintain and every team might have different implementations for their APIs. And so this is where grpctl comes in. What it does is it takes the file descriptors that you see in the generated code. And if we look at this is a piece of generated code that the Google gRPC code generator generates. And it generates this proto reflect.file descriptor file. And what this library does is it takes all the information within that to generate a CLI tool that you can use on your service. And so that's this these string of bytes here, and it has all the information that you need. So if we see a service descriptor, these are things that are sort of contained within a file descriptor. A service descriptor that describes what the service is. a method, and that gets generated to the first level command within the generated CLI. And the method descriptor, which in our proto file looks like this. So get billing account, for example, and that gets generated to the second level. And then the message descriptor gets generated to the flags. So if we can see there, I said page size 20. That has yeah, so that's all generated, and it's really easy to integrate with our CLI tool now. And then what you get is a CLI tool that was really easy to write. We can see that it was only a couple of lines of code. It's customizable, and it can automatically pick up extra information from the proto file. And one of the things that you might be wondering is, like, how does this know where to send the actual request? On the Google APIs, there's this annotation, which is Google API default hosts, and that is set to cloudbilling.googleapis.com. And so if we actually go to billing CTL and go help, the package has actually picked up that piece of information and put it into the defaulted the address string to cloudbilling.googleapis.com. So you don't need to specify like where any of that config would be. Yeah. And as a bonus, there is also a gRPC reflection. So if your gRPC service has reflection enabled, you can dynamically sort of call it. So gRPCTL, I can go address equals localhost 8081, plain text equals true. Click tab. When I press tab, it does the server reflection call, gets all of the proto file descriptors like I was talking about before, but it gets that directly from the API, from the service, and then generates all of the things that we need to be able to call it. And you cannot know you can only know the address, and it'll be really easy for you to integrate as compared to something like proto gRP curl. And so, yeah, that's the link. There's a Gopher Slack, no one's used it. And if you want to see these slides, that's the link there. Cool, thanks.
Well, thank you very much, Joshua. It was a great talk. I really, gRPC, one of my biggest problems with gRPC is kind of exactly what you just said. Everybody's got different implementations. So it's great to see people trying to corral that beast a little bit. Excellent work. So with that said, let's bring up our next speaker. Liam, you there?
Hello, yes, I am here.
Hey, and where are you calling us from?
I'm currently in London, so in the UK.
Fantastic, nice. Fingers crossed, I'm going to be there next week.
Good luck.
If my flights don't get canceled again.
Yes.
They've already been canceled once. So you're going to be talking to us about Go and the Edge, like IoT stuff, right?
Yes, I am.
Oh, fantastic. I love IoT. I know nothing about it, but I love it. Go for it. Let's hear what you got to say.
Okay, hello everybody. It's so great to be here. My name is Liam Hampton, and I'm a cloud advocate at Microsoft. A really quick agenda. So what is TinyGo? Why is it used? What have I made with it personally? And what am I doing next? So let's start with saying, what is TinyGo? It's a Go compiler for small places, as quite rightly stated on the README on the GitHub and tinygo.org. So what does that really mean? It's a subset of libraries from the standard library in the core language package, and it's based on the LLVM compiler infrastructure, which is a collection of modular and reusable compiler and toolchain technologies. Now, hopefully my slide can illustrate this quite well. It is essentially cherry picks a number of really useful libraries from the main language, which you have to have installed prior to having it on your machine, such as IO, bytes, archive, zip. And then it disregards things which are not necessarily seen as important, like HTML templates or the net package. And this is purely because some of the 32-bit boards that you'll be using it on probably won't be using it for that. So let's have a look at the CLI. It looks very, very similar to the Go CLI, very similar commands. So you have build, run, test, just with a few added extras like flash when you want to flash your board, GDB, and so on. It's pretty similar, same from same. What is it used for? Well, people often use it for microcontrollers, and there's about 60 of them. It supports more than 60 microcontrollers. Arduinos, BBC Microbit, Adafruit Playgrounds, and the X9 Pro smartwatch is some of the ones which I've seen used the most. They're really popular boards, and this is just a really fun way to get into IoT if you're a hobbyist like myself. It's also used with WebAssembly. Now, if you're not sure what WebAssembly is, then it is essentially lets you write your code. So in this instance, TinyGo, and pass it through a WASM compiler, which turns it into machine readable code. And then when you go to run the application through the web browser, it runs it, because most web browsers support this. And from that, you get near native performance of your web app, which is fantastic. So where do I personally use TinyGo? I use it on Arduinos. Now, a little sidetrack here. I bought a bunch of Arduinos thinking, cool, I'm going to run some home automation. And boy, was I stuck when it came to coding them, because I didn't know C++ or MicroPython or anything like that. I don't use it in my day-to-day development. I use Golang. So I thought, light bulb moment, let's try and put Golang on a microcontroller, see what I can do. So to prevent my lovely houseplants looking like this, which looks a bit scary, it's dying. In fact, that one's actually dead now. I created something like this. I created a soil moisture sensor. And it takes some calculations. So it takes an input from the plant itself, takes it to the Arduino, does some cool calculations, and then spits out some human readable output for me. That just essentially tells me I need to water my plant when it's getting thirsty. And it helps my plant look like this, which is over my shoulder. It's growing quite nicely behind me. Secondly, another really cool project I've made is a night light. This is taking a photo resistor, and when there's no light, then obviously the lights come on, and when there is light, then the LED lights are off. For those that you want to see the boards, it's just a breadboard, an Arduino with a couple of resistors, few wires, and LEDs. Nothing exciting, but it's the principle behind what you stick in your garden at night with those solar panels on top. The syntax looks really cool. It's exactly the same as Go. So you've got your byte arrays, you've got your slices, you've got ranges. It's all the same syntax. It's really, really fun to get into if you know Go. So what next? What am I going to be creating next with TinyGo? So for my soil moisture sensor, I'm going to be creating something which will let it water itself. So I've asked Santa Claus for a water pump this year. So I'll be able to implement this one and hopefully get that one going. For my nightlight, I am going to be implementing this in a letterbox, and that may seem a bit crazy. However, for context, I live in a block of flats, and in the block of flats, it's a real arduous task to have to keep running downstairs to check the post every day. So to prevent me from running down those stairs every single time I want to check the post, I'm going to be putting something that looks like that in my letterbox. And that will just tell me that when Postman Pat has been and delivered his lovely post, then I will be able to get a notification. And through that, hopefully using MQTT IoT Hub in Azure, I will be able to do just that. And there's a lovely little GIF for you there. Secondly, there is a TinyGo playground. So much like Go, you can just go online, and it's an online emulator. This will let you play with it, sort of choose your hardware, your specifications, write a little bit of code, give it a go, and off you go. I've actually written some pretty complex tasks on here where I have played with multiple boards, creating multiple little loops and lovely LED light shows just for a bit of fun. Like I said, I'm an IoT hobbyist. I don't want to make the same mistakes I did previously where I buy a load of boards, don't know how to code them and stick them on there. So I thought I'd better give this a go. But yeah, I'm an IT hobbyist, and thank you very much for listening to my lightning talk. If you'd like to get in contact, if you'd like to talk to me about this, in fact, if you're going to give this one a go, please do let me know. And you can contact me on Twitter, GitHub, or contact us and watch some meetups through the Microsoft Reactor for my work. and that is a short, sweet lightning talk.
It certainly was. Thank you, Liam.
You're welcome. Thank you very much.
Much appreciated. It was excellent. TinyGo, I still got to play with it. One of the things I miss about GopherCon, not being in person, is Ron Evans and all of his hardware shenanigans, where normally he would have a bunch of people in a room, everybody hands-on playing with stuff, TinyGo. And every year, of course, he tries to kill me with a drone. We all know that. But what you probably don't know is he often tries to get me arrested through TSA. He will routinely give me, and this is the truth, a brown bag full of just wires and capacitors and electronics and just random stuff to take on my plane ride home, just a lunch bag, and I don't know what any of it is. And if I get stopped with a bunch of wires and stuff, I can't explain what they do. And when they say, well, where did you get it? I have to say, well, here's a picture of Ron Evans. This guy gave me these things to take on the plane. So you'd probably never see Mark again. So with that said, let's bring up our fifth speaker here today. Gabriel, are you with us?
How are you doing, Mike? Good?
I'm doing great. How are you doing?
Good too, thanks.
Fantastic. Where are you joining us from?
So I am Brazilian, but today I'm speaking to you from Istanbul, Turkey.
Wow. Awesome. I love Istanbul. I was there, actually, when I first got into Go, I got to spend a weekend in Istanbul with Blake Mizurani and Andrew Garand, who was on the Go team at the time.
Yeah.
And that turned me to Go. So
Awesome.
have a great time. I'm really excited about learning how to write some good unit tests. Go for it.
Thank you so much. So hello, everyone. I am Gabriel Busolo. I'm working for Mercado Livre Brazil. And today I want to speak a bit with you guys about mocking in Go. I started to work on Mercado Livre and working with Go by consequence 6 months ago. And before it, I was working with Java. And when I did this transition, I started to see how things works on Golang and how people are making effort to do things simple. So I didn't saw too much frameworks around it. People doing everything more pure stuff. So even I knew it how to do some things in Java, but it was always surrounded by frameworks. And I started to struggle to do simple things like mocking on Golang. And reading some articles, reading some videos, always missing that enlightenment about the thing. And today I'm trying to bring these things for you guys here. So here I have I have built this API doing some course about Golang and testing. And this API basically is connecting to an API that we have, sorry for this, we have on our company. It's an API that we throw in the country and throwing some information about the country. So basically just have one URL and we have a controller. This controller receives the ID. Going through the service, we have a provider. Get the BR here and you throw to our API. Good. So what is the problem here? The problem is that if I want to write, when I running my test here, let's run here, test. I have a test that I want to actually test a behavior that is breaking it. So country not found. But when I'm running my test, because on Go is too easy to just throw functions everywhere, and basically, like on Java, we are obligated to put classes and always filling with so much things and chunking frameworks. And here we can just throw functions and make things work. So here, when I'm doing my test, it's working. And the problem is that it's going straight to the API and returning. Let's see here. The result, it's returning a 200 on my test that I want, not found. So mocking, it's coming for solve this problem for us. So what we can do here to solve this problem? Because of time, I didn't rewrite code with you guys. I already have here on my master. I will go check out here. So one of the things that we can do to solve this problem is that, like, if we check, let me back for my other branch. as I said before, it's easy to just throw functions and get the results that we want. So before it, I was going straight to a function, and how can I mock this behavior? And the other thing that is different on Golang, it's how to we are dealing with interfaces here. We can do composing with interfaces. It's so easy. You just throw interface here and you implement down it. So it's a bit different for me, who was working with Java before. So here I just wrote the function, and the function is calling another function. So for mocking, one of the strategies that we can have is that, let me do checkout here. It's start work with interfaces. And on my service now, I have an interface that now I have the behavior that I'm expecting from the country, from this service, and making this function now associated to the struct. So now I can implement this interface. And because I have this interface here on my controller, now I'm able to create another struct implementing the same interface. And this is interesting on Golang. Like we can, it's not a bad practice. You implement some stuff like this. So here I implemented an interface. I'll call it mock, and I'm returning a function that I declared here, the type of the function. And when I'm going through my test, now I can, because of this function that I declared here, and I'm using on the function that I'm associate with my mock, I can say the return that I'm expecting. So because of this, now if I run my code, yeah, it starts to pass, because now I can give the behavior that now I can mock my function. So the thing here is not presenting anything new, but for me it was kind of enlightening, you know, like I've been working with chunk frameworks and they are doing all by yourself, and you keep as sometimes not thinking how to do simple things like this, just creating an interface, and I can mock the behavior because now I accomplished the contract of the interface, so I can associate it here, a function which will return the behavior that I want. And now when I'm using the server here through the country, yeah, it's working fine. It's giving the result that I'm expecting, that I'm putting here. So now I'm not connecting with, but here I'm mocking a simple function, and we need to mock HTTPR request. So I would like to give a tip for you guys. I'm learning a lot from this repository here, learning Go with test, and this part of mocking is awesome, enlightening a lot. It's written from, if I'm not wrong, Chris James, and this article is an excellent article, how to create mock HTTP mocking in Golang. It's from Sophie, and this code that I present to you guys, it will be on my GitHub here. Is not yet, I will give push. And if you want to keep in touch, my LinkedIn is here. Thank you so much, guys.
Well, thank you, Gabriel. That was excellent. Yeah, using interfaces and mocks in testing is, you just have to. It's definitely the best way to go about doing it, especially when you start getting into some of the really, really complicated types of things when we talk about HTTP and talking with files and all sorts of stuff. So it was an excellent talk. Thank you, Gabriel, and hopefully others will get that aha moment too. So with that said, talking about aha moments, let's bring up our next speaker, Tom, who's going to talk to us about data science program at Northwestern. Is that right, Tom?
That is right.
Fantastic. And are you in some sort of ionic chamber there? What do you got going on behind you?
I am in a vocal booth.
Okay.
Soundproof, because I live in Glendale, California, as it turns out. But the apartment building has many dog owners.
Oh,
in the middle
yes.
of giving a lecture, and the dogs start barking. So this is where I come to do the Zoom sessions.
Fantastic. I love it. I love it. Well, great. I'm very excited to hear what Northwestern's doing with Go. So please take it away.
Thank you. years ago, when I was a student at Minnesota, that's the home of the Golden Gophers, I learned a lesson about programming in academia. At the start of a course in robust statistics, the professor said, "I don't care what language you use for assignments, as long as you do your own work." I had a facility with Fortran, this is a few years ago, but was teaching myself Pascal, trying to adopt a structured programming approach. Taking the professor at his word, I programmed the first assignment in Pascal, while my classmates used Fortran. The first assignment comes due, I walk my paper, a program listing, to the front of the class and hand it to the professor. He looks at it quizzically and asks, "What's this?" I explain, "It's Pascal. You told us we could program in any language we like, as long as we do our own work." To which the professor says, "Pascal? I don't read Pascal. I only read Fortran." Lesson learned. Academics are not especially open to new programming languages. Data science students today at most universities would have a similar experience if they handed in assignments in Go or Rust or any number of other contemporary languages rather than Python. With machine learning, applications, and AI, Python rules the day. But watch out. Data oceans are choppy. Sharks are approaching. Recall the words of Chief Brody de Quint in the movie Jaws. You're going to need a bigger boat. I would suggest that bigger, faster boat be built with Go. Now, much what I say in the next minute or so is not new to Gophers. Remember that excellent presentation by Carmen Ando in 2017, The Why of Go. Go is machine efficient. It beats languages that are interpreted, as well as languages that depend on virtual machines. Go offers a rich set of tools for concurrent processing. It is well suited to today's multi-core computers. Go is programmer efficient. Python may be touted as easy to learn, but I would argue that Go is easier than Python. Go is simplicity by design, a language with only 25 keywords. It's easy to read, easy to use, and easy to maintain over time. Think of software development as a game of Jenga. We want to address the blocks at the bottom of the stack while ensuring that the entire stack does not collapse. Go lets us do this. And I'm happy that the leaders in the Go community are reluctant to add new features. Donald Knuth had the right idea when he got to version 3.17 of tech. He declared that there would be no new versions, no new features, only bug fixes. And with each bug fix, he would borrow another digit from pi. Changing slowly and carefully promotes programmer efficiency. Keep it simple. Keep it running. And what about that software stack, the infrastructure? When Python, even bolstered by C or C++, is not up to the task, data scientists turn to other languages and systems. Here is a popular so-called solution to Python's performance problems. Data scientists turn to Spark, which is built on Scala, which depends on the Java virtual machine, and to provide easy access, these well-meaning data scientists add PySpark to the mix. Is this the best way to address Python's performance problems? No. Consider a simpler stack. It's Go. Just Go. On the first day of this conference, Daniel Whitenack demonstrated various ways of implementing data science solutions with Go. We can do this today. Companies value safety, simplicity, and the performance of Go. They recognize its strengths. If Go is good enough for Google, Netflix, Uber, Dropbox, PayPal, American Express, Capital One, Salesforce, Zillow, and many others, then Go is good enough for the rest of us. If Go can provide an effective platform for Docker, Kubernetes, Prometheus, Pachyderm, Grafana, CrowdStrike, dgraph, CockroachDB, Aerospike, and a diverse array of distributed solutions and cloud-native microservices, then Go can be an effective platform for building data science applications. Using Go for data science doesn't mean we have to forget good things the R and Python languages provide. We can be multilingual. At Northwestern, we're doing just that. We're using Go along with R and Python. Here's how the 3 languages for data science rank today, according to IEEE. Python, R, and Go are in the top 8. Go is the newest of these languages, trending up and with strong job opportunities. Take note, Gophers. Go plus data science plus data engineering is a winning combination. These are languages, courses that we're using. Go, where we're using Go as a primary language at Northwestern. And today, if you go to a Northwestern professor, you may hear these words. I don't care if you use Go, Python, or R, as long as you do your own work. Organizations need data science, and data science needs Go. We've been doing distance education for more than a decade. Most of our faculty consult with industry or work in industry. They're practicing data scientists. We offer 5 specializations: analytics management, analytics and modeling, data engineering, artificial intelligence, and technology entrepreneurship. Most students hold full-time jobs in industry and study part-time. If you're interested in data science or data engineering, love to learn new things, and want to work with Go, Northwestern is the place to be.
Well, thank you, Tom. That was excellent. If I wasn't already doing a master's program, I might consider it. Thank you so much. It's really great to see Go getting into universities, because I kind of agree with Tom. I think Go is a great first language. I think it's better than Python as a first language because you don't have to deal with the white spacing and the dynamicism. And then again, I might be a little biased. I really like Go, as I'm sure you all do too. I think Go is an excellent first language. So with that said, we have time for one more talk. So let's bring up our next speaker. Mahesh, you there? You're muted currently.
Sorry. Hey, Mark. I'm here.
Hey, how you doing?
I'm doing excellent, Mark.
Great. Where are you joining us from?
I'm from Mumbai, India.
Okay, fantastic. Very, very exciting. We are all over the map in this session here. I love it. We've got people all around the world. And you're going to talk about using Go in the embedded world, correct?
Yes, yes.
Oh,
I'm going
fantastic.
to talk about Go in embedded world. Can you see my screen, Mark?
Absolutely. Yes, you're all set. Take it away.
Thank you. Hello, everyone. I'm going to talk about an interesting topic, Go in embedded world. And I think there are so many presenters already have talked about a lot about how you can use Go in different embedded devices and products. So I'm not going to discuss something very specific to any product. What I'm going to discuss is just a single problem statement. can we use Go as a single technology for both cloud and device-side development? So this particular question came up when I was in a startup a few years back, and we were trying to find a very lean tech stack for both our devices and cloud side. So we were pondering on different languages, and we choose Go over there. Let's talk about it. I'm sure that there will be so many other teams and companies who are also having the same dilemma, whether they can have a single tech stack, which they can use in both dev devices and the cloud side. Now, first of all, is Go a solution? If it is, then why? So as Tom has already told a lot of things about Go, right? I'm not going to tell you why Go is really, awesome language for the cloud side. Multi-core support, easy for multi-threading, faster development, the test framework, inbuilt test framework, error handling, garbage collections, so many stuffs, right? That helps Go make sense for the cloud side development. Now the question is on the embedded side, on the device side, right? First of all, this is a statically linked compiled binaries. The points that I made here is very, crucial for any embedded developer whenever it is finding which language he should use and how that can be helpful. So first of all, statically linked compiled binaries, you don't have to worry about the dependencies, easy to build, and it is only dependent on the kernel, right? The third point is the empty interface equal to void pointer. I put this point, after a lot of thought. So any embedded, developer who is working with C, if you ask him, void pointer is something which he always or mostly use for transferring data from point A to point B, right? It's like really gold for him. Now, what Go provides is an empty interface, which is you can use a void pointer. Not only that, but you can use empty interface or concept of interface to design, provide a pattern to your code so that you can, use or change or support any new changes as quick as possible. How good is that, right? Now, next, two keywords, Go OS and Go Arc. Okay. Now, when I was working with C a couple of years back, the main problem, well, that's one of my demerits is I was not so good at Makefile and C Makefile. So whenever I have to change the platform or wherever I add some new dependencies, I always get stuck there and need a lot of help. The Go provides a beautiful way of creating libraries, creating your executables based on these two keywords, Go OS and Go Arc. Just tell which operating system and which architecture you want to build, and it will build that binary for you as long as it's supported, right? And if we are talking about Go in embedded world, and if we are not talking about TinyGo, it doesn't make sense, right? TinyGo library really makes your life much easier as an embedded developer. Now, as Liam already told us about how easy to use TinyGo and how easy to use this library to create a particular product as quick as possible. Now, on top of that, the thing, I think Liam told us that there are 60 plus microcontroller available in TinyGo. I looked at TinyGo today, it was 70 plus, 71 of microcontroller. So the amount at which the acceleration is happening, the amount of microcontrollers supported in TinyGo is really huge. Not only this, there are so many other libraries are now present, Embed Go, Embedded to Go. There are so many libraries are present, which makes any embedded developer life much easier. But enough of it positive. Let's talk about what is not there in Go. So if you're talking about embedded systems, talking about microcontrollers, you have to think about the advantage that Go brings is that is a garbage collection and how this is a disadvantage for a microcontroller. You may have to tune it down because you don't want your microcontroller to use this garbage collection feature and use its CPU cycle for that. This is something that we need to take care of in the Go. Still, there are some platforms which are not supported. So if you're working on a device which is not supported in Go, then you have to wait or you have to switch to C, right? Now, the third point I added it here to make sure that there are so many critics of Go which says that Go is having a lot of issues with the feature list that they have, and it might not be good suitable for the embedded systems. Absolutely right. Even as per Rob Pike in GopherCon 2014, Go was actually not designed originally for the embedded usage. But look at the timeline after that, the amount of evolution that Go has brought us, it is completely, awesome, and amount of support, the device support, device-side development support that Go has right now, as compared to any other language except C, it's going in a much, much, higher speed. Just to give you how Go looks like as a code as compared to C, this is the same code. This is the same logic that you will need to toggle your LED in a Arduino board with Go. The left side is the Go and the right side is the C. just to tell you how easy to write, how easy to develop the code in Go these days as compared to C. Of course, the people who are in already C, you will definitely have to pull yourself and look into the benefit of Go. But yes, there is an easy way to develop and learn and do. That's Go provides. So Go makes sense. Now, conclusion. Now, before the conclusion is very, can be key here. What we need to do is we need to understand that Go helps to get things done as quick as possible, right? It's easy to develop and easier to, the timeline is very quick. But we have to also remember, which, Tom mentioned it properly, that Go is extremely simple and minimalistic. They don't add features as they should be, and which adds quick learning and helpful in reducing cognitive friction in any developer that you want to build it, right? With the rate at which Go is evolving, it can be a good and maybe only replacement option for C in coming future in embedded world. That's about me, and I think we made a right choice on choosing Go as both cloud and dev side in our project. Hopefully it will be helpful for you. Thank you.
Well, thank you very much, Mahesh. That was wonderful. We've come to the end of yet another set of GopherCon Lightning Talks, and it's been, for me, it's just been a wonderful week. We've seen almost 24 new speakers present some great new concepts, some new ideas, and definitely gave me a lot to think about, and I hope you as well. I hope you've enjoyed all the programming at GopherCon this week, but in particular, I obviously hope you've enjoyed the Lightning Talks, and I really hope to see you all in person next year. Well, my Gopher buddy and I hope to see you in person next year at the real GopherCon, and maybe I get to shake your hand and introduce you in person at the Lightning Talks. With that said, we still have a little bit more programming left at GopherCon, so enjoy it, and I'll see you next year. Thanks a lot. Back to the studio.
Thanks to all of the amazing presenters for the Lightning Talks this week. It takes a lot of courage to kind of get up there and to try to, reduce a complicated topic down to 7 minutes. And there's such a wide spectrum of topics that we always see in these Lightning Talks. So it becomes a really, important part of the conference and one of my favorite things to see.
Yeah.
We can't thank Mark enough for putting all of that stuff to, well, I take that back. We can thank Mark enough. This would be like 6 times.
This is it.
He's going to start to think we like him or something.
No more for you. No.
So, and also like geographically, how spread out everybody is,
Yeah, I mean, we had at least North America, Europe. I think we had Africa. I don't know. I'm sure we had plenty
India.
more. We just had India as well. Yeah. So that's, I mean,
We
that's
global.
impressive.
We're global.
We are. Yeah, definitely. And then just the quality of the talks too. It's just, like we got 7 minutes and then 7 minutes and 7, and every single one of these talks is jam-packed with just really good content. Yeah. Speaking of thanking folks, we should take a minute. I want to thank Microsoft and Capital One for helping us take this thing virtual on relatively short notice, I would say. So thanks to them, and thanks to Salesforce as well, excuse me. They're providing the captioning for the conference too. So all those captions you see, you can thank the Salesforce engineering team for that. And speaking of the sponsors as well, let's bring it in. I'm the VMS guy, the virtual sessions guy today. Bring it in real close. We've got open source security and action from Praetorian. They're going to talk about that go-kart package that we had them on. Yep. We've got more Q&A with the Course Hero talent team, so check them out. And then we've got more AMA from the Microsoft team. So it's called Gophers of Microsoft, Go Projects Ask Me Anything session. So do check those out. Reminder that you need a ticket. The tickets are free, but you do need to go register on the GopherCon.com website to go to those sessions.
Yeah, and if you've not found it in the last 2 days, you can go under the GopherCon.com/agenda, and that's where you'll actually see the ones that are coming up pop up in the top. If not, you can scroll down through the schedule for the start times.
Yep.
Again, feel free to also interact with our sponsors in the Discord. Many of them are hanging out. Most of them are all hiring, so if you're in the market for a new job, this is the perfect opportunity to reach out and meet some of the engineers and folks that work at these companies that you may be considering applying for.
And they all write Go. Surprise, surprise. So some might write Rust. I don't know. You're gonna have to talk to Erik for that, but you know
they're here to steal the couple of Rust people.
Yeah, they came to GopherCon to find Rust engineers and Go engineers. So check them out. Do check them out.
But where are the people writing Pony and Nim?
You know, we're down the Rust rabbit hole, and now we're into Zig, Nim, and Pony. I don't know what to do with you, man.
Next time we're gonna talk about brain. Shut.
It's like, ooh, shiny.
Caught myself there.
Yeah, you did.
Yeah. So I have a question for y'all. How do you debug? Are you old school, like print line, you know, or do you go full on IDE?
It depends on what language or technology I'm using, because in some cases the debug tools are pretty good, and you know, I can use GDB, or I'm not typically an IDE person, so that's not usually the way I step through stuff. But you know, if things have good support in GDB, I'll use something like that.
I just write perfect code.
If it's quick, I just print lines. But yeah, again, I just
and some would say you're like a caveman. You're putting print statements. Got here, like a peasant.
But what do you do? What do you do if it's a complex problem and you've got to delve into the solution?
Oh my goodness! Yeah, your likability just shot up despite the T-shirt.
Here we go, screenshot time again.
But yeah, so we always like to hear more talks about delve and debugging and DAP and all these cool innovations. And Susie, just give a nice deep dive into some of that stuff. So up next, we have Mr. Sam Kamenetz, who's going to dive a little deeper, right? Show us the how and the whys behind using a delve.
How we can be a power user.
Yeah, power users, and not just using print statements everywhere. Well, I'd use print statements. I think it's okay.
Right tool for the job,
Right tool for the job. Yeah. Sometimes you do need a got here.
Yeah.
It's okay. It's like JavaScript.
Yeah.
That's the only.
Hopefully, though, we'll learn a little bit more how to get into delve so that we don't always have to do a print statement. We can have another tool for our toolbox.
Yeah, let's hear it from Sam Kamenetz. Take it away.
Hi, I'm Sam Kamenetz. I'm a software engineer at Bread, and I love using debuggers. And I'll candidly admit, it took me a long time to figure out how to use Delve, Go's debugger. Debugging a Hello World application was easy enough, but I got flustered by more complicated setups I encountered in my day-to-day job, like debugging a test or debugging a Dockerized application. So I learned how to configure a debugger for almost every scenario. In this talk, I'm going to demo all variety of debug configurations, as well as how to reason about them so you can become a debugging expert. I'll be talking about VS Code's debugging features as well. Now, this talk isn't just for debugger enthusiasts, it's also for the debugger skeptical. For all of you, my pitch is this. Setting up a debugger requires understanding the nuances of how the debugger, project, and IDE interact. And it can feel like too much work to set it up while you're hunting down a bug. But here's the thing. It's a time investment, but it's a one-time investment. Once you configure your tooling, you can debug at will, even at the press of a button, and from there, it's really just setting breakpoints. Before we get into the how of the setup, I want to show you how awesome debuggers can be. It's easier to make the pitch when you're actually excited about what debuggers can do for you. First, debugging without a debugger can get a little mind-numbing, especially when you're in what I like to call the tweak, build, run loop. So you ever find yourself writing code like this, just a bunch of logging and prints, adding a new one each time you compile? Obviously, debuggers help avoid this, but they can also do a lot more than that. I think that one issue is that most people don't even know everything you can do with a debugger. So here's just a few use cases. Say you have a function that's called in many places, and you aren't sure what call chain represents the error case. You can inspect the call stack with a debugger. If a test is failing, you can launch a debugger against the test itself. Say that's running fine locally, but you're having issues in the Docker container. You can launch the debugger as part of the container. Let's say you're getting an unexpected nil pointer dereference. You can just set breakpoints and watch the value mutate as execution proceeds. All right, so everyone's familiar with the basic debug operations of setting a breakpoint and running to hit it. What you might not necessarily be familiar with, though, is that when you're using a GUI debugger, you get access to all of your local variables and you can see them updating in real time. Also, you have access to the call stack where you can see each of our Go routines, and currently the one that we're paused in, and see that we're currently in the playground function, which was called by main. So suppose for a minute, though, that you didn't particularly care about seeing all your local variables, but you wanted to focus on one. This is where our watch window comes in. So let's go ahead and just focus on one expression. Let's go ahead and keep on watching I. And now as we run through, we can watch that update again and again as we go through a loop. But suppose that we want to have things run a little faster. So let's go ahead and set a conditional breakpoint. And we'll say the condition is, I mod 10 is equal to 0. And let's also add a log point where we'll just say, hello world. So let's see that in action. So as you can see, we're incrementing by 10 each time in our watch window. And when we go ahead and look at our debug console, you'll see that each time we run, we're hitting hello world 10 times and incrementing the same amount. So that's pretty cool. Suppose that you wanted to run a debugger, but not by typing in all these commands at once or clicking around. Well, you can use something called debug scripts. And you can see here we have just a simple text file populated with basic commands that you would enter into the command line debugger. And it's pretty analogous to our previous example. So we're setting a breakpoint B1, trace point T1, and we'll go ahead and setting so we're only hitting B1 every 10th time and printing I each time we do that. We continue a bunch, then we set I back to 0 and see what happens there. So let's see this in action. So that was kind of a blink and you'll miss it situation. So let's go ahead and see what we're doing. So you can see right away that we're setting our breakpoints and we're hitting our trace point T1, and that's just printing out the name of the function that we're in each time we go through. Finally, we pause when I is equal to 9. And you can see our printout of not only the value of 9 of I, as well as our source code. So we go ahead and do that, and you can see that we're incrementing by 10 each time until finally we get to 59, in which case we set I back to 0. And then the next time we run, I is equal to 10. So suppose that you want to launch a Docker container and then also debug it all in the same click. Well, you can do that too. Observe. You can see that we're starting our command right here. Flipping to orange indicates that we are good to go. Let's set a breakpoint and run from here. And of course, in the words of Dr. Facilier from Princess and the Frog, there are things I haven't even tried. Namely, RR debugger integration, which lets you rewind execution of code. There is a native debugger adapter protocol support built into the most recent version of Delve. I'll unpack what that means later on. And then I showed you earlier in the demo that there are debug scripts. One of the features of Delve is that you can use Starlark, which is a dialect of Python, to enrich your debug scripts. Full disclosure, I never heard of Starlark until I started digging into Delve's documents. Safe to say, debuggers are very, very useful and make your life easier. My goal is to show you what Delve can do, and how you can set it up for yourself. For each scenario, I'm going to show you how to launch Delve as a command line application, and then show you how the same configuration works when run through VS Code's GUI debugger. So, why use the CLI? Well, even if it's not the most ergonomic way to run a debugger, it's a really good basis for understanding the commands before we introduce layers of our tooling. My approach is to start simple and work up from there. And you also might be wondering why we're using VS Code. Well, VS Code is ideal because it's a common tool that's highly configurable and has robust debugging capabilities. A lot of my coworkers like using JetBrains Golang IDE since debugging usually, an emphasis on usually, works out of the box. I prefer VS Code in general and for debugging because the debug settings are much more flexible. There's some really cool things you can do with it, and it's also really easily portable. For instance, you can include the debug configurations as part of the version control. We'll touch on that more later. Oh, and one programming note, if you'll pardon the pun. If you have VS Code, the Go extension Delve, you can pull my repo, the one that I'm demoing right now, and follow along. On to our first demo. Let's start with a simple web server running locally. Okay, a couple things to point out here. Just for convenience, I'm printing out the first part of the Delve debug help command, and then the actual payload is on line number 2 here, where we're running the actual Delve debug command, and then we're separating the debugger commands from program arguments with this double dash right here. Side note, you're going to see this a lot in all my examples where we're setting this environmental variable and then also including this program argument because my program requires that. Also, I'm using makefiles because you should never remember something that you can make a computer remember for you. If you're not familiar with makefiles, you can think of this as just a collection of very short bash scripts that each have an alias within all one file. Very convenient, especially when you're setting up debugger stuff. So let's go ahead and actually see this in action. All right, so we've launched our debugger, and once it's ready, we'll see the interactive Delve prompt. Let's go ahead and set our breakpoint on line 25. And then we'll continue. And then you'll actually see where we're requiring that environmental variable and our program argument. All right, so now that we figured out how to run that in the CLI, let's talk about how we run the same example, but in VS Code. So, quick side note, I'm not going to invest time in showing you how to set up VS Code or the VS Code Go extension or Delve. There are plenty of guides online that can teach you how to do that. Instead, I'm going to focus on our launch.json here. If you're new to VS Code and you're not quite sure what a launch.json is, you can think of this as basically every run configuration that we've specified here. So every JSON blob is represented here as an item in this drop-down menu. And each of these is a different run configuration that launches our debugger with a different set of parameters. Now, the best way to understand how to use a launch.json is by referencing the official docs, namely for VS Code and for the VS Go extension. These pages were largely how I built this demo. First attribute here is the name, which corresponds directly to the name that we see in the drop-down menu right here. Type refers to the language and tools that we're using. We also have a request for every configuration. This can be launch or attach. I'm going to touch on that later. We have mode, which corresponds almost directly to the equivalent command line invocation. Program specifies the working directory where you can find the source codes and the executable. Here we're using a special VS Code variable workspace folder, which maps to the current folder that you're working in as part of your editor. We specify stop on entry, meaning that we stop right at the top of program execution, so we can then set up breakpoints and then resume execution. Finally, we have the somewhat self-explanatory args, which are our program args, and then
setting environmental variables for the duration of the run of the debugger. So let's go ahead and see this all in action. We hit the plus button, and then we go over here. We can set our breakpoint. And there you go. So let's go ahead and now run this. So we're going to go ahead and set our breakpoint right here. And also, just to illustrate a future point, I'm going to set a breakpoint right here. So we hit our breakpoint. We're running now. And let's go ahead and actually activate our server. Host 8080 ping. And you'll see as we hit this root, the editor actually retakes focus as well as stopping at the breakpoint, which is pretty cool.
Now, suppose you want to figure out why a test is broken. Well, Delve can do that too.
Actually, going ahead and looking at this, it's pretty simple. The only real difference is that we're setting mode to test, again, analogous to our delve test command. And then for program, rather than just specifying the workplace folder, we're then additionally specifying the subdirectory sum package. So let's go ahead and see that run. Looking at a launch.json configs for this, there's actually not a whole ton happening here. As you can see, everything's the same except for we're running mode test corresponding to delve test. And then for program, we're specifying rather than the workspace folder, we're specifying its subdirectory sum package because that contains the test that we want to run. So let's go ahead to sumpackage.test, set a breakpoint right there, and we'll run, and we'll hit it right then and there. And you can see this testing object and all of its nested structs.
So earlier in the demo, you saw me using logging points. That's analogous to the functionality of Delve's tracepoint, which is a breakpoint that doesn't stop execution but logs to standard out. So you can activate trace mode in Delve, meaning every function matching a regex will have tracing, but execution will not be stopped.
So again, looking at this command, pretty basic. The two differences being that we're saying delve trace, and then we're specifying a regex for all the functions that we want to call. In this case, we're really going to just be calling getMessage as part of the trace program. So let's go ahead and see this run. And remember that trace doesn't actually stop execution. It just sets trace points at all the designated functions. So when we go ahead and run curl localhost 8080, we're going to get a response. And here, in addition to our gin logs and our console.out, we are going to also see these go routines, get message. This is part of our trace point. So you'll notice that I actually do not have a debug configuration for number 3 because there is no direct equivalent in VS Code's functionality for the delve trace command. However, you can mimic that with something I showed you earlier, which are VS Code's log points, which more or less map to the functionality as a trace point. So let's go ahead. We'll run our original example here. But rather than that, we're going to set breakpoint here, and we're going to add a log message right here, and we're going to say example 3. So we run, and then when we run again, we're going to see example 3 show up in the debug console. And there you go.
Before we go into more complicated examples, let's talk about how debuggers work. The correct mental model will help you reason about configuring your debugger. Now, I'm stealing this slide from Alessandro Arzili's 2018 Gopher talk about the internal architecture of Delve. His talk goes into full detail of the architecture, but The gist is that Delve contains a client representing the UI and its service layer, and then a server which maps the symbols of the program to memory addresses and manipulates execution of the program itself. This separation is what allows us to support running a debugger on, say, a different machine, be it a remote server or container, as well as connecting to different UIs. When we use Delve via VS Code, a debug adapter, which ships with the VS Code Go extension using the DAP, or Debug Adapter Protocol, allows the IDE to serve as the new front end instead of the CLI interface. It uses the UI actions that are standard to VS Code and converts them into RPC requests to the server. It also handles launching the server process, for instance, launching the debug server via the headless option. The newest versions, which must be opted into, natively support the DAP and require no separate adapter. Now that we understand the client-server model, let's try attaching Delve to an already running program.
So you can see that I have defined this somewhat verbose command, but this is really just building our executable. One thing I want to point out here is our GC flags. And what this is specifying is that we are building, the N signifies we're building without compiler optimizations, and then the -L signifies that we're running without inlining, both of which are compiler-based optimizations that can interfere with how the debugger actually interacts with our running program. So let's go ahead and see what else we need to do. We have our make dry run, which is pretty basic. We're just running that build executable with our environmental variable and our program argument. And then we're going to do make debug patch. And simply what we're doing here is we're just printing out the PID based off the executable name. And then we're running the delve attach with no arguments. All right, so let's go see this running in action. First we're building, then we run. Now let's go ahead over here and actually attach to our running program. Okay, so we're in the debugger. I'm going to go ahead and set a breakpoint on line 8. And since we're broke at startup, we're going to say continue. So now we're freely running. And let's go ahead and curl our endpoint here. You can see now that we've broken in the actual function. And now after we resume, we see that we get our message back. Okay, so let's go ahead and talk about this launch.json configuration. So you'll notice here that we're running a request hatch instead of launch. Now that you've seen a few examples, I want you to think of launch as basically saying this debugger command is effectively starting the process that will also be debugged, versus attach is much like running on a train and jumping onto it, simply attaching to an already running process or already running debug configuration. Finally, we also have to specify a process name that we're connecting to. Here, instead of using a randomly generated process ID, we can just give it the name of the process itself. So let's go ahead and run this. So we're now running our debug executable. And now in our VS Code window, we can go ahead and actually attach to it now. So I believe we should be able to go into package, set a breakpoint, and then we go ahead and curl, and then we hit it.
Now, let's debug with a separate debug client and server. You can think of this as debugging a program on another machine. This isn't a scenario that I encountered much as a backend software engineer, but when I was writing embedded software, we'd load the application onto our custom hardware in a different building and launch the debugger against that. Even if the use case might be a bit special case, it's a good stepping stone to our most complicated example, debugging a Dockerized application.
Okay, so there's a few flags here that I want to call your attention to. First off is this accept multi-client. Basically, this allows multiple clients to connect to the same debug server instance, which makes it easier for us to actually disconnect and reconnect to the process. Then we have headless, meaning that we are launching just the debug server, waiting for a client to connect to it, rather than launching both the client and the server in the same process as we were doing previously. Finally, we're specifying a listen, localhost 40,000, just to make it deterministic as opposed to listening on a random port. And we're specifying API version 2 because my command line version of Delve runs by default on version 1, but this allows it to use VS Code client, which is running the API version 2. So let's go ahead and look at the command that we're actually using to connect to this debug server. And as you can see, we're doing delve connect localhost 40,000, specifying that we are attaching at the exact address that we specified for our listen. So let's go ahead and see this in action. Okay, so now we are listening. And let's go ahead and say make debug connect. Now we're connected on port 40,000. So let's go ahead and set a breakpoint at some package. Let's just make sure that we're continuing. And then let's go ahead and curl localhost 80 ping. And you can see that we've hit our favorite message. All right, so looking at this, you'll notice the key difference is that in our launching against a running process, we were in mode local, but here we're in mode remote. And basically that's just for when we're in the attached configuration. That's toggle from looking from a process ID to a host and port to connect to. So, and you can see right here, we're also specifying the same host and port that we're expecting to find our debug server. So let's launch this by first running our debug server. Looks like we're up and running there. And we're on example 5, launch against server. Okay, so now that we're running, we'll set this breakpoint. Here we're going to curl localhost 8080, and we are able to hit our debugger. Pretty cool.
This is actually returning to the first example I showed. Debugging a Docker container is probably the configuration that requires the most steps and knowledge. Luckily, we've built up to this point. I'm also showing how to set up pre-launch tasks in VS Code, which is critical to automating setup for many debug configurations.
Okay, so the first thing that we're going to want to do is actually take our Docker file and modify it so it supports debugging. There are two elements I really want to focus on here. First, you have to add this go get delve command, so the actual Golang image has access to the delve executable. The next thing that you should focus on is that we are using CMD. Now in Docker files, remember that entry points cannot be overwritten when you're doing Docker run. CMD executes when you do Docker run, but can be optionally overwritten with a new run command when you're actually invoking Docker run. Now, if this solution feels kind of ugly to you, you can always just make another Docker file and call it Dockerfile debug and run that instead. So as you can see, this is just a fairly bog standard Docker build command, just specifying the name of the image that we're building. So let's go ahead and just execute that. And since we're cached, it builds right away. So let's actually take a look at the command that we need to actually run and invoke the Docker container. So there's a lot going on here right now, and it's kind of hard to read in the format. So let's go to the slide for this.
The first line is how we are running the Docker container, and the second one is the command we are launching with. Remember, we are overriding the CMD that runs by default for this container. For those of you that aren't super familiar with Docker, we built our container, and now we're running it. We're exposing port 40,000, meaning it's reachable outside the Docker container, and then via the publish flag, mapping the container's port 40,000 to the host machine's port 40,000. We could also expose it within the Docker file as well.
Okay, so now that we've already built our Docker image, let's go ahead and run that as a container. All right, that's looking good to me. Let's flip over and then connect to that. We'll go ahead and set a breakpoint right here. We'll continue, and then we'll just go ahead and ping, check back in our debugger window, and you'll see that we've hit our breakpoint as expected, and we're back in the prompt. However, the source code isn't loading. Now, this originally caused me a lot of consternation, but simply put, after debugging a bunch, I realized that the root of the issue is that because there was a mismatch between the paths on my local machine and on the paths on the remote Docker file. So the Docker file has everything under the /app, and locally everything is under my Go source, so on and so forth. This is where keeping the client in server model really comes in handy, but since the paths don't match up, we aren't able to find that file, and hence why we're getting the no such file or directory right here. All right, so let's go ahead and open up our hidden delve configuration file. In addition to a lot of other things that you configure, what we want to focus on here is the substitute path. And remember that this is just mapping the source code that is configured within the actual Docker container to what's on our local machine. And this is from the perspective of the debug server. So the from is actually in the Docker image itself, and the to is where our client is on our local machine. So let's go ahead and uncomment this. With our configuration changed, let's go ahead and rerun the debug server. All right, and let's go ahead and connect to that. Now we will go ahead and set a breakpoint. And with the proper configuration, we are now able to actually see our source code in the debugger. Let's break down this part of the run configuration. This one is really based off of our connecting to a debug server, because conceptually it's really similar, just with some of the nuances of it actually running in a Docker container. The two things that I'm going to point out that are different are, first off, I'm using the substitute path, which is essentially exactly the same as what we did in our delve configuration. However, the from is actually our local path, and then the to is to the remote path. Because remember, this is from the perspective of the client debugger instead of the server this time around. The other thing that's happening here is that we have a pre-launch task, which basically is running our Docker image for us. We're going to touch on this in just a little bit and break that down. That lives in task.json. Then, of course, we have our stop on entry. And then we have these two commands, show log and trace. Basically, both of these are what I use to get logs from the debugger itself to help troubleshoot this issue when I first encountered it This is a great step if anything's acting kind of wonky with the debugger in general. Okay, so let's go ahead and run and debug this Docker container. Now, you'll actually notice this is the example that I showed you at the beginning of this talk. Something I'd like to point out is that we've actually waited for the API server to start listening before the debugger actually launches.
So you saw in the last example that we were able to run the Docker container and start the debugger all in one click. That's thanks to the magic of tasks. So for context, VS Code allows you to define arbitrary tasks. Normally these are used for configuring file watchers or linters or other such tooling. They live in your project's task.json if you've defined any task. Since we aren't setting up one of those tools, the configuration can be a little hard to follow. Namely, it expects a pattern of files and regexes to trigger, so we have to fill in dummy values for this. And remember, we are invoking this as part of the debugger.
Okay, so this is our task.json file, and we're looking at the task that gets launched as part of our debug Docker launch configuration. So the command to define is actually pretty simple. This is just what you would type into the shell. Where it gets a little bit more complicated is that since this command doesn't technically halt on its own, it has to be manually halted, we have to specify it is a background task. Further, we have to specify at what point that VS Code can stop waiting for this to finish and then go ahead and launch the debugger. So here I've defined this in this background object where we're saying that once we see the pattern appear in the terminal API server listening at, we are good to go ahead and launch the debugger. Mastering the task.json can be a little tricky, but it's the key to becoming a VS Code and Delve power user.
I'm hoping you feel empowered to set up debuggers for your most common Go repos. You'll have to rely on the manuals to build that launch.json, the manuals being VS Code docs and the Go extension docs. Specifically the bits about configuring the launch.json. You'll also have to rely on a bit of trial and error. The setup can be a hassle, but once you make that launch.json file and lock it into your repo, you are set for your whole team. I've already touched on some extra mile things you can do there, like pre-launch tasks and debug scripts, so go out there, give everyone on your team a new tool in their tool belt.
Use Delve and how to become a power user with Delve and tools like it. So, what do we have?
I love sessions that kind of go into kind of day two things, right?
Mm-hmm.
You know, because we watch and read so much content that like assumes happy path and like, you know.
Mm-hmm. And it's cool, you know, we've seen DApp now, we've seen integrations with the VS Code Go plugin, and Susie showed us all that. She showed us integrations with possibly the best editor out there, Vim. Have we landed on that?
No, I think it's confirmed. Yeah,
okay.
It's confirmed.
There's not been enough people in Discord to say anything.
To say otherwise.
Yeah.
Emacs, so it's got to be Vim, right?
Yep, it is. Yep.
So I got yelled at for doing a Vim joke, but I'm going to do another one.
Yes, do another one.
This is how good I think Vim is. I still have it open. But yeah, you know, we saw that
the last time.
I know, right?
Second time it was going to be better. Thought I'd maybe get some laughs. That's okay. Yeah, but you know, when we in this, in the same conference now, we've got the deep dive into the underlying tools that power those experiences, which is really great to see. You know, if we need to, if your VS Code or your Vim isn't working, you can dive down and use the tool directly, which is really nice. Yeah.
Indeed.
So, we've got an interview.
Yeah, and I mean, speaking of the fact that everybody assumes happy path and things like that, right?
Yeah. You know, we've talked a bit about, code gen, we've talked a bit about gRPC and protobufs, and, the thing that a lot of people see in the day one, as to use that kind of parlance, is this stuff is not too hard to get started. You follow some instructions, there are quite a few steps, but if you follow them, you'll get it up and running. You'll get your gRPC service, serving possibly even on the internet, put it behind a load balancer, whatever. But then, yeah, there you have it. The day two is, how do you evolve the schema and plenty of other things there.
And there's lots of complications that come into it.
Oh yeah, oh yeah. And so we've got Alex McKinney from Buff here to talk to us a little bit about those complications, talk to us a little bit about this kind of stuff. So I'm going to put in the old earbud, and we'll see if we can get him on the line. So Alex, are you here?
Yes, can you hear me?
I can, yeah.
Great.
So yeah, tell us a little bit about these day 2 kind of things, the difficulties that
what are
we
some
might
other
face.
considerations once we've kind of generated our code for this? Like, what are other considerations when we go to deploy this? What are some other things we should think about and problems?
Right. Yeah. So I think you hit it right on the head with the simplicity of getting going. Like on the day 1, there are a ton of tutorials out there. As generating code is easy with Proto-C at the beginning, but then when you get to day 2 and you start making changes to those APIs, you start to understand that the Proto-C compiler, or the protocol buffer compiler itself, which is the default encoding used by gRPC, is very complex. There's a huge onslaught of different configuration options, both tied to the protobuf schema itself, as well as how you invoke the compiler. A lot of nuanced behaviors, and unfortunately, there's also a lot of undocumented compiler options. But even once you start to get acquainted with some of those things, complexity involved with like the Go package file option, or modifier flags, if you're familiar with those things, you still fall susceptible to some of these issues with, hey, as soon as I need to use some of these protobuf files from common dependencies, like Google APIs is a common one that is kind of baked into the gRPC Go library for things like the RPC status type, which is used for the gRPC error codes and so on. Once you start to use these things, you start to understand, like, okay, now I'm depending on these files from external sources. How can I make sure that my copy doesn't drift between, the one that's published via Google APIs? They do this by publishing SDKs and generating them themselves in a GitHub repository, but a lot of these issues are not solved with regard to the general community. And they still struggle from this problem of tying the protobuf schema itself to a certain representation of that generated code by kind of abusing the Go package in that way. So Buff solves that firsthand just by saying, hey, we're going to provide dependency management for you so that you can just specify the dependencies very similar to what you're used to with a Go mod. Like, you can just require different dependencies and they're included in your module. So we've similarly created a protobuf module that's very analogous to what you're familiar with a Go module. Then beyond that, we have a ton of cool, specifically tailored features for Go, including one that I'm particularly a fan of, referred to as managed mode. So this problem I was talking about of tying a file option to the schema itself means that that schema is no longer portable across different environments. It's no longer usable from one organization to the next. This is actually something I went over in the Buff Helps You Go Faster talk, but it goes into detail of saying, hey, this Go package is tailored to my GitHub repository, and as soon as somebody else needs to use that API definition to generate their own gRPC client, they have to hand edit it themselves. And then that just, again, you're back to that API drift problem. But what managed mode does, it actually will set these options for you at generation time. So you can remove the file options entirely and leave it to a compiler like Buff to set it at runtime, which is not runtime of your application, but runtime of when the code generator is invoked. And what this does is it makes your APIs more pure. It makes it not tied to consumer level concerns, because these are consumer level concerns. I want to generate with respect to what I need from the API and my annotations and my custom options, not necessarily someone else's decision. But beyond that, this still has all the issues of, okay, fine, I've installed Proto-C Gen Go, Proto-C Gen Go gRPC locally. I can invoke these plugins and get some generated files, but you're still at odds with, the versions I have locally on my machine could be different than my peers. So you build a bunch of custom tooling, you use a build system to ensure this, but those struggles still exist when you cross that boundary, when you're referring to your customers or your clients that are generating code for a client that they don't own. So what we do now is actually we let the community publish their own protobuf plugins, which i.e. is, Proto-Cgen, Go, and etc., to the BSR, which is our buff schema registry. It holds all of the API definitions with regard to your protobuf modules, the thing kind of analogous to Go modules. And once you have both your API definitions there, versioned logically together, now I can invoke these plugins that are also versioned according to similar semantic versioning that we're all used to with, GitHub repositories and so on. But now I can execute those plugins on my behalf, but on the server side in a secure sandbox. We actually have kind of homegrown our own technology around that using gvisor, so we can ensure security for all of those things being executed on our servers. And then, so that alone is already so much better than where we were even just moments ago. And then finally, the last thing I want to really stitch on, because I know it's super exciting to the Go community, is using all that technology, we were able to build a Go module proxy that you remove all your concerns about Go code generation, and all you do is go get a library that immediately gives you the Go gRPC clients and servers associated with the API that you've published to the BSR. And again, that's really only the beginning.
That's very slick. It kind of sounds like a pretty big leap forward, because I think a lot of
these things I didn't even really kind of think about. Like, I mean, I haven't really thought about how to solve these problems, but they are things we've ran into, like how to manage versions between these things and how to share protocol buffers between services.
We're in the Stone Age. We're just copying .proto files from the Google or from someone else's.
So many people are doing this across everywhere. Everyone's reinventing the wheel, trying to come up with these solutions and kind of leaning on GitHub repositories as, okay, let's use this as a source of truth. Then all the tooling you have to build to get that to be a good experience. So many companies are just doing this repetitively, and we're trying to solve it once and for all.
Great. I mean, I wish we could talk about this for a couple more hours. I mean, there's so much meat here. So I mean, thank you so much, Alex. This has been, although short, it's been a really fulfilling and awesome and interesting conversation.
Great. We look forward to see you in our Slack channel, or check out the documentation at docs.buff.build, and give it a shot.
Thanks so much, Alex.
Thanks, Alex.
Cool. Thank you.
So we've got some VMSs and we've got a talk coming up. So what do we got?
Yes, so coming up next, we're going to be talking to Kevin Dangoor from Khan Academy about migrating big Python monolithic applications to services written in Go. So Kevin, take it away.
Hi, I'm Kevin Dangoor, and I'm going to be talking about Khan Academy's journey from a big Python monolith to Go services. It's going to be a tale in 3 parts because I have a lot of stuff to cover. And I'm going to be talking about why we did it, how we did it in terms of the technology, and how we did it in terms of the project. And so that means I'm going to be talking about Python, Go, Google Cloud, GraphQL, code generators, and burn down charts. All of this in a 25-minute talk. So before I get into that, I do need to talk about what Khan Academy is, because not everybody has seen our site. If you haven't, check it out. We are an education nonprofit. We have a mission to provide a free, world-class education to anyone, anywhere. We have many thousands of videos, articles, and exercises about a bunch of topics, and millions of learners come to us every month to learn on our site. So when we first started talking about this rewrite publicly, we did get some feedback with people wondering why we had so much code. Turns out there's a good reason. We have a lot of features. And people don't always see these features because they're not always target users of those features. So keeping track of learner progress is something every user sees, because they'll see how far they've progressed in their skills and which skills they need to level up on. But we also have login with Clever and use with Google Classroom, because working with classrooms is important to us because we are used as a supplemental resource in many classes already. We also provide reporting for school districts. We connect with the College Board for SAT prep. We have a content management system to manage all that content that I was talking about, and also to work with translators who around the world who have translated Khan Academy to dozens of languages. So there is a whole bunch we have here, and that's why we have so much code. That's why our rewrite is not an easy project. So why did we have to do it? So to answer that question, we need to go back in time to 2010. And in 2010, Python 3 was still very new. It was actually less than a year and a half old. It was around a year and a half old, I think, at about the time of this commit that you see here. And that's that's not very old. Most of the libraries hadn't converted yet. There wasn't much available for Python 3. Plus, Google App Engine was also pretty new on the scene at the time. There wasn't much in the way of serverless architecture back then, providing both scalable web layer and scalable data layer, but App Engine provided that. And that stack actually served us really well. It did scale quite well as we added new users, as we added new features. That worked great for us. But the Python Software Foundation said January 1, 2020 was the end of life of Python 2. And so we knew we had to get off, we had to move, and we had to figure out what to do. To make matters more interesting for us, Google in August 2018 introduced App Engine's second generation. Now this was actually, I think, a really big improvement to App Engine, because what it meant is that all of these bundled APIs that App Engine first generation offered have been unbundled in App Engine second generation. So an App Engine second generation app looks like any old web app, but you get to pick and choose which APIs you use from the whole suite of Google Cloud. It was a big improvement, but it also meant a lot of change for our code. Finally, I will mention that because we were running an App Engine monolith, that meant that all of our instances were running the same code. So if we wanted to be able to move to something else, including Python 3, that meant that we had to effectively adopt a services architecture, at least for one more service, which would be the new one. And that adds a whole lot of complexity to our system. And so we had to think about what kind of architecture we wanted to go forward to. And as we thought about it, we did some rough estimates, and we figured out that moving from Python 2 to Python 3 is a lot of work. Moving to a different language is probably going to be about 50% more work. So that's a significant amount, but we thought we could get significant benefits from doing it. Things like performance. We like some of the tooling available. Memory usage. All these things could be better. And runtime performance does matter a lot to us. So we looked at Python 3. We also looked at Kotlin, which we had some experience with. And we also looked at Go. And I probably don't need to convince you all that Go was a great choice for us. It has performed really well for us. The tooling has been great, and we're really happy with it. So Goliath is Khan Academy's project to move our entire backend to Go plus services. And we call the first 80% or so of the work our minimum viable experience. We took the most important of that, called it our minimum viable experience, MVE, and you'll see this term later on. So now we can get into the tech. This is really cool. We got lots of stuff to talk about here. So the first part of our tech transition for this was finishing other technical transitions we had already started. We were early users of React, for example. We wanted to replace all of our Jinja templates in Python with React. So basically our Go backend was never going to generate HTML pages for the web. We wanted to get all of our service behind Fastly, which is a great CDN. We wanted to move all of our REST APIs as much as possible to GraphQL, which we had already started doing. So we had started these tech transitions and we wanted to complete them so we wouldn't have to port extra code over. And the same goes for, we had a 10-year-old product. We had some features that were outdated and not hardly used. So we wanted to reevaluate some of those. And so this is what our tech stack looked like, our architecture as of January 2020. We had a lot more dragons to worry about back then, but fundamentally our architecture was like this. This is a probably clearer and less fanciful picture of our architecture. But the general flow of a request is it starts in a browser or mobile app. It goes to the Fastly CDN, and from there, it's going to go to the render gateway if you're getting your initial page view, or if you're making a data request, it's going to go to the GraphQL gateway. That is colored yellow in this picture because it's JavaScript right now. It is Apollo server. And basically, the GraphQL gateway is going to look at the GraphQL request and fan it out across all of the services. We have about 20 services right now. It's going to fan it out among those services, gather the data, and return it to the user. And that includes also calling the Python 2 monolith to get some of that data. So our Go services are all very consistent in structure. They all have, a makefile and a README at the top. They all have a command package or command directory under which you'll find the package main for any binaries we want to build. It has some YAML files to configure some things. It's got some GraphQL files. It's got a resolvers directory, which I'll talk about, and a models directory for accessing our data store models. So let's get into GraphQL. I will give you a quick crash course in what GraphQL is like so that you can understand some of the architecture choices we've made. So first of all, we are looking at a piece of a GraphQL file here. And GraphQL lets you provide basically a typed API. So you define types. In this case, we're defining a type called user. And your types can have typed values on them, typed fields on them. And so basically KAID, CAID, is our identifier for a user, and it is a string. And you can also define directives, which provide metadata to the system about a given field or type. Next, let's take a look at a query. This is a query being defined on the server. So it's defining a query that can be run by the client. So a query, something the client can query for is a user. They can run a user query for, they have to pass in the CAID so they can identify which user they want, and they will get a user object back. Okay, and this is what a client-side query will look like. So it says query, you can name the query, you can pass in parameters to the query, and then you define what parts of the schema you want to pull out. So in this case, it's saying, hey, I want a user, and here is the CAID of that user, and you can specify exactly which pieces of data you want, so you're not going to overfetch. In this case, it's just saying, just give me the username, that's all I'm interested in. So queries are not allowed to change data. For that, you use mutations. They're defined just like queries, except it's under the mutation type, not under the query type. But they work exactly the same way. Otherwise, they can take in parameters and return values. But the difference is that they're going to mutate data on the server side. And so that's what's in the GraphQL files on the server. How do we get from these GraphQL files to the actual client, to actually serving something to the client? And that is where GQLGen comes in. So GQLGen is an open source project. It's great. It is a library and code generator that takes your GraphQL schemas and gives you type-safe APIs that you can use to implement a server that will respond to those GraphQL queries. Let's dig into how that works. So this is the package main for a service, for the serve command rather. And you can see that we're importing, we have our own little web framework, but our little web framework is basically just some conveniences around the standard net HTTP stuff that Go provides, but conveniences for our services. We're going to pull in the generated GraphQL code from GQLGen, and we're going to pull in our resolver code and basically glue those together into an executable schema. And we use that schema to handle the GraphQL requests that come in. So that's what serve.main, serve.handle GraphQL passed into the schema, that's what it's doing. So if we jump into our resolvers and we look at what they're doing, the resolvers are basically gluing together GQLGen's generated GraphQL interface with our code that is going to be able to resolve the GraphQL data needed for responding to a query. So we're going to focus on this user resolver down at the bottom here. So again, that is an interface. GraphQL.userResolver is an interface that we are going to have to implement in our code in order to be able to respond to user queries. So this is a piece of the user resolver. Our user objects have actually a lot of data on them. And email is one of the fields that are on there. So for every field, you're going to see a resolver function like this that basically is, in this case, going to take a context and a user object, and it's going to return a string. It is a string pointer because it can be nil, and an error. So that basically every single field is going to look like this in the interface. So this is our handwritten code now that is designed to implement that interface. And this is what a lot of our resolvers are going to look something like what you see here. So basically, we are taking in the email, we're taking in the context and the user, just like we saw, just following the interface. We have our own dependency injection system where we basically upgrade a Go context to match up the interfaces that we need. So we have a nice typed interface that gives us access to all of the services that we need within a service. So for example, when we need to access data store, we just have to include that interface in here and we will get the data store interface back. So the next thing that we need to do after we've got our context upgraded is we need to basically validate that the user making this request has access to this field. And so, yeah, so this is actually happening at a field by field level that we can determine what permissions somebody has access to. And so in this case, not everybody has access to a user's email. This is definitely not open. And so we look at what's required for that access. So the next thing is that we're going to actually pull from our data model what the user object looks like in the data. And we get that by the KAID. Every single field, again, is going to look like this, which means that that get by KAID function is going to cache that for the request. Is going to cache that user. This is how we make sure that we're not every single time for every single field pulling in that user object, because we just cache it. It's very simple. But the pattern is going to be very similar each time. We have this nice little PTR package that lets you do mappings from simple types to basically pointer types. Because in this case, as we noticed from the interface, it can be nil, so it's a string pointer, and so we just have the convenience function to basically say, hey, if this is nil, just return a nil for it. Yeah, and so one of the things also I'll note is that email is personally identifiable information, PII, and so we make that very clear in our interfaces, and we also encrypt that data on our backend. So we have to decrypt it at the time that we know that everything is authorized. All right, and so that is what an individual service looks like. Now, some of the magic that made this whole transition work really well for us is GraphQL federation. And basically the idea with federation is that the query comes into the GraphQL gateway, and that is going to federate out the query to all the different services. So basically the GraphQL gateway has to take the schemas of all of those services, including our old Python monolith, glue them together into one big schema. That is what is served up to the users. So let's take a look into how federation works. Okay, so this query here is run by the assignment service. Okay, so this is actually a service-to-service query, but this query could just as easily be run on the client side. But the idea with this query here is that we are going to query data, and so we are calling that user query, so that same user query that we saw previously, we are calling for a user, and we're passing in the user's KAID because we know that that's what's required. But what we're requesting on user is student list. Now, what's interesting about student list is that that is effectively a class in our system. And the student list data is presented by the coaches service. So the previous service we were looking at was actually the user service. This is something that comes from the coaches service. So how does that work? So this is how that works. This is from a GraphQL file in the coaches service. And you can see that it is saying extend type user. So the user type is defined over in the user service. The coaches service is saying, hey, let's extend that type and add, and that extension is based on the key of KAID. That's how it kind of glues users together between services, is it uses that KAID field to say, okay, give me this user's data. And it's going to say then, okay, I am providing on the user type student list. And I take in a student list ID, which is basically a classroom ID, and I return a student list object. And so the GraphQL gateway is going to have to stitch that together when somebody asks for a student list. So if you're asking for some fields of user, they will come from the user service. Asking for other fields, it's going to come from like the coaches service in this case. Now, one really cool feature that we got out of this is that we were able to make the GraphQL gateway do side-by-side testing. So what this means is that once we have an implementation in Go of the same field that's in Python, what we can do is have the GraphQL gateway request the data from both services simultaneously and return the Python data to the user, but compare the result. And if there's any difference in the result, it's going to log that. So we're able to look up in the logs, hey, are there differences that we're seeing? And if so, then we know, oh, we still have some work to do to make these match up. But the great thing is that this is working with real production data. And so all the weird little edge cases that have built up over the years are all going to be covered by this testing. Works out really well. And we can also prove out performance this way because we can make sure that the Go implementation is actually performing as well as we expect it to. So how does side-by-side testing work? In this case, we have a field that is implemented, or rather a type. The teacher campaign type is provided by the Python monolith still, but this field, the live field, comes from the campaign service. The campaign service, actually both campaigns and Python are both defining the live field. The difference is that this campaign service is saying, we are migrating, that's what this directive is for, at migrate. We're migrating from Python to, and the current state is side by side. So basically what that means is it's going to tell the gateway, hey, when you look at this live field, we know that it's coming from the Python service, but we're doing side-by-side testing right now. And so that means that the gateway is going to run the side-by-side test that I just described. Once we're done with that and everything's happy, we can just change that state to migrated. And that will mean that the gateway will only send the traffic to the new Go service. Once we're completely done with it, we just remove the migrate directive entirely and we delete the Python code, and that's all set. So that gives us the ability to migrate even a single field, which is as incremental a migration as you can possibly imagine. So having talked about side-by-side testing, I wanted to come back and talk about this query that we looked at before that the assignment service is going to run to get data from the coach's service ultimately. I want to put this in more context. So in context, it looks like this, because in context, that query is living in a Go file in a string with this special @GenClient comment in there. And so that lets me introduce GenClient. So GenClient is really cool. This is an open source project that we've created. And what's great about this package is that it's very much like GQLGen for clients. It lets you create queries, generate type-safe Go code that you can then use to run queries from Go. So basically that query was defined and that string is more or less thrown away because GenClient turns it into the API you see here. We call the GenClient.getClassroom icon URL for assignments, and it takes in all those same parameters that you'd expect. And that's generated code. And the result that comes back, you can see there's response.teacher.classroom.id. So that is what the response is showing us. And it's all nicely typed. And it's also matched up when GenClient pulls this query out of our code, it's going to match up this query with the schema. So we actually get type-safe querying all the way through from our Go code all the way through to the GraphQL schema and the service on the other side. So that's pretty great. Basically, it's like if student list changes on the coach's service, we will know about it right away because our GenClient code here will fail to build. So I didn't have time to get into our test code, our data store models, library code, custom linters. We had a lot of really cool stuff that we've used to get us through this project and to put us in a good place with our Go infrastructure. But yeah, so far the experience of writing Go has been great. We love the tooling that we're using and the awesome production performance. It's been really great. So I want to talk a little bit about delivering this project on time. How did we do this project? So Goliath MVE, basically a little timeline. It was March 2019 when we made the decision that we're going to go with Go and services in this project. We had spent the rest of 2019 basically building early infrastructure and the first service to kind of prove it out. We had an overall idea of what the services would look like. And then spring 2020 is when the team really ramped up, when we really had like full staffing on the project. And we completed it at the end of August 2021. What is MVE? MVE ended up being about 85% of our GraphQL field, which is about 5,000 fields, 95% of the requests going to the new Go backend, 750,000 plus lines of Go code. So we wrote a lot of code, did a lot of porting, and got it working. So our earliest estimates showed us coming in at May 2021. This is our burn down chart from Goliath MVE. By July 2020, we had a really good sense of what our velocity was looking like, where we thought it was going to go over time. And so we basically just managed the project diligently to keep things on track. People were very flexible. The engineers were flexible in moving to other parts of the project if other parts of the project needed some additional help to keep it moving on track. And you can see that we had a pretty smooth burn down. Or organizationally, we value working sustainably. And so I see this as a sign of consistent delivery and not a death march. Like we were just working it, and everybody worked really hard to get it through, but we worked sustainably and consistently. One of the things we did at the beginning of the project was we established project principles. These project principles also help to keep us on track. We clearly didn't want new Python features because new Python features would basically just add more to what we needed to port, so that wouldn't be good. A lot of the other principles are actually focused on keeping us from adding more to Goliath. When we're rewriting the code, we wanted to do as close to a straight port as we could. And so that's what a lot of these principles were trying to keep us on track for. So as of today, the last 15% of the GraphQL fields remain. So Goliath continues, but now it's just one project among several because we have a very comfortable move on our architecture. Everything's running, and we're happy with where we are. And I'll just close with, I like Go more, the more I work with it, which one of our Khan Academy engineers said, and that's a sentiment shared by many. Thank you all to the community for making it so great. And thank you for listening to my talk. If you have any questions, talk to me in the GopherCon Discord or hit me up on Twitter. I'm at Dangoor there. And if you're interested in working on this kind of project, go to khanacademy.org/careers.
All right. Thank you so much, Kevin. That was a wonderful talk. Are you all ready for this? I can't believe how good that. Because it's Khan Academy. You guys get it, right? Yeah. Yeah, you get it. All right. All right. Peanut Gallery.
Khan Academy is here at our conference.
They just keep on rolling.
Khan Academia, learn from this.
Peanut Gallery, I invite you to top this. All three of us, I invite you to top it.
I don't think it's going to take much.
I don't either, because they have the gift of images and being able to edit images and then put them into Discord, which so far has proven pretty great.
They can't do it.
Well, seriously though,
3 days here. We're starting to get a little delirious.
Yeah. We're on like 3 hours of sleep or something like that. But seriously though, I mean, I enjoyed that talk. It was a really nice measured talk on how to move responsibly from one language to another. Of course, Khan Academy is a huge service. They have to do this well. They have to have a measured way of doing it. And the talk isn't saying you should get away from Python. Python sucks. It's not saying that. It's saying,
but you are.
I am only not saying to write bots. That's it. Yeah, someone can clip the video and just have me saying Python. But yeah, I really enjoyed that. I thought it had great measurement. It told us kind of how we should go about doing a language switch like that if we found a reason to inside of our organization. So
when was the last time you did a language switch?
Myself or at a company, an organization?
At a company.
I'm moving from Rust to Go right now. I'm just kidding. I actually did move a code base from Python, half of it from Python over to Go. And we kind of did a similar thing, like the services route, about a year ago or so. So it's kind of interesting to see the paradigm shifts that even you inside your own mind has to make between, in that case, Python and Go.
I mean, there's so much around the whole ecosystem of it, right? It's not just like the differences between like writing idiomatic code in this language. There's dependency management and how are these things deployed, and then you have certain things like statically compiled binary. You don't really have to worry about things, but like if you're going the other direction to a language that has, a runtime, and then you've got to figure out how you manage what version of that is on individual nodes.
Certainly, yeah. And then you got to get deeper into the language ecosystem sometimes too. In Python, Python 2 or 3, and if you go over to Go, you got to start. Soon we're going to have to start thinking about generics and things like that. So you kind of hit the nail on the head there. It's a lot more than just the language. It's the tooling and the ecosystem and the support and the docs
and the community. I mean, who wants to
where are you going to find people funnier
than this crew right here?
Exactly.
I mean, you know. But on a serious note, though, like I think the community aspect of things for me plays a huge role, right? It's being able to interact with others in the community, being able to feel okay, asking questions and not somebody being a douche to you. It's these kinds of things I think really make it worthwhile being in a language community.
Yeah, I mean you got to feel comfortable. You got to feel like you can enjoy this too.
Yeah, absolutely, absolutely.
So we got some stuff coming up. Tell us what's going on in Discord first. I saw some stuff going on out there, especially with regards to CrowdStrike.
I'm sure there's some dad jokes galore.
There is. I mean, we haven't checked in on CrowdStrike's competition in a while.
I actually just saw something.
They've had some really interesting submissions. Yeah, people implementing try-catch, monads. I'm trying to remember what some of the other ones are.
Unfortunately for monads, someone already took the gonads repository.
Right.
So you can't, unfortunately, this is sad news to have to deliver to everyone, but no gonads for a repository name.
No gonads for you.
Another great one was async await, and the struct to do it was pro-mess, like promise. Pro-mess. I enjoyed that, yeah.
Nice, awesome.
I love it, the puns too.
Yeah. But seriously, CrowdStrike, there's a link in the peanut gallery for the Gopher they're going to give away. That competition is ending now in about an hour and a half or so. So get your submissions in.
And vote.
Yes.
Then speaking of things it's too late to get submissions in for, we have the Gopher Say game coming up.
Yeah.
And so we're hoping that all of you trolled them hard.
Please.
I'm so looking forward it's just how bad some of these answers are going to be.
Me too. Yeah, me too. Should be a hoot, for sure.
I'm going to be the most surprised by some of the, like some of the things were legitimate questions when we played. They were legitimate questions, but you were not getting the responses you'd expect.
No.
Like, I forget what one of them was, other languages, like your second favorite language or something along those lines. And we were like we're like way off base. We're like,
yeah,
who
we're thinking
are
JavaScript,
these people?
whatever they're like COBOL and Pascal. I'm like,
Fortran.
What? Fortran. I'm like, what is people?
Oh man, I hope someone put GoBall in there now. It's just the pure trolling aspect there.
So going along in parallel, we also have a Fun with Fuzzing virtual meeting space coming up. If you want to attend that and you don't already have a ticket, it's free. Just go to GopherCon's website and register for that. You'll see it on the agenda page. But yeah, I'm really happy with all the content that GoTime has been bringing to us throughout the event. This one in particular, I've been really, really excited for. I'm sure it's going to be wildly entertaining.
Yeah.
And if you want to interact with the contestants and the hosts, we created a Gophers Say channel inside the speakers section of the Discord. And so without further ado,
let's do it.
It's go time.
1, 2, 3.
I stole it.
Oh, you stole it. All right.
1, 2, 3. It's go time.
Hello and welcome to this Go Time GopherCon extravaganza. Yeah, extravaganza, yeah. I'm Matt Ryer and I'm thrilled to announce that today again we're playing Gophers Say, the excellent, popular game show, family game show based on Family Feud or Family Fortunes if you're in the UK, which I am. Let's meet the teams. We have Team 0 is... Well, let's meet our contestants here. We've got Julie Q's around. Hello, Julie.
Hi.
Welcome to GoTime/GopherCon. We've also got Steve Francia. Can't believe it. Hi, Steve.
Hi, everyone.
Can't believe you're here, Steve. Really? Can you?
I mean, I'm here.
Yeah. Well, you won the competition, so congrats. John Calhoun's also here. John.
Hey, Matt. How are you?
Hi, John. I'm good, mate. Yeah, I'm excited. Are you going to win?
I don't know.
Okay, no, that's a good answer.
If my team
Honest
carries
answer.
me, I'll win. But if my team doesn't carry me, I probably won't.
Okay, good. So he's not going to be pulling his own weight there. Well, Natalie Pistanovich is in town. Hello, Natalie.
Hi, Matt.
Welcome back. Are you looking forward to the game show?
I'm very excited to be the one person who is aware of the rules, yes.
Yeah,
because I already played it.
Yes, please remind me if I forget as well. Katie Hockman, also around. Hello, Katie. Welcome. How are you doing?
I'm good. I'm very excited to win, despite John not believing that we can.
Ah, okay. Well, you'll have to carry him. That's it. Rob Findley's also here, aren't you, Rob?
I am. Hi, Matt.
Hey, welcome to the Go for Time, Go for Time, Go Ton mashup. Yeah, don't worry. Said it wrong on purpose. Okay, I need to tell you about this game that we're going to play because it's lovely. Essentially, we've asked a load of Gophers some questions, and you'll have to try and guess the answers. So you're trying to match the popular answers from the survey. It's not about right or wrong. It's just about what Gophers say. That's why it's called Gophers Say. The top answers will go on the board. Any response that had 5 or more answers will appear on the board. And in order to get control of the board, each team has to do a face-off, basically, where you'll just have a guess and see the highest score. And that's how you'll take control of the board. Once you've got control, you have to then guess all the other answers, and then you'll win. That's how you win. You get points. But be warned, if you get 3 of them wrong, you'll lose 3 lives, and it'll give the other team chance to steal, and they'll be able to take your points, essentially. So don't let that happen. You cannot confer through the game, but while you're stealing, you can confer, and I'll remind you of that later. Do we feel like we're ready to play? And I'm going to announce the teams that we have here. So Team 0, we've got, it's Natalie, Steve, and Julie. You are our first team, Team 0. There you go. And, don't take anything by the fact it's 0. Is in the name of your team. It's literally just 0 bound, like a go slice in it. And that's why I've done that. John, Katie, and Rob, Team 1, you're our second team. Are you happy about that, or slightly indifferent?
Very happy.
Yeah. Okay. Okay, good. They're definitely happy. We've been assured of that verbally. Okay, we're going to now look at the board. We're going to share the screen. Can we see this? And we're going to jump into our first round here. Natalie and John, you're going to go face to face, and we're going to have an interface off, if you like puns. Natalie, what would your guess be to this question? Describe the Go community with just one word. What did most people say when they were asked to describe the Go community with just one word?
Welcoming.
Natalie. Welcoming. Gophers say. Yes, it's on the board. In number 2, 9 points there. So, John, you're going to have a guess. If you beat Natalie, you have to get that number 1 spot. You'll take control of the board.
Natalie stole my answer, and I don't know if my backup is. I guess is friendly the same as welcoming? I don't know how that would be categorized.
Let's see if friendly is on there. Gophers say. Yes, friendly. And where is it? Number 3. So Natalie's team, Team 0, takes control. And we're over to Steve Francia. Steve. How's it going, Steve? Are you going to have a guess? What do you think the Go community said about this?
I was going to say welcoming and friendly.
Okay.
But those have been taken. So I'm going to say good looking.
Oh.
Attractive.
Okay, go for say. Oh, no, I'm sorry. Attractive was not on the board. You lose a life. But don't worry, you've got 2 of them.
It should have been.
Agree, yeah. Julie, would you want to have a guess?
I'm going to say fabulous.
Fabulous. Okay, go for say. Oh, I'm sorry. Nobody said it was fabulous. Well, 5 or more people didn't say that. We look back around. Natalie, what do you think?
Inclusive.
Inclusive. Go for say. No, nobody said inclusive. And that's your third and final life gone, I'm afraid. So now the other team, team one, have a chance to steal. You can confer and just need one answer from you, John, the team captain, after you've conferred with your team.
All right. For my team, does anybody think the word gopher might be on the board?
I don't
Go
know.
community
I
is
would.
Gopher.
That or like programmer or like nerdy?
I was just gonna say. I was gonna say diverse.
I
That's
think
that's a
diverse.
good one.
Okay, is that any answer you'd like to submit?
You going with diverse?
You want to lock it in?
Yeah.
Yeah, we're locking diverse in.
Okay, we're going to lock diverse in. Go for say? No, I'm afraid not. It did not steal. Let's reveal the board. Number 6 was opinionated. 5 people said that. In at
Makes
number
sense.
5, we have fun with 6 people. And in position number 4, we had helpful. 7 people said that. In position 3, we have friendly with 8 people. Welcoming's in position 2 with 9 people. And at number 1, it is awesome. And that was said by 17 people.
Wow.
So there we go.
Getting off to a rough start.
Good
Kind of the
start.
same as
Ah.
fabulous.
Yeah, I was going to say awesome is fabulous.
Anymore.
Right?
Yeah. Well, there we go. Let's move on to our next round. Okay, round 2. Name a place outside your house where you like to code/work. Name a place outside of your house where you like to code/work. This time it's Steve versus Katie going face to face to find out who controls the board. Steve, I'll ask you after Katie. Katie, what's your answer?
Wait, that's me first. Okay.
Yeah.
I have 2 guesses. I will say coffee shop.
Coffee shop. Good one, I think. Go for say. Yes, of course. And it's the top answer, which that means that Steve doesn't even get to have a guess. You've just basically snapped his dreams out of the clutches of his
And
tie.
I was going to say coffee shop, so I'm
There we go.
Good one.
Yeah, good one. Okay. Right. So now it's Rob's turn to have a guess. You've got 3 lives, Rob. What do you think?
We used to work in offices. So how about the office?
Okay, let's find out. The Office. Go for say. Yes, indeed. In at number 3, The Office with 21 people. By the way, 38 people said coffee shop. Very cool. All right, John. 3 lives still, going strong.
Oof.
Where do you like to code/work?
I'm going to go with park.
In the park. How beautiful. Go for say. Yes, indeed. Number 2, Park Garden Yard. 26 people. Okay, Katie. Still got your 3 lives.
I don't do this because I watch movies instead, but I know a lot of people who do. I'm gonna say like airplane.
Oh, airplane. Go for say. No, nobody does that outside. They don't do that, apparently. They watch movies too, I guess. You lose a life, but that's okay. You've got 2 more lives. Rob, what do you think?
Okay, how about the beach? Some people work at the beach.
Do they? Well, let's see. Go for say.
Oh.
No. Have you met a programmer? The beach.
Well, yeah.
Yeah, I know. There's some cool ones, aren't there? Not in this survey, mate. Not me either. Okay, John, back round to you. Talking of cool people. What do you think?
Boy. I'm going to guess campground.
Campground. Okay, let's go for say. No, can't believe it. They can't believe no one's going camping to setting up a tent, sorting out the electric,
Going to go camping and work.
sort out the water, sort out all the. I mean, look up the local amenities, just to get some code written. They're not doing it. I can't believe it. Katie, what do you think?
Oh, we still have a life
Last
left.
life, 1 life
Gosh.
left.
I thought we were dead, so I wasn't even thinking. Pressure's on. I was gonna say
They are dead. They've had 3 X's.
Yeah.
Oh, really?
I think I think we did. I
Yeah.
mean, we
Oh,
did die 3
okay.
times. So I'm
Okay,
pretty
don't
sure.
worry. That's it's a mistake by me then. Okay. Okay,
I
that
started
means
counting at 0.
yeah. Thank you. Get out of it. Okay. Unfortunately, that was your last life. So that means the other team get to steal. You can confer, and I'll take Natalie. I'll take your answer. What do you think?
So we get to talk to each other right now?
Yes,
Yes.
we get to
Yeah.
decide together.
What about library?
I was thinking of a
thinking
cohort. Oh.
I thought train.
I was thinking train too. Train and library.
That's because you live in the US.
Yeah.
Maybe most of the people who took the survey live in the US. How about a co-working space? Is that like the office?
Okay, I'm gonna.
I
have to
think
take
4,
an
5,
answer.
and 6 are co-working space, library, and train.
By this
So you
order?
can't go- well, I don't know. Any of those sound good to me, Natalie. You choose.
Yeah.
Natalie.
I was about to ask Julie, what do you think? But okay. Yeah, let's try train.
Okay, train to steal. Surveys. I mean, our Gophers say. No, I'm afraid not. Well, that means the points go to team 1. Let's unload this board then. Number 6 was nowhere. People that don't leave to do any work. That got 5 answers. In number 5, it's the pub or the bar. 6 people said that. Can believe that. And at number 4, let's see if this is one of yours, Steve. Number 4 was the library, indeed. 14 people. Oh, that's okay. Don't worry, though. It's going well. We've got Team 0 have 17 points. Team 1 are forging ahead with 85 points. Let's go on to round 3. Okay, round 3. The question we asked our Gophers is, the most useful Go keyword is what? What is the most useful Go keyword? But what did people say? We're going to find out which team takes control of the board when Julie and Rob go head to head. I was expecting some music there. It's all right. We've never done that piece before. We'll do it for next time. Okay, Julie, this time. There you go, Julie.
Oh boy. Switch.
Switch. Go for say.
Oh, sorry.
No, that's okay. You just lose 1 life. No problem. Rob, you have to have a guess.
Yeah.
Actually, Julie, you don't lose a life. We're just still finding out, who's going to take control. So, Rob, you have to get one of these to take the board.
Well, you can't switch without a funk. So I'm going to say funk.
Funk, indeed. Go for say. Yes, indeed. At number 2, 18 people said funk was the most useful Go keyword. And that means team 1 steals the control of the board, takes it. John Calhoun, what do you think the most useful Go keyword is? What do you think our Gophers said?
This is one of those ones where I just expect people to not name keywords as answers.
Why would that be, John? That's very unusual.
Like if you asked me to list all the Go keywords, I couldn't list them all. I'd definitely get something wrong.
But you could do some of them, right?
Select.
Select. Go for say. Yes, indeed. Down at number 6. 7 people said select. Nice work. Okay, Katie, what do you think?
I'm going to say return.
Return would be very useful. Let's see if the Gophers said it. Go for say. No. That honestly shocks me that that's not on there.
That's fine.
What are they?
You need to
What are their
return.
programs? Yeah, what are their programs? Okay, well, we can't figure that out now, Rob. You've got 2 lives still. So what do you think?
Okay. I think people will have just heard the word go, so they'll say go.
Okay, that's how much respect you have for the audience of Gophers. That
It's useful.
This. Yeah, it is useful. Let's find out if they said it. Go for say. Yes, and look at this. Top answer. 29 people said that go was the most useful Go keyword. Very cool indeed. 2 lives. It's Johnny Calhoun. Go on, John. Do a guess.
VAR?
VAR. Very good one.
I mean, how else
Go
are you
for
going to create those globals
good
that
point.
everybody loves?
Trolling. Go for say? No. You lose another life. You have one more life. Katie, that life sits delicately in your hand. Are you going to set it free or crush it to death more? What's your guess?
I'm between two,
Yeah.
so I'm going to go with, I think people said if.
If. Go for say? No. These
All right.
programmers are very certain. There's no
Apparently.
uncertainty. Yeah, they know what they're doing. This is not like, yeah,
Interesting
if this,
programs.
if. Make your mind up. That was your last life, I'm afraid. This gives the other team, Team Zero, chance to steal. Please confer amongst yourselves. And then Natalie, team captain, I'll take an answer after you've conferred with your team.
All right, this time we're doing this right. What do you
Yes,
think?
please.
Defer.
I was thinking
Really?
of that too.
Interesting. I was thinking panic or type, but I'll defer to you two.
Let's use
This was meant to be.
Use
Let's
the
go with
keyword.
defer.
Oh, excellent. I don't know when to do this now. I feel like we need to wait for the end of the game show before I announce this one. I'm just kidding. Defer. Go for say. Yes! You've successfully stolen third
Oh, good
space
answer.
there with 11 people. Defer. And you steal the points. 65 delicious points coming your way. So
Oh,
Team
it's so
Zero is
close.
now on 82. Team One is on 85. Let's reveal the rest of this board then. What was the most useful Go keyword? Number 7, people said struct. 5 people said that. Number 6 was select with 7 people. Number 5 is interface with 9 people said that. At number 4, clues in the number. 10 people said so. And defer was number 11. Funk at defer was at number 3 with 11 people. Funk in spot 2, 18 people. And go at number 1 there with 29 people. Well, things are heating up here. 82 and 85 is not much in it, is there? Now we've built some tension. It's time to go to round 4. Bam, ba-dam, bam, ba-bam, bam. Okay. So, right. What are we doing again? Okay. The next question. The best thing about the tech industry is what? What is the best thing about the tech industry? And Natalie, it's Natalie and John to go head to head. John, what's your guess? What's the best thing about the tech industry?
Paycheck?
The paycheck. Go for say. Yes, at number 2, the pay/benefits. 20 people there. Interesting. Okay, Natalie, can you beat that? Can you find that number 1 spot?
Twitter?
Pardon?
Twitter?
Twitter. Twitter.
It's my
Go for
honest
say.
answer.
No, I'm afraid no one gets that. That means Team 1 take control of the board. Katie, we're over to you. 3 lovely lives. Don't ruin them. What's your guess?
I think people would have said the people.
The people. That'd be nice if the people said the people. Let's see. Did the people say the people? Go for say. Yes, indeed. At number 4, the people or the community that they're in. 15 people said that. That's very nice, isn't it? Rob, can you find a nicer one than that? Or just any?
I don't know about that, but how about the fact that we get to program? How about the work?
Oh, the work itself, programming. Go for say. Yes, indeed. People did say that. Problem solving we grouped into that. 19 people at number 3. Yes. Very cool. 3 lives still. Johnny Calhoun.
I'm going to go with the impact. You can
The
affect more people.
impact. Okay, is the impact. Did they say that? Let's find out. Go for say. They did indeed say impact. They said opportunity or the impact to make change, things like that. Isn't that nice? 8 people there. There's a number 6. And still 3 lives. This is looking good. Katie, can you keep up the running streak of success?
I don't know if I can.
Hmm.
I feel like the thing I want to say is probably within the category of benefits, but I was going to say like flexibility. People like to work
Okay.
from home. People, you know.
Yeah, flexibility. Okay, let's see if it's up there. Gophers say. Oh, well done. Yeah, work from home or flexibility. 10 people said that. I tell you what, I genuinely thought this was probably going to be the hardest question, and you've really just nailed this. Very impressive. Rob, I think we're back round to you, aren't we?
I'm mystified. I have no idea. I was going to say flexibility. I don't know. How about the opportunity to grow?
Okay, let's see.
I don't know.
Yeah.
I'm doubtful.
Let's see if more than 20 people said opportunity to grow. Gophers say? No, and you lose a life, but it's okay. You've got 2 other lives. So John and Katie are both going to get a guess here, starting with you, Johnny Calhoun, down at the local saloon. What do you think?
Equally mystified.
Mhm.
Let's, I don't know. I'm going to go with go.
The language, go.
Go. Best thing about
The
the
best
tech industry is
thing.
go.
Okay, let's see. Maybe Gophers did say that. Let's see. Gophers say? No, I'm afraid not. You lose your life. Katie, last life. To prevent the
that
steal.
was going to be my guess. I don't know.
You're very close with that answer, apparently.
Okay. Coding.
Okay, let's do it. Let's find out. Gophers say? No, I'm afraid not. So that means the other team get a chance to steal. Can you get this right, team? Please confer. Start conferring now.
My idea is conferences.
Me too.
Okay, Steve?
Yeah.
I was going to say travel.
All right.
So I think conferences is great.
Yeah. Cool. Okay, then that's our answer.
Oh, okay. Conferences. Oh, conferences. Oh, let's see if it's conferences. Is it conferences? Gophers say?
No.
No, afraid not. That means team 1 steals all those delicious points, and we'll look at the scores after. The top answer for this one was, in fact, the tech, the innovation. Tech or innovation is the best thing about the tech industry. Okay, so let's check in with calm down. It's time to check in with the scores. Team 0 in our slice of team here. Team 0 has 82 points, but Team 1 out in the lead again. It's 157 points. Celebrate.
Yay.
Yep. There we go. Okay, let's move on, shall we, to the next round. Round 5. Da-dum-bam-ba-bam. Someone else is having a party at their own house, by the sounds of that. Okay, right. Here we go again. This is round 5. This time the question is, the worst thing about the tech industry. This is what we're after now. What's the worst thing about the tech industry? And last time it was John and Natalie went head to head. So it's Steve and Katie, and Steve goes first. Steve, what's the worst thing?
Bugs.
Bugs. What a great
Bugs.
answer. Bugs. Yeah. We'll submit it in your accent then, shall we?
Yep.
Go for say. Go for say. Yes, bugs. Bad practices. Okay, yeah. There we go. We give you that one. Bad practices and bugs, things like that. Okay, in position 4 there, 13 people said that. Okay, Katie, can you beat that? There are 3 other answers ahead of this one.
I feel like no matter what I say, I'm going to get in trouble for it. I'm going to say this in the most diplomatic way possible. Potentially like the room for growth as far as diversity goes.
Okay, so Right. Yes. Diversity being the worst thing currently. Gophers say? No, Katie, apparently that's all sorted.
It's all done.
Yeah,
Fixed it.
we're finished. Put that into the done column. Okay. So that means Team 0, you need it. You've taken control of the board. And Julie, it's your turn. 3 lives. Have a guess. What do you think the worst thing about the tech industry is?
I'm gonna say the bad people. The people, but specifically the people who are bad.
The baddies, bad people, like villains and the like,
Yeah.
charlatans, scallywags.
Exactly.
I don't know. Okay, the bad
Lock it in,
people.
scallywag.
Yeah, okay, let's see if scallywag, I don't know if it'll be spelled out like that, but let's find out. Gophers say? Yes, indeed. So people saying, people or the culture. 49, that was our top answer. Merry festive holidays to everybody. That was a little surprise. And that surprise there means Steve Francia is going to donate $100 to a charity. And that was what that lovely piece was. So thank you so much, Steve. That's lovely. And Natalie, we're back round to you now. It's your turn to have a guess. What do you think the worst thing about the tech industry is? 3 lives.
Something along the lines of agile sprints, Jira, something there.
Okay. So like management practices, stuff like
Yes.
that. Okay, let's see if that's on the board. The Gophers say? No,
Good,
everyone
it's
loves
not a
all that.
problem.
Not
Right.
a problem at all.
That and diversity is all good.
Yes. Steve, what do you think? You want to have another guess? You've got 2 lives left still.
I think it's the hours.
Oh, the hours could be the worst thing about the tech industry. It is nearly 9 p.m. and I'm hosting a game show. So let's see if what Gophers say. Yes, indeed, Steve. Number 3 there. The pressure and long hours. 16 people said, oh, yeah. Take a break, everyone. Not you, though, Julie, because you're up to answer a question now. You've got 2 lives still. What do you think the worst thing about the tech industry is? We're looking for that second answer.
This is very hard. I'm gonna say, can I say like the bad impact?
Yeah, so the evil? Would you class it as evil?
Yeah.
Yeah, negative impact of tech. Okay, let's see if that's up there. Gophers say? No, Julie, not there. Down to 1 life. Yes, indeed. Down to 1 life. And Natalie, you've got your foot on it. So what are you going to do? What's your guess? What's the worst thing about the tech industry?
That code was already said, right? That was kind of the bad practices one.
Yeah, bad practices and existing code was at number 4 there. Got number 3, we've got the pressure, long hours. And at number 1 is the people. Well, that would probably fall under the existing code.
Okay.
Yeah.
Oh man,
Tough one, isn't it?
I'm out of ideas. Not the people, not the long hours, not the bad practice, nothing about management then? Did we say that? Is that management practices? That also doesn't work?
Yeah, that one wasn't up there either, was it? What are we going to say? Or should we time you out?
Does that mean we get to keep the life?
No, it means the other team will get a chance to steal.
All right, some bad documentation?
Okay, let's go for that then. Bad documentation. Go for say? No, but what a great guess. Okay, so now the other team have a chance to steal. John, I'll accept your answer after you confer with your lovely team.
So I'm assuming that if they voted the podcasts, that they would have filtered that one out, right? Jared wouldn't let that fly.
My idea is
Take
like
conferences out.
Twitter, Reddit, Hacker News, like that kind of like the social media aspect. What do you guys think?
I was actually thinking Twitter but Natalie used it for the best things about search. But I think it's kind of like people as well. It can be good
both.
and bad.
Yeah.
I
mean, yeah.
I think that's good. I was also
do we
going
want
to
like
say
social media, or do we want a specific?
I would hope that they would take either if that was actually the answer.
Okay, so let's go with
Sounds good.
social media.
Okay, social media. Let's find out. Gophers say? No, they didn't say that. So you don't steal the points. That means that Team Zero keeps those lovely points. But let's find out. What was it, number 2 on this one? It was, there's too much to learn. There's too much to learn in this old tech industry of ours, and it's making us angry. That's what we've learned today. Okay, I don't know, probably wouldn't have guessed that one. I thought there were some great answers there, everyone. How's it going so far? You having a fun quiz?
Yay!
Woo! Yeah.
I'm realizing that I do not resonate with all the people who took this survey. We've missed like the top 2 answers several times now, I feel like.
Yeah, that's it. It's surprising. You learn things. It is a surprise. Let's check in with the scores, shall we? Please. Team Zero's got 160 points, just slightly ahead of Team 1, who have 157. But it's so tight, and you won't believe it, but the next round is double points round, round 6. Let's go. Okay, this is the final round for double points. Anyone could win the amazing prize. Any one of you, 3 of you, can win this, and then you have to share it, which I'm sure will be no problem. The question for round 6 is, we ask people to describe the Go language with just one word. Describe the Go language with just a single solitary word. What did people say? Julie and Rob, you're going head to head, starting with Rob. What do you think, Rob? What do you think people said?
I think people said simple.
Do you now? Let's see if people did say simple. Go for say. Yes, and it's the top answer. So it means you take control of the board straight away there. And we're over to John. You got 3 lives. There are 3 ones to guess. The top answer's already taken. Simple. What else do people use to describe the Go language, John? One word.
I'm going to go with verbose.
Verbose. Okay. And just for anyone that doesn't know, verbose is when you use lots of extra words that you're really unnecessary and don't need to try and explain something to somebody, or could be in documentation. And essentially, you're using way too many words that it's unnecessary. Essentially, and the idea is
when Jared tells you we have 11 minutes.
Oh, not 11 minutes to fill. Oh, okay. I won't carry that joke on then for 11 minutes. That would have been gold.
About being verbose.
Yep. Okay, good bit of comedy, everyone. We're all equally guilty. Katie, what do you think?
Is verbose on the board?
Oh yeah, I genuinely forgot what we're doing, and that's why it shouldn't be
I can
verbose.
assume no. But okay.
It's not on there, unfortunately. No, it should be now after that.
Yeah.
So unfortunately, yeah, John, you lose a life. Sorry, thanks, Katie. Hopefully we can edit that so I don't look like an idiot.
No worries.
No, we can't apparently. Okay, Katie.
I'm going to say fast.
Fast. The Go language with just one word. Fast. Go for say. Yes, indeed. It was in spot number 3 there. 9 people said it, so you get 18 points. By the way, for the simple answer, because 25 people said it, you've got 50 points there. So there's a lot of points on this board. And with 2 lives left, Rob's to guess. Rob?
How about concrete?
Concrete. Oh, okay. Concrete. Let's see if people said that. It'd be interesting. Go for say. No, obviously not, Rob. But good answer. But you lose a life, I'm afraid. John, over to you now.
See, this is the problem.
Last life, John.
It's a self-fulfilling prophecy if I lose this for us.
Come on, get in the minds of these surveyed gophers. You know them by now. We've got to know them over a series of 5 rounds, simple questions. I feel like you know them pretty well. What do you think?
Readable?
Readable. I love that answer. Let's see. Gophers say? No, they did not. That is a surprise. And unfortunately, that was your last life, which means Team Zero has a chance to steal and basically win the game if they can get either the second or the fourth answer from this board. You're allowed to confer, of course, Natalie. I'll accept your answer after you've conferred with your team. What do you think?
What do you say?
Oh boy.
I think I would say, I'll give a few. Efficient.
That was
secure.
mine. That was what I have in mind.
I mean, it is what it says on the Go website, which I put there. We could also say fun. Fun is another one.
Mm-hmm.
So fun, efficient, secure.
I like
Secure is a good
efficient.
one. Efficient.
Mm-hmm.
It's interesting that some of the other questions have like 7 answers and this one has only 4. So it looks like everybody has the same thing in mind, or they just dropped out of the questionnaire. Okay.
I think
I guess
below 5 answers gets dropped.
Yeah. Oh, so it's actually the other way around. So many answers.
Many people
well,
answered the same things in this one.
Yeah.
Yeah. 25 people said simple. 9 people said fast. There's still 2 answers to get on the board. Positions 2 and 4.
Then how many people said efficient?
Shall we find out? Is that your answer?
Yes.
Would you like to lock it in?
I would like to lock it into number 2, please.
Well, you don't get to choose. Let's find out. Efficient. Go for say.
No.
You've been hanging out in Germany too long, Natalie.
I've been reading the documentation. It says there.
I mean, it is on the website.
Yeah. Okay. We're going to award those points, and let's find out. At number 4 on this board, people said with just one word, the Go language was fun, which was
I
mentioned.
knew it.
Fast was at number 3, 9 people. At number 2, pragmatic. 12 people said that. It would have earned you
At least it
24.
doesn't say secure.
Yeah.
Were there just
Okay.
a lot of answers with like 4 or less then?
Yeah, we'll do the data crunching and find out. There sometimes happens there's lots of answers and it's not many people agreeing. Only if you had 5 or more will they make it onto the board, of course. But there we go. Let's have a quick look at the scores because these are final scores now. It's time for the final scores now. Team 0 got 160 points, which is very respectable. And I'm saying that to lessen the blow when we find out that Team 1 thrashes you with 225 points. Please celebrate appropriately. So there we go. Right. Any surprises? What do we think? Which was the round? John, when you were saying that they missed out some answers, what do you think? What were you thinking of?
Oh, I just felt like half the answers people gave on that last one were ones I would have expected to at least show up a couple times.
Mm-hmm.
But it is hard when, everybody chooses different words.
Yeah.
But I did call it that Katie and Rob were going to have to carry me because I got nothing on that last round.
Yeah, it's good
That's
though,
all right.
isn't it?
That's why we're a team.
There you go.
That teamwork. Sorry,
Yeah,
Steve,
but
you look upset.
how are you feeling, Steve, after?
I'm pretty brokenhearted. I thought we were going to win. Even at that last round, I thought we had it. I was like, we're going to steal it.
We were not
Yeah.
efficient enough.
No.
Mm.
Well,
But
we
do
weren't
you-
fun enough. Is really what it was.
That's true. That is actually true.
Or pragmatic.
I mean, that just
Yeah.
means you need to rebrand the go.dev website and just put fun real big.
I think we're going to have to just, it was fast, simple, pragmatic, and fun. I think that's what's going to go on the website now.
I think it has
That's what
to.
people think of
Legally
it.
obligated.
Yeah. But how do you feel? Do you feel like you got to know the Go community a bit more as well in a way?
Yeah.
And like, do you understand them? Sometimes some of the answers are unusual, aren't they?
I feel like the last time you played this, didn't you have questions that asked about editors and people were using that? Or I think one question was like, what was the first language you learned? So you kind of got to understand people better based on how old they were when they learned to program. This one, I don't feel like there was any questions that gave that away too much.
Yeah, no, but you sort of just have to pick up the general vibes of people, I think, with this game. But
interesting fact, in the first Go user survey, we had a bonus question, which what was your favorite Go keyword? And I thought doing all these surveys would help me. That's the only one it helped me with. But Go and Defer were both high on the list. I remember.
I was somehow waiting for else to be on the list, even though if and switch weren't. I was just like, if that's the case, it's just somebody trolling us.
Sometimes I think some of the answers in some of the questions, because we've asked loads of questions, so we have loads to choose from, and some of them are like you wonder if people are trolling or joking, and sometimes the joke answers enough people say it that it makes it onto the board as well, because it's quite funny. But I don't know. Yeah, it's interesting to get into the minds of people, I think, a little bit. Speaking of that, we've got a couple of minutes. Steve, what have you been working on lately?
I think I've been working on a lot of stuff lately because that's what I do. I work on a lot of different stuff. But I know I'll just kind of talk about some things that we're working on. A lot of work getting ready for generics release, which is coming up. In the release in February, but the betas should be, all the pre-releases we're working hard on. I'm also meeting with a lot of our users. That's a good part of how I spend my day is meeting with companies and individuals and projects who have adopted Go and just hearing their challenges and their successes. And
nice.
It's one of my favorite parts of my job, actually.
Yeah, generics, of course, coming in 1.18 in February. Katie, also fuzzing's coming. First class concern.
It is. I'm so excited that it's happening. I'm working very hard on documentation right now. We're kind of in the bug fix and polish and document phase. So I think it's going to be important for it to land with docs, or it's not going to land successfully if people can't use it. So that's the goal that I have right now for this project.
Yeah, no, that makes sense. I love the way that it interrupts with the existing testing stuff, and our knowledge of writing unit tests can come in handy for writing fuzz tests. I think that's a kind of really nice advantage to the fact that it's getting first class support rather than being a sort of external tool.
Absolutely. Yeah, that was one of the main goals. And I'm glad you like that.
Yeah, I do. I really do. Right. Well, thank you so much. It's been a pleasure. Rob, we had you, if our audience wants to learn more about Rob and Julie, check out our Go Time back catalogue and also listen to future shows because, they'll definitely be on it, hopefully. Thank you so much to everyone for joining this live feed, this game. It was a great time was had by most. Great time was had by most. And we'll see you next time. Bye, everyone.
Bye.
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 And just closing music. Here we go. Just smile. Don't let the smile go stale.
Thank you to the Go Time team and the Go team for, I'd like to say a show that did not disappoint, but there were some answers there that were kind of,
they were
or lack
illuminating.
thereof.
The answers were illuminating, though, for sure. Yeah.
We have some work to do.
Yeah, indeed we do. Yeah. Well, we don't have any work to do on the pun front. I'll share one from the peanut gallery.
We do.
Well, the fact that we do means we don't, right? I feel like there's that juxtaposition in there. Here's one from the peanut gallery to illustrate. We were talking about Khan Academy before. Someone wrote in, B Green wrote in, GopherCon. You can guess what the spelling was. Just that's one word, that's it. It's great, right?
Please tell me there's an accompanying picture of William Shatner screaming, GopherCon!
If only.
How did none of us catch that one earlier?
I know, right? We were going all over the board, but we forgot the simplest one. It was
like there. It was literally right there in front of us.
Seriously, oh man. Well, anyway, we should just give a quick thanks to all of our sponsors. Do go check them out on GopherCon.com and in the Discord. Go chat with them. There's giveaways. Many of them are hiring. You know, they're here. They've made this conference possible. So go check them out. Go give them, have some discussions with them and so forth.
I mean, coming up, we have another exciting speaker.
Indeed, indeed.
Got another return of an original GopherCon speaker.
An original.
Original GopherCon 2014.
Indeed, indeed. So for a lot of you in the Go community, this person needs no introduction, but for a lot of you who are new, and here over half of the community is new every year. Wow. You might have come across his projects. BoltDB is actually one I use constantly in my projects. He's here to talk to us about using Go and SQLite. He loves databases, and you're going to see that come through when he talks about that stuff. So please help us in welcoming Ben Johnson to the stage. Ben, all you.
Cool. Hey, thank you very much, guys. Appreciate it. As I stated, yeah, I'm Ben Johnson. I work a lot in Go and databases, and I'm going to be talking about writing production applications with Go and using this great database called SQLite. Just a quick background on me. I've been writing Go for quite a while now, about 8 years now. I write a lot of open source as well. So BoltDB is one example. It's a key value store. It's used in projects like etcd or Console. I also am writing a project right now, or have a project called Lightstream that we'll talk a little bit about later. A lot of my focus right now is getting SQLite really production ready and getting it to deploy out in all kinds of projects. I do a lot of blogging as well. So you can find blogs about Go project structure on Go Beyond. It's a blog I have. And finally, I just really love embedded databases. I think they're awesome. So this talk is going to be very biased, but I hope you follow along with me. So whenever you start a project with Go, you're always kind of the biggest question is, you know, which database do you choose? There's a myriad of options out there. There's traditional options like Postgres, MySQL, SQL Server, Oracle, those kind of things. But you have a lot of new ones as well. You have all kinds of options from Amazon, so RDS, Aurora, you have PlanetScale out now. There's just tons of database options. What do you choose? Now, a lot of these databases, they have benefits and they have trade-offs as well. A lot of these are familiar, so a lot of you have already used maybe Postgres already. A lot of these databases have been around for 40 years, some of them, so they're quite robust, and they just have tons of features in them. They just collect features over the years. Now, you get some trade-offs with all this as well. One thing is expense. So if you have a separate server to run a database on, that's an extra server to run. If you're doing cloud databases, they get charged per operation. And a lot of these databases get bloated over time with all these features. And then finally, the last trade-off, I think is one of the most important, is high latency. So connecting to another process or connecting to another server can really take up a lot of the time of your processing and your query speed. Now, in addition to the client server and cloud options, one I don't think most people consider would be SQLite. And it's, for a long time it was kind of considered a toy database or a test database, but really it's so much more. Like it's an in-process database, it's an embedded database, which means it actually gets compiled into your source code and deployed with your application everywhere it goes. It's super stable, super safe. This runs on all kinds of devices. So your cell phone has it installed on it. It's installed on airplanes. It's installed in all kinds of places. And it's been around for about 20 years now. First released back in 2000. Now, SQLite provides a lot of great guarantees like any other database. So ACID compliance. We're talking about atomicity, consistency, isolation, and durability. That means that whenever you write transactional data, it gets saved safely, and you can trust it. In addition, it has a lot of SQL support you might not consider. It has things like windowing functions. It has things like common table expressions, recursive queries, subqueries. Most of the things you expect from a SQL database are in there. And finally, it has non-SQL support. That's really great. You have full text search, so things like Elasticsearch you don't always need when you have the built-in full text search within SQLite. It also has JSON support. So if for some reason you are storing JSON in your database, you can query it. I don't recommend that generally though. So as far as when you should really consider SQLite. Historically, it was used in embedded software. That was kind of its biggest use case. It gets used on like edge databases, things like that, small resource-constrained servers, and that was kind of its purpose for a long time. Now, there's been a lot of improvements over those last 20 years, specifically in concurrency, so it does really make sense as like a multi-process or multi-threaded database. So because of that, it's really useful for read-heavy workloads. You might consider it for something that, like an e-commerce website, for example, where you have someone going to a lot of pages. Those are all read queries, and then every once in a while, maybe adding to cart or checking out. Those would be write queries. It's good for small to moderate request load, things like tens of requests or hundreds of requests per second, which probably covers most applications out there. And really SQLite has kind of grown so much over the years that it can kind of be considered a general purpose database for a lot of applications. Obviously no tool is used for everything, and they all have their specialties, but it's I consider it a good default to start with. I think historically I always consider Postgres as my option, and then try to think about why would I use something else. These days I really look at SQLite as kind of my default database, and then consider why I would use something else. So this talk's going to be split up into 3 different parts. We're going to talk about kind of the development side, the testing side, and then finally we're going to get into kind of the production database side and what that really looks like from a durability and a performance standpoint. Now, when you connect to SQLite, you have basically 4 options out there. There's probably some extras, but these are probably the most popular. The most common library out there is going to be the MatN library, GoSQLite 3, and honestly, this should just be your default. It's used in all kinds of places. It's been around for years, stable, and great. I have no complaints about it. This is one I typically use. There's also a project going on from Modern C, where they've actually transpiled, like mechanically transpiled, all the code from SQLite into Go, so you can actually compile it as a Go library. Then you avoid the CGO overhead and any issues around cross-compiling. Next, we have the low-level SQLite database. If you want to avoid the database/SQL library, you can use this one by David Crawshaw. And then finally, Tailscale is actually working on an implementation right now that has some improved benefits with concurrency over the MatN library. It's a work in progress, but definitely check it out. They're doing some good work. So when you connect to SQLite, this is actually going to be pretty brief. You use it like any other driver for database SQL libraries. So you import it with a underscore before, because you're not referencing the actual name of the library. And then in the SQL.open, you are going to just pass in the driver name, which is SQLite 3. And then for the data source name, instead of a URL or a network path, you're going to actually pass in the path to the file on disk. And then after that, from then on, that database connection, really you can just treat it like any other database connection. Now, I generally consider SQLite pretty configuration free. There are a couple exceptions here that are worth noting, and we'll kind of go over those. But once you get these set, there are some knobs you can tune if you really want to later on, but generally it just pretty much works. Now the first one here is probably the most important, I find. It's called the journal mode. And journaling in databases is how you safely write a transaction to disk. And what happens here is the default mode, the original mode, was called a rollback journal. And you'd write whenever you wrote disk or data to your database, it would go into, you take the old data, put it into a rollback journal, and then you'd write the new data to your database, and then you delete the rollback journal. There's a new mode in here since 2013 called the wall mode. This stands for write ahead log, and what this means is that you're going to write all your new data to the separate file instead of your database, and you get a lot of concurrency benefits with this. You actually get point-in-time snapshots for every transaction, as well as you're able to write and read at the same time. There is a limitation on SQLite where you only have one writer at a time, but you can have as many read transactions as you want. Next, this is kind of an odd one if you're coming from other databases. It's called the busy timeout. The busy timeout sets how long a write transaction will wait to start. Now, again, SQLite only supports a single writer, so that means if one's active and another write transaction starts, by default, it'll just fail immediately. That's not usually what you want. So instead, we'll set this to the number of milliseconds we want to wait. I usually use 5 seconds. Sometimes you can use 30, as long as it's more than 0. That's kind of the biggest thing. And we're going to use this format here with a pragma, which is essentially a way to set settings on SQLite. So we're going to do pragma, busy timeout equals 5,000 for 5 seconds. Final option that's really important is foreign keys. And a lot of these are for historical reasons as to why you have to set these things or why they weren't enabled originally. Foreign keys are not enforced by default, which is pretty surprising for most people. SQLite started off on very resource-constrained systems, so you didn't want to necessarily use all that processing power for foreign key constraint checking. So what we can do here is we just set pragma foreign keys equals on, and it'll enable enforcement for your foreign keys. So those are the main settings you want to set with SQLite, I find. Another side of SQLite you really need to kind of get used to is the type system. It's a little weird, but it's not as bad as a lot of people consider it. The first thing to note is that the type system is pretty small. You have integer, you have real, which is the floating point numbers. You have text for readable text and blob for binary data. But this actually pairs well with the Go type system. We have integers, we have floating point numbers, we have strings, and we have byte slices. And finally, we have null, which is kind of no data at all. Now, the really weird part about the type system in SQLite that people kind of get thrown off by is that a column isn't necessarily associated with the type, doesn't have like a strict type. Every value you insert into the system has its own type, and type definitions on tables and their columns are basically ignored by default. So here down below, you can see we have a create table with an X and integer and a Y text, but SQLite largely ignores those types, and you can insert text into X or you can insert integers into Y, and it'll just let you do it, which personally seems insane to me, but that's how they set it up. Luckily, actually, just only 2 weeks ago, they added support for strict mode, which actually enforces the column constraints and a couple other options too. So I don't have time to get into this presentation, but it's something to look into. The last thing you kind of caveat you got to worry about when you're developing is that SQLite kind of has some types I really wish it did have. It doesn't have. These two are timestamp and decimal types. For timestamps, while there's no type actually available within the type system, it does have some date-time functions, and these functions will work with 3 different types of dates. The first one is ISO 8601. In Go, this is known as RFC 3339. This is a string format where it's nice because it's actually lexicographically sortable naturally, so you can just sort them and use them in indexes, and it works as you expect. The other option, you can use Unix epoch, which is the number of seconds since 1970. This will give you an integer, which is, shrinks down the amount of space you're using for each column. And then finally, there's something called the Julian date. I would generally advise against this one because most people have no idea what it is. It's the number of days since about 4,700 BC. Again, it's pretty obscure, but there are some applications for it. But I would generally avoid that one. Now, the development side, once you kind of get it connected, get it up and running, it's really a pretty good pleasure to use once you get around those caveats in the type system. Another piece of it that's super nice with SQLite is the testing is just super fast. Now, the biggest thing with the type system, like if you come from an ORM that allows you to run against multiple databases, a lot of people will actually run their tests in SQLite because it is so fast. Again, it's built into your application and compiled in there. But the bigger thing is that you can actually, it has native support for memory-backed databases. This means you're not going to have any slow disk access, you're not going to have fsync calls. Everything actually lives on the heap. We can do this by setting the data source name, or the DSN, to :memory:, and then everything will just be in memory from that point on. And again, you just use a database like any other database, except now it's screaming fast. We can do some benchmarking here with SQLite. Again, this is very much loaded in favor of SQLite, but we're comparing this here, Go SQLite in memory versus kind of a standard Postgres setup that people use for testing. Both are the default configurations. and just kind of understanding how the performance changes. So with Postgres, certain operations you need to do that you don't need to do on an in-memory database. So if you need to drop if exists, you don't need to do that for in-memory databases because you wipe it out every time you close it. So for Postgres, we're talking 5.5 milliseconds. For create table, it's 3 times as long as the in-memory version, and some of that is just the connection time. And then when you get down to inserts and selects, it's again screaming fast, where we have 25 microseconds for selects and inserts versus around half a second for inserts and selects on Postgres. So again, it's not quite apples to apples, but it's a good idea to understand really the scale of difference between the two. Another thing you can do is parallelize your tests for SQLite. Again, because it is in memory, there's really a shared nothing approach between the different databases for each of your tests. You can use t.parallel to run these tests in parallel. There's some options on Go tests where you can flag the level of parallelization. The one caveat here is that SQLite 3, GoSQLite 3 has a global lock on its connection. So it'll actually slow down parallel tests. If you want to get better performance for these parallel tests, you need to use a tailscale implementation. Here's a quick benchmark here to kind of illustrate the point. So with GoSQLite 3 and tailscale, they both run at just under 1.5 seconds. And here we're running about 10,000 small tests. Each test opens a database, creates a table, does an insert select, some very basic testing, and then closes down. We can run that about 10,000 times, again in memory. But as we scale this out over more cores, for GoSQLite, it actually ramps up over time to 3 seconds and gets slower. Whereas with tailscale, you can see that it actually speeds up quite significantly. So on the development side, we've really seen where it can be pretty easy to get up and running. On the testing side, we find that it's screaming fast and we can just constantly test and get feedback and what we need. But then the thing that people generally worry about is production experience. And that kind of factors into 2 different ways. We have the durability side and the performance side. Now, before we get into too much on the durability side, SQLite specifically, this is kind of a quick aside about durability in general. I feel like over the last 10 to 20 years, we've had a lot of conversations around availability, where people had expectations of 100% uptime, and that's not realistic, really. You're looking at 99%, 99.9% uptime, and there's costs associated with trying to get higher and higher uptime. So it's really a trade-off of how much money you want to spend and the complexity around that system and what level of uptime you're expecting. However, on the data durability side, we really don't have that same conversation. And before we talk anymore, it's just important to note that there really is no such thing as 100% durable data. You can make as many copies as you want of your data, but you can always lose them all. So sad but true. Now there's kind of a spectrum of durability when we're talking about hard drives and systems. So when people think about running SQLite on an application, sometimes they just think it's like a server in your closet that has a hard drive, and that's not very durable. I mean, Backblaze puts out an annual report where they find, they check all their hard drives and see how often they fail, and they find that about 1 in 100 fail annually. So that's a 99% durability. 1 in 100 chance isn't too bad for a lot of things, but losing all your data, you probably want something a little more safe. Now, you can upgrade, look at something like cloud servers, where they tend to have a bit higher durability with their hard drives. They can be rated. They have other options around that too. EBS, most of its volume, so this is Amazon's elastic block storage. Most of their drive types have 3 nines of durability. This means that every year they lose about 1 in 1,000 hard drives. That's better than what we had with 1 hard drive, but still, it's not amazing when you're considering losing all your data. You can look at something higher, like IO2 on EBS. This has 5 nines of data durability. That means you have 1 in 100,000 drives fail annually. This is getting to something that's much more comfortable. You probably have a bigger chance of dropping the database or deleting a table than 1 in 100,000. So, it's something you can get more comfortable around in data durability terms. Finally, we have S3. This is kind of, on the far end of durability. It has 11 nines, which is crazy. That means you lose like 1 in a gajillion objects every year. So generally, when you put something in S3, you kind of consider it safe to be there. So when we're talking about data durability beyond just a single disk, we start talking about, one or more servers. So obviously, single server is going to be your fastest, cheapest option, but it's less durable. You have options for doing a primary replica setup, where we stream changes from a primary down to a replica. This is obviously more complex. You have double the number of servers, so there's additional cost. And finally, it's more durable. You have 2 servers instead of 1. There's also more complex situations you can get into. Distributed consensus, for example. You can have a cluster of servers that need to confirm rights before you let them continue. This is really complex, though. If you've ever run, say, etcd, you can kind of understand that there's a lot of complexity and performance you're trading off with using this. But on the other hand, it's really quite durable. You can lose multiple nodes, possibly, and still have your data. So I'll end this kind of aside, this little rant here, with a quick story. The idea here is that no data loss is good, but not all data loss is catastrophic. I'm not trying to throw anyone under the bus here. I think GitLab did a great job documenting an incident they had 4 years ago. So in 2017, they lost about 6 hours of data, which sounds, that's rough. No one's going to have a good day with that. It's unfortunate, but it happens sometimes. They had a primary Postgres replica setup, so streaming data from one primary to a replica. However, the replica just stopped getting updates for some reason. They were trying to figure it out. And during this, while they were trying to figure it out, the operator accidentally deleted the data on the primary when they deleted it on the replica, and they lost 6 hours. So terrible, but GitLab's still around. They haven't fizzled out. In fact, they actually IPO'd this year for $16 billion. So again, this is really a trade-off. No data loss is good, but it's not necessarily catastrophic. So I'm not encouraging data loss by any means, but I think it's something to consider how much your data costs and what you're willing to trade off for it in terms of durability and performance and cost. So with that all said, let's talk about data durability in SQLite specifically. So your first option you should probably consider is just honestly regular backups. If you're talking about running something like IO2 on EBS, you're already getting, tons of durability with that in the first place. And then if you're regularly backing up, then you really have a fallback plan anyway after that, if it fails. So regular backups, the pros here is it's super fast, super cheap, and it's really hard to mess up. It's not a lot of configuration. The main trade-offs here is that you start to get a bigger data loss window. So a data loss window is when you just have data that hasn't been backed up and you lose your primary data set. Anytime in between the last backup and your current data set is your data loss window. Now, you can set up a regular hourly backup or daily backup to, say, S3. And again, SQLite is just a file, so it's really simple to work with. We can back it up, we can compress it, shove it up on S3, and don't worry about it, which is nice. We can use a time-based file naming scheme here. So if you want to name it after the current hour, you can just have it replace the current or the previous snapshot from yesterday, and just have a rolling 24-hour backup, which honestly works great for a lot of applications. The other thing too is B-tree databases, which is most SQL databases. They compress really well. There's usually a lot of extra space in there so that they don't shift around records when they update and insert all the time. And it means that if you have, say a gigabyte database, you can compress down to, a couple hundred meg, and it's not as painful. Also, something else to note with S3 that's interesting is that they make it so it's very cheap to get data into S3, but very expensive to pull it out of. So it works great as a backup solution. You don't do a lot of operations where you're restoring constantly, but those operations pushing it up can be quite cheap. So SQLite has a command line, SQLite 3, and here you can see that SQLite 3 will pass in the name of the database. That's mydb, and then we pass in the full command here in the double quotes, which is going to be .backup, and then the name of the file we want to back up to. So again, back it up to another file, compress it, push it up on S3, and yeah, generally actually works pretty well for a lot of applications. Now, if you can't handle that data loss window of an hour, that can be pretty long for a lot of people, even if you have, again, say 5 nines of durability on IO2. You can look into other options. So this is Lightstream. This is a tool that I created. So obviously I think it's the best, but every tool has its situation where it works well in. So the idea with Lightstream is that because S3 is super cheap to back up to, is that we can actually continuously back up to Lightstream, which is really nice. Sorry, to S3. So what Lightstream will do is it'll snapshot your data at the current point in time, and usually once a day. And then whenever you make changes to your database, it'll read those off that write-ahead log that we talked about earlier. And then it'll compress those, push them up to S3. And if you ever need to recover your database, it can pull down that snapshot, replay all the pages from the wall after that, and you'll have the exact same byte-for-byte database afterward. This works too if you have catastrophic failure. You can set it up to automatically restart and reload and go with that. So again, a bit more complex than your regular backups, but it's a pretty nice option. One user of this, Michael Lynch, he's written a blog post on this where he's looked at moving from different cloud services over to Lightstream, and he found that he only spends about 3 cents a month on these the S3 backups. So he finds it as a great, super cheap option. So something to keep in mind. If you do download it, Lightstream actually runs as a separate process. SQLite supports multiple processes connecting at the same time, and your actual application has no knowledge of Lightstream. It's really like an ops consideration. So here we have Lightstream command. There's a subcommand called replicate, and we'll pass in the path to the database, which again is just a file, and then we'll pass in the S3 bucket. Here's just kind of a visualization of Lightstream. So we have our database on our application server. Whenever it has changes, it tacks those onto the wall, and then Lightstream is pushing up snapshots and continuously pushing up new wall pages as soon as they happen. So this is again a good option for reducing that window of data loss, but again at a trade-off of a little more complexity. Finally, on the durability side, the most extreme example, once you get into data durability, is clustered SQLite, which is a bit of an oxymoron, it kind of seems, but it works for some people. So the pros to this is that it's super durable. I mean, you're going to run a cluster of servers, so the cons here are obviously that it's going to be more expensive. 3 servers or 5 servers is going to be more expensive than 1, and it's significantly more complex. If you've ever run etcd before and tried to manage that, it can be sometimes a bit of a headache. So keep that in mind. And these kind of get split out into a few different types. We have Raft-based. So Raft is a distributed consensus protocol. etcd uses Raft, for example. But RQLite was written by Philip O'Toole, and that's a great option. He's done a great job with that. Canonical also wrote their own implementation of a distributed SQLite called DQLite. And then we have on a primary replica setup, where we stream from a primary server to a separate replica server, we have something called Light Replica. This one, I haven't used this personally. It does have a GPL license, so watch out for that if that's a consideration you need. But they do have a commercial license you can check out too. And then finally, there's kind of a crazy project from Expensify called Bedrock. I haven't personally used this one. It's blockchain based, and I have no idea how they do it, but it sounds very complex. Apparently it works for them, so kudos to them, but I have not used it personally. So, on the performance side, we got durability. And if you're comfortable with the durability story, then performance is kind of the next thing you really need to consider when you're talking about performance. Production. Now, performance between SQLite databases is always hard to kind of quantify. You always see synthetic benchmarks out there where one database is X amount faster or X percentage slower, but really you kind of have to test it with your own workload to know what is actually going to happen in the real world, because they're all, again, synthetic benchmarks. Now, the caveat here is that most SQL databases in general are B-tree based. That means they have the same underlying data structure. And because of that, a lot of the performance profile is generally going to be fairly similar. Some are going to have a bit better performance, some are going to have a bit less performance. It's really hard to say for each situation. One might be better than another. However, the one consistent thing is that network latency can be a huge component of performance, and this is really where SQLite shines, because it basically skips over the network piece entirely, because it lives right in your application. So doing some benchmarks here against SQLite versus Postgres, we're doing point queries in this instance here. So it's running about 10,000 point queries on a fairly large database, and we're calculating the time it takes on average for each query. So for SQLite, we see it's way down there at only about 18 microseconds, which is screaming fast. And then, once we start going out of process to another process over some kind of network connection, even on the same box, so Postgres running on the same box, still takes 10 times as long just to get that one point query. Again, this is connection overhead. This is serialization. There's all kinds of overhead here that you need to consider. You just don't have a SQLite. Again, it's a lightweight database, but again has some features too. Once we move out of the same server into the same availability zone here, we see that it jumps up. It basically doubles. This is all run in AWS. But we see that it goes up to 300 microseconds. Again, not a ton of time, but if you're running hundreds of these queries or even tens of these queries, that adds up to real numbers. And then finally, running it within the same region, we see it gets 3 times as slow. We're now up to almost a whole millisecond at 900 microseconds. So going down from SQLite at 18 microseconds to, same region at 900 microseconds is a huge jump. Now, that's how most people set up their applications when they run their own database server. If you start running against a cloud server, that's a whole different story. It might not even be in the same region as you, so you need to really consider latency at that point. So once we add in cross-region latency, we really start seeing big numbers. This is adding in US East 1, so Virginia, to US East 2, Ohio, which is not very far away, but it still takes about 11 milliseconds. You can't even see SQLite at this point on the graph. It's so tiny. But it's something to really consider. This network latency is going to be a big part of your performance. Now, you might consider that queries can run in parallel, and that works in some situations for sure. But we see when we do parallelize them, we get better performance generally, especially as we have more network overhead. But we really don't get anywhere close to that latency of SQLite, because again, it's in process and it's so close to your data. Now, a lot of times you can scale up a single database on a single server quite large. We have AWS where it can scale out to 96 cores or some ungodly amount of RAM, which is great. Our machines keep getting faster every day. If you ever do reach your maximum of what you can store on a single server and process on a single server, it's time to start thinking about moving horizontally. And horizontal scaling in SQLite is not an often talked about topic because it's kind of seems antithetical since it is an in-process database. However, the benefit here with SQLite is that it's so flexible. It really is just a file. That's all it is. So we can do some pretty interesting things that you might have a harder time doing in other databases. So, for example, if you wanted to isolate your tenants, put a single tenant per database, which can improve your security. They're all just individual files. So we can move them around. We could put them onto a cluster of servers and then distribute those tenants based on like a consistent hashing scheme. This talk, we don't have time to go into consistent hashing schemes, but it's something to consider if you actually do want to fan out your tenants and their data over a network or over a cluster. So again, options out there if you really do need to scale to those bigger data sets. Now, as much as I love embedded databases and SQLite, there's always times when you just shouldn't use a tool. So, I want to, get into that. It's not all sunshine and roses out there. There are considerations here as well. I would say the biggest time when you don't want to use SQLite by far is if you have a working system. Please do not rip out your database and put in SQLite. your colleagues will hate you. You'll never find happiness in doing that. So definitely avoid that with a working system. A good way to do it is to start off small, have a smaller application, get going with that. And if you really like it, there's always some operational pieces you need to learn around any database. So it's good to get comfortable with that at a smaller scale for sure. Another piece you want to kind of avoid, if you have long-running transactions in your database, usually you don't want those in any database really. With SQLite, it's really a requirement though, because it has that restriction of a single writer. Other databases get around it with some optimistic locking schemes, which can work to some degree. Generally, you want to avoid long-running transactions. Another time to really avoid it is if you have like a truly ephemeral serverless environment. If you don't have a disk, or if your disk suddenly disappears when your service is done running, it's definitely time to, you're going to lose all your data. So that doesn't work great. There are some options out there. Services like fly.io, they kind of work similar to Heroku. So you have kind of those kind of dynos or kind of serverless environment, that kind of feel. We can push up to basically a Git repo and deploy. You can do that, but they actually provide persistent disks as well, which really helps a lot. So that's something to consider. Just to kind of wrap up here a little bit, SQLite's great, in a lot of different ways. It's kind of a different paradigm from what you're probably used to with a client-server database or a cloud database, for example. Going back on the development side, it's great because there's just no dependencies at all. You import a library and you're done, basically. There's not really any configuration. You just get up and running. You don't have to worry about users or grants or privileges. It just kind of works. There's not much configuration. We have kind of those 3 pragmas that we set, the journal mode, foreign keys, that kind of thing. So make sure you set those. Those are important. And then, again, the type system, it's kind of weird, a little esoteric. But it actually works pretty well against Go's type system and enforcing your types at the application layer. And then as far as types go, timestamps and decimals, those are always going to be tricky. But generally, I would say that RFC 339 timestamps work pretty well. On the testing side, the in-memory support is fantastic. You get your tests running super fast. You can just constantly run them whenever you make code changes instead of waiting seconds or minutes. You get your feedback in sub-second, even for hundreds of tests. There is parallelization you can use, but again, there's a caveat with that. The Go SQLite 3 library doesn't work as well with parallelization, and you really need to evaluate kind of the tail scale implementation, even though it's it's still a work in progress. On the production side, once you actually do put it out there, there's a couple different options. Again, you have your regular backups. Again, some people may scoff at this, but it's really a great option, especially once you have very high durability drives anyway. You have a known data loss window, but it still works great, and you put yourself at pretty low risk of data loss in general. If that doesn't work for you though, options like Lightstream, where you can stream your backups up to S3, also work pretty well. Again, you're going to trade off a bit of complexity for that, so just kind of know that going in. And then finally, we have clustered SQLite, which is kind of on the extreme, where we're using something like Raft to replicate, either through RQLite or DQLite. We have Light Replica, which is a primary replica setup, or there's Bedrock, which is the blockchain-based one. Although if you're getting into clustered SQLite, again, there's not as much of a difference of just using a regular client-server database at that point, so that's something to consider too. On the performance side, single node performance is just screaming fast. Like, you can't beat it. Once you remove that network latency and your serialization overhead, you can really do so much and bring your request times down significantly. And a lot of times you just don't have to worry about things like N+1 queries, and there's just a whole class of performance problems you generally don't have to worry about with SQLite. And then you can scale it up. There's pretty large nodes out there, either on AWS or whatever service you use. And you can also scale it horizontally with some creative ways. Again, SQLite is just a file, so it's super flexible. So really, in conclusion, I hope you give SQLite a try. I love the database. It's not great for everything. Maybe you'll hate it. Maybe you'll love it. But I think it's worth a shot. And yeah, I really like it a lot. So thank you for listening to my talk. Really appreciate it. You can reach me either by email, or you can find me on Twitter as Ben B. Johnson, or pretty much anywhere on the internet as Ben B. Johnson. And yeah, thank you very much. Back to you all in the studio.
Thanks so much, Ben. Oh, that was a lot, and the main thing I took away from that was, we have a simple option. I was about to say SQL option, which we also do.
That is an option.
But we have a simple option we can start with, right? You don't necessarily need to start up a Postgres or click the button on your cloud provider to get a Postgres or a MySQL. You can just get started, single node, write your app, get it running. When you hit the front page of TechCrunch, maybe then you get your Postgres in the cloud or whatever.
It's kind of sad because I feel really old thinking about the fact that used to be the /dot effect.
I know, right?
The number of people watching this who are going to be like, what is that?
What's /dot? Yeah. For those who don't know, /dot used to be the popular geek hangout. But
and then
no
it was
longer.
Replaced by Dig. And then,
Dig.
And then what came? Was it
the
Reddit
upvote
next? Yeah, that was the first play. Well,
that was at least the first popular implementation, right, of the upvote.
Yeah.
And the downvote.
Yeah, and then remember Pounce?
Pounce?
No.
Yeah, it was created by the creator of Dig and somebody else. And
I heard that.
That's how Pun Master recognizes another Pun Master.
Yes, the Pun Masters have spoken. Yeah, now I heard there was something blockchain in there. Did anyone catch what that was? I know there's replication, and that stuff is like very cool, very cutting edge. I never would have thought to replicate SQLite or backup SQLite like that. But I caught some blockchain strategies to do replication in there, which according to Discord is really just Merkle tree based replication. But we got blockchain at the conference now.
We have to somehow. Well, do we have to somehow include blockchain in this?
Does that mean we should mint an NFT for Ben's talk?
Ooh.
Yeah, we do. That's the law. That's the law now. It's the U.S. law now.
We have to mint an NFT. Yeah. we need some Gopher minted NFTs.
Yeah, sounds good. Well, I know you had an unpopular opinion the last Go time about blockchain.
I know, right? That might be my actual very first unpopular opinion on Go time.
But now your first unpopular opinion in general, right?
And then, I know, right? Yeah, I know, right? Yeah, I said blockchain developer was the new hotness of jobs. And people are like, nah, man, nah, we refuse. We refuse.
I mean, just because you don't like it doesn't mean it's not popular.
I'm just saying, there's always going to be somebody somewhere trying to make money on some poor souls. So
even if it's not, this will hit some Discord people, it'll rub them the wrong way. Even if it's not real money. Peanut Gallery, what do you got for me? Let's hear it.
I think this might be one of those times where we actually are very fortunate that we are not in person.
Maybe
they might meet you in the parking lot.
There will be peanuts coming.
There will be, yeah, exactly.
Yeah, that may be my unpopular opinion there. Yeah. All right. Well,
I heard we might be saving the best talk for last.
I heard something about a talk. Is it the best? Maybe we'll have to see.
I think it's the best. I mean, look at the speakers, the caliber of speakers that are in this thing. I mean, one of them, both of them have been in the Go community for a long, long time. They're passionate about this community. They invest time in it. They're funny. They're charming, handsome. It's like very eloquent. Of speech. It's like how can you not be looking forward to this talk? And obviously, I'm talking about me as one of the as one of the speakers, and what's better than having one great speaker up there is having two. Who's joining me today?
This Aaron Schlesinger, this guy Aaron Schlesinger, and he wore his best shirt for this talk. He dressed up to the nines.
You needed to
for
make
this
sure that there was just lots of attention.
Yeah,
Yes.
yeah. I wore a really loud shirt. I went with blue instead of gray for all of you and for you too as well. Yeah.
Yeah. So Aaron is gonna be the moon to my sun, right? He's gonna be dimming down the light, the brightness of my shirt. With his own.
Johnny turned it up to 11, and I'm here to turn it back down to like a 7, 6, something like that.
We have neighbors.
Yeah, come on, let's not go overboard.
Let's not go overboard.
Yeah.
All right, so I'm thinking we walk on over, to the area where we do our thing, and then you gonna be okay, buddy?
I think I'll be all right.
Yeah.
It's gonna be a little lonely.
Leave you some toys to play with.
It's gonna be
exactly.
Leave you some friends to play with here.
There you go.
They'll keep you warm.
You keep making jokes, so I'm gonna barge in. I know where you're speaking.
Maybe we have that to look forward to. We'll see you at the end.
All right, let's make it happen.
All right,
we're gonna walk over. We should have some like music and tunes as we start running down. Run down to the podium to go do this.
Yeah, let's do it.
Oh man. All right. Here we are looking at our blank editor here.
So what are we going to talk about today?
So I was thinking, right, that every year we hear about how we get a lot of new folks in the joining the Go community for the very first time, and they're curious about Go. They're picking up some tutorials and picking up some of the idioms of the language and things like that. And everybody comes in, they're like, hey, Go routines and things, concurrency, that's one of the draws of the language, right? And a lot of times, we end up also seeing some misuses, right, of the concurrency. Concurrency is great in Go, but you can easily get yourself into trouble, right, when you have too much concurrency. There is such a thing as too much concurrency, right?
And, we get this toy. We engineers love toys, right? And we get this Go keyword.
Oh, man.
That's the toy.
That's all it takes. You put Go in front of a function and off you go, right? The puns follow us wherever we go.
You all thought it was over when we were over there.
No, we're gonna be all up in it. So I was thinking that one thing we could do is by introducing sort of a simple little program, simple little concept, to sort of add some sophistication to it as we go, and to sort of introduce some patterns and some ways of reasoning about a concurrent program. So I thought we'd build like a quick little port scanner together. What do you think?
Sounds great.
Sounds great.
Like a plan.
So before we jump into building that, let's actually quickly go over what a port scanner actually is. Okay. So I have a quick little slide here that's gonna sort of illustrate sort of the communication that happens right between a client and a server, right? And the client could be another server, right? Whatever the case may be.
So one person initiates some network
contact to it, to another server, maybe on the other side of the world, wherever the case may be, right? So usually there's a synchronization packet that sort of finds its way from the client over to that server. If the server wishes, right, to engage in that communication, right, maybe there's no firewall or maybe there's no rule that says it can't talk back to that initial request, it sends back an acknowledgement, right, of that initial synchronized packet, right? And the client now says, okay, I'm going to acknowledge that you sent me an acknowledgement to my original synchronized packet. So there's a joke there somewhere.
I acknowledge your acknowledgement.
I acknowledge your acknowledgement.
And then we get another acknowledged 3 times 3.
Exactly.
Acknowledge cubed.
Exactly. And then at last, right, the connection is established. Now we can actually talk back and forth with each other, right? So that process of actually connecting over to that client, that needs to happen on a port, right? So the server must have a process, right, running locally that is bound to that port, to a port, right, whatever port you're trying to connect over. There must be a process listening on that port, right, for the host to actually receive your incoming request and says, okay, yeah, I do have a process running on that port, so I'm going to facilitate that communication, right? So when we talk about port scanning, really what we're doing is basically saying, hey, given a range of ports, can I go through the list quickly, right, for a given host and sort of enumerate, right, the list of open ports, enumerate the list of ports that I can actually initiate some sort of connection onto. Not that you're actually going to exchange any data, you just want to see, you're just probing, right, is this port open?
So we're going to be doing some heavy duty, kind of low level networking we're going to probably expect a lot of times to fail, to not be able to connect. But we want to figure out what are those times and what are those ports that we can connect on successfully, right?
Exactly. And Go, right, exceeds at this particular kind of application, right? It goes, the standard library provides a lot of the building blocks, right, to facilitate, right, the creation of these kinds of programs. And a lot of our work today is going to be based on the net package and the dial function, because it abstracts away a lot of this sort of, handshake process, the back and forth, handling, drops and packets and all that stuff. Like all that stuff is sort of a low-level concerns that we as the developers, basically using the standard library package, don't have to worry about.
And we're going to be doing almost everything with the standard library here.
Absolutely.
There may be one or two, but 90% of our work is standard library.
Standard library.
No external dependencies.
Yep, indeed. So let's flip back over, right? So the way I usually like to do these things is to basically, our task, right? What we've been asked to do is to create this port scanner, and I usually want to start with the simplest thing that could possibly work. What is the minimal effort I could put in to just test out the idea, right?
Kind of similar in spirit to what Ben was just talking about. Is we don't necessarily need to go and start up another database and all that. Let's just take what we got, run it on the same machine. Here, we're kind of following the same spirit. Let's get the simplest thing working and then evolve it over time. We're going to see 9 evolutions of this.
As we go. Yep, exactly. Yeah. So what we have here is really the bare bones of what could possibly work. So we know we're going to be using the net packages dial function to actually initiate that connection. There's going to be a TCP-based connection, and obviously the standard library, the net package, supports all kinds of connection types. TCP is only one of a handful. So we're going to basically hard code the port that we need. For now, it's port 5432. I happen to have a Postgres server running locally on that port, right? We're going to see if we can actually establish a connection on our local host here and on that port and see what we get, right? And then we'll try it, on a port that we know is closed, and then see what the response is. That way we know what to look for an open port and a closed port. Right? How does that sound?
That sounds great. And look how, this is. This is 18 lines, including the new line, including imports, but really we've got line 10 through 16. Some of that's error checking.
Yep.
The Go standard library makes this pretty easy.
Makes it absolutely very, very easy to do.
Yeah.
So let's actually do a quick Go run here. This is the simplest thing, right? And then let's just run this. And it says it's open, right? And then what I'm going to do is I'm going to change this. I'm going to change my port here and say 5433, right? And then I'm going to run this again. And then now we're going to consider that port closed.
Right.
So let's talk about the output here. Okay. So when we call net.dial, right? So let's look at the results, the responses that come back. So we're going to get back a value of type netcon, right? That's going to be the connection value that we can use, the object, if you will, that we can use to do other things with. Maybe we want to start exchanging data. Maybe we want to send some text over and see what we get back. But that we don't particularly care about that. Our job is to find out, is this port open or not, right?
So we do have some methods on that struct that comes back. We're not going to use them today,
right?
But we could, in the future, if we want to do some communication with the server once we connect to it or what have you.
Exactly. What we're going to worry about more so today is the error value. Okay. In other words, for whatever reason, regardless of why an error was returned, we're going to consider that port closed for intent purposes, because whether or not it is closed because we couldn't reach the host or because there's nothing listening on or bound to that port on the host, we don't particularly care. An error was returned, maybe at the time we timed out trying to get a response back. It doesn't matter. We're going to consider that port closed for intent purposes. That's why we have the different responses here. 5432. Again, I have a Postgres server running that we were able to sort of successfully get a connection back. But in the cases where it was a different port that we couldn't get a response back, we're going to consider that closed. So that forms the foundation, the basis for the evolution, right, of our program and the next steps.
Well, that's great. This is not a lot of code. I've used Go for a while, so I happen to think this is very understandable. I think someone from Java or even Python, C, C++, they can come in and get a pretty good grasp on this pretty quickly.
Absolutely. But the thing is, we haven't done any sort of a scanning yet, right? So, remember, we're typically trying to enumerate a list of ports, right? So let's basically, augment our previous program by simply saying, hey, let's just range over a couple hundred ports, right? I think that's more appropriate for a scanner, right? So let's actually see, right, when we run this version of the program, what we get. All right,
So let's go full screen on this. So here we are. We've just scanned a couple hundred ports, right? And we're seeing that the same sort of an error result that we can expect when the port is we consider that port closed, right? So if we scroll down, we're scanning ports, we should see 5432. Here it is. Boom. This is a port that was open before. So now we've enumerated a list, right? Now we have ourselves a list of all the ports that we consider to be open. But are you noticing a pattern here with our scans?
Yeah, I mean, we're doing these in order, one after the other, sequential. In this case, we're doing 5300 to 5500. It was pretty fast on your machine, so a pretty modern machine.
Right.
But, what if we're getting into the cases where we want to do tens of thousands of ports?
Right,
Maybe
right.
I mean, a lot of ports.
A lot of ports.
Hundreds of thousands might be a little out of the realm of reality. But yeah, let's say 5,000, 10,000 ports. Also, you've got some number of cores greater than one on this machine.
Right.
But we're only using
I could
that
probably
one.
use more of those things, right?
Especially we're writing Go, so this might be a good opportunity to explore making this concurrent and probably parallel as well.
Yeah, exactly. And the other thing is that there is no real dependency between one port scan and the next, right? So there's a term for these.
I love this term. You want to take this one?
How about we split it?
Okay.
Embarrassingly parallel.
Oh, we're not splitting the word. Oh.
We're supposed to go together.
Okay.
Get it together.
1, 2, 3. Embarrassingly parallel. We didn't rehearse that at all.
That was completely off the cuff. Right. So we know that we there's no dependency from one scan to the next. So there's an opportunity here, right, to sort of make the work concurrent, right, enable that parallelism. And because I have multiple cores on my machine, we are going to hit some parallel workloads. So let's see if we actually turn this sequential program, this procedural approach to our port scanner into something a bit more concurrent.
And this is where we get to use that toy, that keyword.
Yes, indeed. This is where we actually get to use our toy. So I've been told, right, that the only thing we need to make a Go program go faster, make it concurrent, right, just slap some Go keywords in places and off we go.
Let's see
what happens.
Let's see what happens.
So what we did here, right, we basically create ourselves a little sort of anonymous function that we are going to invoke. All we did was we moved our port scanning code, right, into that anonymous function so that we can actually, sort of run that concurrently, right, outside of the main Go routine, right, and then making sure not to have a variable shadowing going on here, making sure we pass in an actual copy of the port that we want to send in so that we don't get us into trouble with the loop variable. And then basically it's doing the same thing, right? If we got an error back, mark it as closed. If we actually got to here, consider it to be open. And then we're gonna say, hey, we're done after we've done the work. So let's see what happens. Oh. What happened there?
We got no output from any of the Go routines.
From any of the Go. That was a little too fast, wasn't it?
It was a little too fast.
So what the heck is going on here? Can you tell me what I did wrong?
Well, when you have a Go keyword, that means that you have scheduled the Go routine. The Go runtime is going to schedule the Go routine. It doesn't mean it's going to start running it. It doesn't mean it's going to wait for it to be over. And that's kind of one of our first rules of the day, right? We want to know, we always want to try to know when the Go routines are done, not just schedule and not just started. We don't necessarily need to know when they're started. We need to know when they're scheduled and when they're done.
Exactly. And in this case here, we just scheduled them and we just kept on going in our merry way.
Hope for the best.
Just hope for the best. Because a lot of folks often don't realize that the moment you start running a Go program, you are running Go routines, right? In most cases, right, if you just have your main, if you have everything happening inside of your main Go routine, that is a Go routine, right? So now when you fire off other Go routines, you need to somehow synchronize them. You need to somehow allow one to wait for the other, right, or others, or whatever they're launching. You need to synchronize them somehow. So thankfully, the Go standard library makes that process a lot easier. And there's a package I'm thinking that actually is going to help us add some synchronization to this problem.
Let's go check out what that package is.
Let's go check out what that package is.
And most of what we do from this point on is going to be all about synchronizing these Go routines. We kind of got this pattern where we've got n+1 Go routines, where n are the workers, and then that 1 is the main Go routine that you were talking about. And we're going to do a lot of synchronization between the 1 and the n.
And exactly. So the standard library has the sync package,
right? Basically, the sync package is going to provide us all of the building blocks that we're going to build on moving forward for this particular program. So this is where we also start to add some sophistication, right, to our project. Basically, I'm going to parameterize the host, the from port, the to port, and other versions of this program are going to have similar sort of configurability as well as we go. So I've got some defaults here. So I'm basically saying my default from port is going to be 8080, my default to port is going to be 8090. So if I don't override these things, I'm going to have just a small range of 10 ports to scan. So, and basically the rest, I'm not going to go through every line here. The rest, I'm just doing some checks and making sure that, okay, you're not sending me a letter as opposed to a number for port scanning and that kind of thing. So let's get to the good part.
8090 to 8070, just negative.
Right, exactly. Basically, yeah, that wouldn't be so good.
Yeah, right.
But so this is where, starting at line 39, this is where things start to get a little interesting, right? This is where we actually initialize. Well, I should be careful here. This is where we declare, right, a wait group. So why don't we have to actually initialize this wait group?
Well, if we look in the docs for the sync package and we scroll down to the wait group type, it says that the 0 value is initialized.
Right, the 0 value is useful, right? Yeah. Which is another idiom in the Go community that basically you hear folks talk about, make the 0 value useful. This is actually the Sten library living up to that mantra of making that 0 value useful. So we don't have to give it a value or anything like that. We can simply declare it, and when we actually start using it, like when we say wg.add, for example, it's already there. You're not going to get a panic because you're referencing calling a method in a nil object or anything like that. So you're good to go, right? So before we talk about the add, though, we have to think about what are we adding? What is it that we're going to be waiting on, right? So the wait group, right? The way that works is that you have to specify some sort of counter. You have to specify how many things you're waiting on. So how do we get that value? How do we know ahead of time how many things to wait on?
Yeah, so we've got our list of ports. So we're basically saying, well, we've got X number of ports. So I should say N number of ports, right? We're going to want to start up. For this exercise, we're going to start up a worker per port in the list. So we're going to say, all right, well, how long is the list? How many ports did you configure when you ran this code? Right. How many ports did you want to scan? We're going to do our WG add and pass the length of that list.
Exactly. And one of the empty patterns that we generally want to avoid is one where we're actually calling this add right inside of the invocation of the Go routine, right? So you're going to see out there as you start to learn Go, and you're going to start to see some tutorials and some code snippets that they don't always sort of provide. They solve the problem, yes, but they don't always provide sort of the best practices. So this is one of the ones where you actually should try. If you know ahead of time, especially if you're using a wait group, that means that you have some knowledge of how many of these things you're about to launch, right? Just basically call the add method just once because you know ahead of time how many Go routines you're going to be waiting on. In this case, it's our range of ports, right? Do a quick little calculation.
But if for some reason you don't, make sure to call it before you launch that Go routine. Right. That is, if you ever call wg.add like right before the defer wg.done or inside the Go routine somewhere else, probably not correct. Right? That's a pretty good bet that there's something wrong.
Something smelly with the code.
Smelly is a good way to put that.
Yeah, exactly. So we're not doing anything special here. Again, we're going to iterate over our list of ports, and for each port we want to scan, we're going to fire off a Go routine and let the work happen inside of that Go routine. And we have to ensure that when we actually, the work is done within that Go routine, that we decrement the counter that the wait group is using, right, to help us wait on the work to be done, right? And where is that work happen? Where is the waiting happening? Well, that happens on line 54, right? You have to remember that, if you can issue, you can make use of the wait group, you can add the number of counters, but if you don't wait,
what's the point?
There's no point. Right? So that's the coup de grace right there. This is line 54 is really what you want. This is where you're telling the main Go routine that that you've just launched a whole bunch of different Go routines from line 43 on to 52, right? That you need to actually wait for these things. And inside of those Go routines, this is what the wg.done is doing for each one of those Go routine. Every time the work is done, subtracts from the counter, and then at some point, wait stops blocking, right? And basically hence control back over to our main Go routine.
So blocking. What does that actually? What does that mean when you say wait is blocking and then it stops blocking when the wait group goes back down to 0?
Right. So our scheduler, right, is always scheduling. Okay, who gets to go next? Who gets to actually do the next piece of work, right? And so our scheduler is the one controlling, right? Who is next in line? Who gets to do some work? When do they get paused? When is control handed over to another Go routines and whatnot, right? When we talk about blocking here, and especially in our main Go routine, basically we're telling the scheduler, hey, we want, right, to get some work finished, right? But this thread needs to be paused, right? It needs to be stopped in its tracks. It's to wait right here until we're ready to move forward.
So we are literally going to not execute anything after the wait until the other Go routine, those N Go routines, are all done, and they've called wg.done each of them.
N number of times. That way the wait group knows, okay, now we can proceed. The Go scheduler hands control back over to the main Go routine, and off we go again.
All right.
Right. So now let's now see, right, the improvement, right, to this version of the program. So by default, we're gonna have, hey, there we go. That's our list of 10 ports. Before we just saw done, right? Wasn't too useful, right? Basically, everything just we didn't wait for the Go routines to be done. Yeah. Now we actually waited on this.
And this is going from 8080 to 8090. So
yeah, just a small range. I've got enough cores on my machine. This work was done pretty quickly, right? So this is the part where I want to actually see what happens. Again, this is with a very small range of ports, just a handful, right? What if I now package this, ship it, right, and all of a sudden the customer, right, the user of this program decides to throw you a curveball, or rather they decide to actually use it in an unexpected way, right?
Otherwise known as testing and production, right?
Exactly. So they decide, okay, hey, you know what? I'm gonna use this nifty, port scanner, and I'm gonna scan from say 1 to 65,000. Like a very do I have my number of zeros correctly? There we go, that's better. So, yeah, I'm gonna have a very I'm gonna give your program a very bad day. So if we try to do this now, actually I need to specify the argument, right? I need to say I think you're right, it's from port. I might even have that in my, there we go. Yeah, we're gonna use this one. So we're gonna go from port 5,000 to port to 65,000. Let's actually see how our program behaves as written. So here we go. So here we go. Ooh, that did not go well for us.
That's called taking up too many resources.
That is called taking up too many resources, right? So this error is very different from what we were getting before. So now this is our host. This is our operating system telling us, you're using up too much, right? I haven't allocated that many file handles for you to be able to open, right? The operating system is protecting itself in this case, and it's basically going to prevent your program from operating, optimally, right? So we're handling this particular error. We're outputting, what went wrong, but obviously our program is not operating to spec.
And this isn't a great experience either, right? We would like to still scan all those ports. We would like to still do it concurrently and in parallel.
Right.
But obviously the operating system is not able to give us the resources we need to do it in this unbounded way.
Exactly. Hence the title of this talk. This is exactly what unbounded concurrency looks like, right? But you're not constraining your program to the context in which it is going to run. In this case, yes, we could launch 65,000 Go routines, right, to do the work, but that's not the point, right? The point is for us to actually be good citizens within the environment in which we are actually operating and running, right? So we need to constrain this program in some way. We need to somehow control the number of Go routines that we have doing the work, while enabling, right, for the concurrent work and for the speedy work to get done without running afoul of system resources that we've been allocated.
Yeah.
So I'm thinking we need to introduce some new concepts, right, for this particular program. So I'm thinking this is where we introduce the concept of a worker pool. So what is a worker pool, Aaron?
Well, before we had this unbounded thing where we were just doing Go and we launched a Go routine, and the number of Go routines we launched was dependent on what the user gave us, right? So we did whatever it was, almost 65,000.
Yeah, so 60,000. So yeah, it was a very wide range.
Yeah, right. So we obviously cannot do that, as we saw. So with worker pools, we're going to launch a static number of Go routines, and let's say 5, and we're going to feed ports to those Go routines. So we're never going to have more than 5, but those 5 are going to work in parallel on all the ports that we need to do.
Exactly. So we're creating a set number, right, of Go routines that can go out and do the work, and as they get done, they come back and pick up some work, right? So in our case here, we've added a new flag, right? So we've actually modified our flags a little bit, basically just to make sure I don't have to type, from port and to port all over the place. I've just, I've made some improvements to reading of our ports here, but the important thing here is that on line 24, you see I've introduced a new flag. That's the workers flag, the number of workers flag, and I'm defaulting that to the number of logical CPU cores in my machine, right? So I think this is an 8-core machine, so that means by default I'm going to have 8 workers in my pool, which I think is a good place to start, because there's no right or wrong number for this. This is all going to be what is a sweet spot, because you might be running in production, you might be running on a 64-core, super beefed up machine or set of machines, right? That is going to be a very, very different performance profile than a developer laptop.
Yeah, and folks will have to do trade-offs. They'll have to measure how fast they want to run versus how much contention for Go routines per core do they want to run, or per OS thread, and so forth. That's a whole nother talk.
That's a whole nother talk. Yeah, that's something that will basically leave it to you to figure out for your particular situation or your particular workload what the correct number of workers is for you. But the idea here is that basically what we're going to be doing, and I've also added some additional things here, is that in this particular main function, I'm also capturing a signal for when I basically stop and send an interrupt to the program. I can still capture the results, so I can actually print them out. So that's all that's happening here. And I've hidden the port scanning right behind a nice little helper function that's just going to give me back a slice of integers, right, based on the arguments that I pass in when I invoke the program. So, but the real fun stuff starts on line 46. This is where I'm actually using make to actually create myself a buffered channel, right? So normally speaking, right, an unbuffered channel, right, facilitates some communication between the Go routines where only the information is exchanged when there is somebody on the other side waiting to receive a message. How does the buffered channel behave differently?
So a buffer channel has kind of a queue built into it, where I can start pushing stuff onto the channel and it'll fill up the queue. But once the queue gets full, then I block to send. Right. But on the other side, of course, there could be someone taking off of the queue, receiving from that channel. So if someone is receiving from the channel at a similar pace as what I'm sending, so let me say that better. If someone's receiving at the same pace as I send, then I'm not going to block on either side.
Exactly.
So it's just a little bit of a queue or a buffer, as the name goes, in between the sender and the receiver, and it can be used in this case, of course, to do our workers.
To do our workers, exactly. So what we're going to do is basically we're gonna launch an n number of Go routines, and that's going to be driven by the number of workers that we have in our pool, and we're going to be using the ports chain, right, as the mechanism to feed ports into and for workers to pick ports to scan out of, right? So we need to feed some ports in there, and others are going to be picking up from there. So the way we do that is by basically we've abstracted away, we've tucked away all of that behavior, right, into this worker function, which we're calling a new worker. Basically, we're preparing a new worker to start accepting work, right, based on the capacity, right, based on the number of workers that we have. This is what we're doing on line 50 here, right. So let's actually go take a look. Right, and then we'll come back to line 53. Let's go take a look for the definition of worker, right? So what if we take a look at the signature of this function here, we're going to take in the host. Yes, we know we need the host, but the directionality, right, of our ports chain and the directionality of our results chain, that looks interesting,
arrow,
right?
Huh?
Yeah, what's up with these little arrows? Can you explain those things to us, Aaron?
Well, you said it, directionality, right? So we can enlist the compiler to ensure that for the first one, for ports chain, that we only read from it.
We only
That's
read
a read-only chain.
Yeah, and that directionality, that arrow is on the left side of the chain keyword.
So if inside of worker, if we try to write to ports chain, our code won't compile, which is really nice. You get the compiler to write a whole class of tests for us, right? And then similarly for results chain, well, the arrow is going into the chain instead of out. So that's the one where we can only write to.
We can only send on it.
Yeah. And I love making the compiler do work for me. So this
Yep,
is a
yep.
huge boon for me,
Yep.
as it should be for all of us. I
Yep,
think, yeah.
exactly. And what's happening here, so basically we are ranging over a ports chain, right? And unlike other 4 ranges, when you read from a channel, only one value comes back, right? There's no index in value, it's just a value that you're picking up from the channel. And we're just ranging on the port, and as long as, on the channel, and as long as there's values coming in, right, we're gonna be doing some work, right? Basically, we're doing the same thing we were doing before, calling that.dial, inspecting the response, and if we notice that, okay, we consider the port closed, we're gonna send a 0 right onto the results chain, indicating that basically that whatever port that was, we don't care about it anymore because the port is closed. So we're gonna send a 0 in there because we need to send back, right, an integer. We need to send an integer into that port to indicate that we're done with that work, right? So we send a 0 in there and we continue on to the next one, right? So we're gonna keep iterating until that port is basically until we receive a signal, right, that this port is closed, and we're gonna see where that signal is actually sent back where this worker is actually invoked, right? But what we're gonna do here is basically, if we get to the point on line 112 where we manage to get past the point where we do the error check and we notice a closure, if we get back to the 112, we get past and down to 112, we're gonna consider that port to be open. So we send that P, whatever P happens to be, port 5432 for example, that's gonna go into the results chain, right? And this is where basically we're feeding back, right, the result of our operation, of our scanning operation. We're sending back the results onto that channel so that wherever the worker is being invoked, we can actually do something and read some values from that.
So we've got a consumer here. Worker is the consumer.
Yep.
There's going to be n number of CPUs, workers running. They're all going to consume. And if you send a port to the ports chain, one of the n workers is going to pick it up, do its thing, send back the result.
Yep.
So let's look at the producer now.
Yeah, so what's going to happen? So in order for us, right, to steadily feed in ports into this particular ports chain that the workers are actually waiting on, we actually need to range over, right, our ports to scan list. Right. Remember, ports to scan is basically what came back when we actually identified. Okay, you give us this from range, this to range. Like I get back a list of integer ports to actually scan. So I need to I'm going to range over this, feeding in the port numbers. Right. But why am I doing this in a separate Go routine here?
Well, that's a good question, right? So we're feeding stuff into ports chain, but in order for the port to get processed, we need to get something back on results chain, right? So if we were to, in the main Go routine, if we were to feed into ports chain in the main Go routine, we would eventually block.
Yes.
Right? So we need to do this in a background Go routine, n+2 now, background Go routine.
Yep.
Because every time we feed something into ports chain, we're going to block. And if we go further down onto line 59, 60, 61, 62, 63, that's where we're going to receive from the, results chain.
Right.
Once we receive from results chain, then the passing part on line 55, that's going to unblock, and we'll be able to continue to pass.
Exactly. Remember, we have a buffer, right, that we need to keep loose, right? So as things are sending in there, the moment the buffer is full, right, there can be no more sends, right? So, but we need to be popping things off, right, of that results chain in order for other things to actually be able to go in, right? So we basically, it's like a conveyor belt. We can't have a bottleneck anywhere. So we need to be able to read from the other end in order for new things to go in. So that's exactly why we have we have the feeding of the ports happening in a separate Go routine, and so that we can actually have the reading off of the result chain happening here as well.
And again, the important thing is we schedule in the background the person that puts stuff on to the conveyor belt.
Exactly.
But the person who's taking stuff off is in the main Go routine. Right?
Exactly. And then at the end here, we're just cleaning up after ourselves in this case, and then we actually print the results. So let's actually see this version of our program in action. This is the number 4. So let's actually go run. This is going to be 4. Make that go. And let's actually give this one the same number of ports that sort of tripped us up before, right? Remember, we just ran a file of the operating system, said you had too many file handles open. We just have too many Go routines trying to do too many things. So if we provide the same range again here, so this time, right, we're back to having the same kind of errors we were getting before, that, hey, the connections, is being refused, which we expect, that's our indication that basically the port is closed. But you notice that we haven't run a file of the operating system yet. We haven't had any errors that says, hey, you've got too many file handles open, you've exhausted your resources and things like that. So we have constrained our concurrency, using the worker pool pattern. We have a set number of workers doing work. They're we're feeding in ports to scan. We're picking things up on the other end, and actually our program now behaves a lot more stably.
And it also looks like we're actually doing this stuff concurrently.
Yes.
We're not just, like the first one where we're just going
sequential
through
1, 2, 3, 4. Yeah, exactly. And you can look at the port numbers here. It's completely out of sequence, right? Which is exactly what we want.
All right.
So let me stop this, and actually the results and the signal handling we got our results back. So we got 5432 and 6463 open. I think 6463 is because of Discord. I think I have Discord.
Is it?
Yeah, Discord opens this weird
That's
back
for
channel.
You, Peanut Gallery. That's for you.
Yeah, Discord's got some stuff going on there. I don't know if it's shady or not, but
probably.
Yeah.
No, probably.
Probably. All right, cool. So now that we've got ourselves the worker pool pattern, I wanted to introduce a pattern that we don't often see, right?
Well, so worker pool is like a legit pattern.
It's
right?
a legit
Like,
pattern.
you can use this in production. It's solid. Right?
Absolutely, absolutely. Okay. But there's another one that I find to be quite elegant, right? That I don't often see used in the Go community, and that's a semaphore. Can you try and explain succinctly what the semaphore is?
I could try. I haven't used semaphores in a long time, so I kind of see semaphore as similar to a worker pool, except it works in batches, right? It's like you batch up, let's say num CPU units of work or ports, and once they're all batched up and ready to go, then you kind of unlock and you start doing them. You start executing all 8, in your case, 8. You execute all 8 of them. Once they're all done, you start batching up 8 more, execute them all at once. So it's kind of like the opposite. You don't stream work, and the workers don't just pick it up as soon as they can. You kind of put everything on the conveyor belt. You stop the conveyor belt. You get everyone to pull stuff off the conveyor belt, do their work, and then you put all the new stuff, the new 8 ports onto the conveyor belt, and just rinse and repeat until it's all done.
Right. Another analogy that I've found to be quite useful for beginners, or at least for people who sort of those who go to restaurants, right? So and a lot of us have started doing that again. Since things started getting a little easier these days. Oh my goodness.
Finally get to
finally get to see other people in the real life. So imagine you and your 3 other friends, right, go to a restaurant, and you need a table that seats 4 people, right? And currently the restaurant is at capacity. Every table, maybe it's a Friday night, everybody's out having fun, and you're basically out in the lobby, the waiting area, because there is no table. There's a table with 2 people, right? But 2 open seats, right? But you need a table for 4 friends. You can't. All 4 of you must be able to go in there and sit down at that table, right? You can't have sparse, one spot here, 2 spots there. You need a table for 4 people, right? So to me, that's what the semaphore is. I need all 4 of us, right, to go and sit at a table, right? Basically, that's our allocation. We need all 4 of us to be able to sit in to actually do the work of eating, right? And talking to each other and having fun with each other, right? Or we simply wait until that becomes available, right? So that's the whole point of the semaphore. That's how that sort of that's what that facilitates and enables. But semaphore is not yet part of the standard library. It's part of the experimental set of packages under Golang/X. Right, but that's still, don't let that fool you. That very much, that I use this in production. It's very much part of our ecosystem and the part of the standard library. Or at times, these things sort of graduate into the standard library proper. But you have no fear of actually using this library. So let's actually see how we get to actually use this. So I'm just scrolling past a lot of this because we've already seen much of this already, and let's focus on the sort of how we invoke the semaphore here. So this semaphore, I call it a semaphore package, and I call it new weighted. So this particular function will give me so basically the maximum weight, right, of the semaphore. So how many things? So what's the capacity, right, of that restaurant? How many things? How many spots do I actually have? And basically now, from then on, we're able to say, well, what is the acquisition weight? Meaning, remember when I have me and my 3 other friends, we needed to be able to sort of we need 4 spots to basically go into this whole, restaurant and actually sit down and eat. That's the acquisition weight, right? So there's the maximum weight, because it should be the capacity of the restaurant, right? And there's the acquisition weight. I need 4 spots at a time to be able to go in and sit down and actually enjoy my meal, right? That's what these 2 are. And these numbers are completely arbitrary, but they work in relation to each other. right? So from there, we basically say, hey, I'm going to iterate through the list of ports to scan, right? Same as we've done before, but this time I'm going to be using the semaphore to acquire, right, on the using that particular acquisition weight, right? And this call is a blocking call. So that means this is us sitting in the lobby, right, waiting to be able to go in to sit down and eat, right, because there's not enough spots for us yet. So we're waiting right here. So as at the moment we've enough folks have acquired that acquisition weight, right? The moment that we can no longer extract, right, that acquisition weight, then the acquire becomes a blocking call.
So we saw blocking calls with the wait group. If you've used mutexes in Go or other languages, they're blocking calls in there in those languages, or with Go mutexes as well. It can be really useful here.
Yeah, absolutely, absolutely. And when as folks get done in the restaurant and they start to leave, right, they actually release, right, which is what we're doing here. We have basically a separate Go routine. In that Go routine, the actual scanning operation gets done, where we scan the port, and basically we're deferring the release, right, of the weight. So basically, imagine there was another party of 4 that just got done eating. Now they get up, they pay their bill, hopefully, and they walk out, right? So that's their release. They've just released, right, the acquisition weight. Now you, with the same acquisition weight, right, can now go in and sit down at that table where previously it was occupied, right? So that's that whole mechanism. So in the interest of the time, I'm going to skip running this one, and I'm going to jump to the next concept, the next pattern I want us to take a look at, and that's the pipeline. So when I say pipeline, what comes to mind for you?
Kind of like an assembly line to me. You got one person doing something, they hand it off, another person doing the next thing, they hand it off, but each individual person, they all just do one thing at a time. They know how to get something from the previous, do their thing, pass it on to the next.
Right. So the way I like to sort of visualize this is basically you have all these steps, right, and this sort of this conveyor belt as you illustrate. And each one of these steps obviously is handled by a Go routine, right? So we have, the first one, it gets done with the work, through a channel, right, communicates to the next step in the process, and then again through another channel communicates with the next step in the process, right? So let's actually see this pattern, right, at play in our code. So let's flip back. Oh, we need to. There we go. All right, so let's actually see how we actually put one of these together. So we've already seen much of this before. We've seen the ports to scan. We actually need to open up the right program. All right, here we are, back in action. All right, so we've got our ports to scan, and this time we're gonna be writing the results to a file. Oh, and by the way, there's gonna be a repository with all of this code sample, so don't you're not missing out on anything. You're gonna get to see all this and play around with it at your leisure, right? And basically, what we're doing here is this is where we have a pipeline invocation. Right, so the way this invocation is happening is kind of odd looking, right? So starting from the innermost function, we have a generator, right? Typically, when you have a pipeline, you need to actually generate. There's a starter. There's a starting point, right? That generates basically the work that needs to be done in the pipeline, and that's where this is. Notice the return type. That's a directional channel, right, for a scan op. Let's take a quick look at scan op. Scan op basically says, hey, it's an encapsulation that says, hey, given a port, and we're gonna find out whether it was open or not. If there was an error on the, we're gonna capture that, and we're gonna capture the duration, right? Pretty simple. We're just capturing all the details about the scan operation. That's what that's about, right? So that's gonna generate basically a channel for us of scan operations that we can read from, right, to do work, okay? But the result of that, right, is passed into our scan. Now, our scan is the next step in the process, right? It's the next step in the pipeline, right? So we're feeding in that channel into the scan. The scan then is going to read from that channel as well, and in whatever work it needs to do, right, it's going to be doing. But its result is also, right, a channel of scan operations, which gets fed into filter, right? So that conveyor belt mechanism, right? And then the last step in the process is the store, which does the exact same thing, receives that channel. So you can see how the channel becomes the conveyor belt. That same channel is what basically every step in the process is using to pass information to each other.
So I noticed something here. We've got, the standard people who do the work. We've got someone to not do work, but just pass stuff on at the beginning of the conveyor belt. We've got someone to take it off and put it into a file. but they're all waiting for the previous person.
Mhm.
We don't have any. Do we have any more concurrency in this?
That's the thing. By doing this, though, we've reintroduced sort of a sequential processing, right,
okay.
of step by step by step by step.
Okay.
So the way, I'm glad you brought this up, because the way we can avoid this is actually by using a different pattern called a fan out and fan in. So again, in the interest of time, I'm going to let you play with all these code samples on your own, but I'm going to introduce the fan out and fan in pattern instead, and see how that looks a little different, right, from the previous version, right? So on the, let's put this on the left side. Let's put the fan out on the right side. Okay. So this was our original, right, implementation. This is the pipeline, right? And on the right side, this is where we actually fanning out, right? We still have a generation step that's going to give us back our channel of operations that we're going to read from, but we're going to fan out by basically the scan call is basically going to receive basically that channel of scan operations that we can read from, but we're going to invoke it multiple times. In this case, we're doing so manually, but you can actually, you can program around this, right? You can have a loop that's basically driven by maybe the number of workers that you have working on those different steps in the pipeline. But we basically we split that work into 3 different channels, right? To actually perform the work, thereby bringing back the concurrency that we lost by making things sort of linear, right, with the first implementation of the pipeline.
So we got this model now where we started with linear, but it looks like it's super easy now to make it concurrent. Instead of calling scan once, now we're just calling it 3 times or n times or whatever. Now we've just pretty easily, we have 3 Go routines.
Exactly. So I'm gonna close this one, right? But I do want to do a quick walkthrough what our scan, what some of our pipeline steps look like. So if I go to the scan, right? So I didn't mention the generator and the scan and the filter. So these are you'll notice a pattern here which each step of our pipeline. So the generator, this is the starting point. This is when I said I receives the ports that we need to scan and returns that channel of scan operations that we're going to be reading from. So basically we create this sort of buffer channel, right, and then we feed in, right, the ports, right, to that outbound channel that we're going to feed into other steps that are going to read from that, right, and we return these things. And the reason why we are closing here, right, so we always talk about basically the channel, right, closing the channel being a signaling mechanism. Why do you think that's important here, that we actually we need to return this channel, and we need to close it here? But in other cases, we're doing this sort of because this is the first step in the process, the generator, right? The point I'm seeking to make is more readily illustrated with this, perhaps the scan operation, where we need to send back an outbound channel as quickly as possible, because we are in this pipeline, right? But we're actually we need to actually close out this channel to signal, right, to the further steps down the road that there's no more data coming, right?
So this is a great way to broadcast something.
This is exactly. When you close a channel, you're signaling to anybody who's reading on that channel that there is no more data coming, right? That's why we actually perform this work here inside of we defer the close of this outbound channel here after having fed in, or after having done the work, whatever work we need to do, right? Sending in the scan into the outbound channel, right? This happens concurrently, and we return back the outbound channel so that any other step in the process down the road can actually pick up and keep reading and know when there's no more work to be done. And
so we've kind of got a pattern here. Create a channel. Use our Go keyword to schedule some work. Immediately return the channel after it's scheduled, and then we kind of move on to the next step.
Move on to the next step. Exactly. So let me actually quickly show this version of the program, which is our fan out. And to find the appropriate. This is hard to read. I think it's been a long conference for us. All right. I think this is 9. Yep, it is 9. And we have that, and we have the ports here, and then we run a pretty wide range of ports. And then in this case here, we found the one port that is open. Actually, the 2 ports that are open, 5432, and the suspicious port from Discord. And we can see how sort of again using that fan out and fan in pattern, we're able to actually split the work across multiple Go routines and actually merge all the steps back in so that we can get ourselves a result, and our program successfully ends.
And this is cool because because we were really easily able to put filter on the end of our pipeline, so we don't have to parse
So we don't have to
manually
parse
through
exactly through all these things. Yeah, our filter function, which is exactly what we have here, we basically said, hey, I want to filter out only the open channels, right? Which is another step in our process, right? For in our pipeline, right?
Yeah.
Basically say, you only give me back the things that I care about, right? So one last thing we're going to look at before we wrap up here is
Are we looking at is it number 10? We're looking at context?
I think we're looking at we're looking at number 10, because one of the things that is useful, right, and being able to sort of launch all this work and being able to sort of know when things are done, being able to signal to Go routines that, hey, you're done, you can go away now, because Go routines are not garbage collected, right? They're going to hang around until you return from them when you say, hey, I'm not using them anymore, right? So we're basically augmenting our pipeline by having a mechanism of signaling, right, to every step of the pipeline when we no longer need the pipeline to be running, right?
And this goes back to our, always know when your Go routine is going to shut down.
Always know when the Go routine is going to shut down, know when to signal for it to go away, because again, these things sort of hang around. So this is where we're actually using, not a context, but we're using an actual a done channel, which is a very common idiom within the Go community, basically having that done channel passed around, just like you would a context, right? Okay. And this has given me, since we've been talking about this, has given me an idea how we should actually have another example to this. It actually uses the context, right, in addition to the example here that uses the done channel. But this done channel here, you can think of it as the signaling mechanism that we hand over to every step of the pipeline, so that they can be made aware of when they should stop doing the work.
And so, like you said, this is a really powerful and popular mechanism to broadcast something is done. If you use context for signaling things are timed out or manually finishing something, this is used under the scenes, right? Behind the scenes.
Behind the scenes, absolutely, absolutely. So you might see some change, some sophistication added here before we're sort of manually doing our fan out here. This is a more sophisticated way of actually, based on the number of workers, and creating the number, basically doing that same fan out work we were doing before, and then basically we're doing some filtering here. And this time, every step of our pipeline actually we receive as part of the invocation, as part of the arguments for that function invocation, is going to receive the done channel as a signaling mechanism. Meaning that if I were to go to say let's go to the filter open as one of the steps in our as an exemplar, right? You see that it received the done channel as as a read-only channel of an empty structs, right? The empty struct is the commonly used for signaling on channels. And again, we have the same thing we were doing before. We have the inbound channel from which we are actually going to read things to do. You see, I'm telling you, it's
long conference.
It's going to be the long. And then basically we're returning the channel of scan operations again for whatever comes at the next in the pipeline, and we're following the same exact procedure here. But the only thing we've introduced here that is worthy of note is the fact that we're actually now using a select block, right? To basically not only sort of doing the work we were doing before, but listening in on this done channel, so that if we receive a signal, right, that says, hey, you should stop now. You should be, there's nothing more that's going to come through on this pipeline, because sometimes you don't need the pipeline to keep operating anymore. You maybe you received an error and you really want to sort of bail out of there. There's nothing to be done anymore. You want to shut things down. So receiving a message off of that done channel is going to be our cue to return from this Go routine, right? So that now this Go routine goes away. Basically, it can get garbage collected. Now we can actually, sort of shut down things cleanly.
And this is a really popular pattern in, production concurrent code.
Exactly.
If you are going to do some operation inside of a Go routine, send or receive on a channel, you probably want to put it in select, and you probably want to have a done channel as well.
Exactly.
It's one of the cases in the select.
Exactly. So the final run of our example here, what I'm going to do is I'm going to use this filter error function, right? And I'm going to uncomment some things above so you can actually see this in action. I'm going to use this filter function here as that is part of our pipeline to basically say, hey, if I want to extract out of that pipeline as things are going through that conveyor belt, I want to pluck out, right, the scan operations that actually aired out, Okay, basically I'm gonna find the ones that basically when you do the scan and for whatever reason, right, there was an error. But the errors I'm gonna be looking for is one where there are too many open files. Remember that when we were in a file of the OS and basically saying, hey, you're using up too many resources when we had too many routines happening, running at the same time. I want to pluck those out. Right, and the way I'm going to do that is by actually invoking this program, basically asking for way too many routines to be running at any given time.
Workers,
lots of workers, right? So, but that filter function is actually going to give me back, right, the one where I've actually run afoul of my constraints here, and I'm going to return that. So let me go back onto the top here, and then we're gonna end up with a summary of the best practices for this. So I'm gonna, yep, you got something going on?
Oh no!
Oh, okay.
No.
I thought I heard you about to say something. Maybe a pun. You want to drop a pun on us while I'm uncommenting some code?
We're gonna do a lot of work right now. That's the best I got on short notice.
On short notice. All right, cool.
I do think it's cool because we decided imagine we got different requirements from our PM or from the CTO or something. We've got our pipeline and we're essentially going to comment out filter open and uncomment filter error, and now we've got different behavior. Right, so we're basically, the person at the end of the assembly line. We're going to fire one of them, and we're going to bring in someone new who's going to do slightly different work. And now we've got a different program. So this is the power to me of pipelines. It's very composable, but it's very orthogonal, I suppose.
Right. Indeed. So the first time I invoke this program, I just want to make sure it works. Nothing is broken, right? So I'm going to invoke this program as is, right? This is the one with our workers. So it actually did something. Let me make sure I've got okay, I've got the appropriate number of ports. Okay, good. So remember, actually the reason why we didn't get an output is because I'm filtering out, right? I'm only saying, give me back the errors that happened, right? So in this case, actually, I scanned, right, basically this default number of ports, and there was no error. So my program actually ran successfully, even though there was no output, right? So let's actually change that a little bit. Let's actually do this, but this time around, I'm going to provide a ridiculously wide range of ports.
A lot of file descriptors.
Yeah, and then I'm going to ask for a ridiculous number of workers, right? Let's actually see, right? If this goes according to how I think it's going to go, right? The operating system is going to tell, hey, at some point, this process has got way too many file handles open, right? And our filter error function in our pipeline should be able to pluck that out of that stream of errors, happening as the scanning is happening. Our filter error should be able to pick that up. Let's see if that's
it's
true.
Friday, but we're asking our trusty machine and trusty programming language
Don't let
to do
me
extra
down.
work.
Don't let me down.
Even though it's almost the weekend.
All right,
still
ready?
doing it.
Ready? Here it goes. Oh, it's running. It's running.
Oh,
here we go.
All right, too many open files.
There we go.
That's amazing.
We actually plucked out, right, the too many open files. And what else did we do when we actually caught this, right? Remember when we talking about the whole signaling mechanism? So what we did here, we were ranging over, right, plucking values out of the filter error step in our pipeline, right? And the moment we were able to read a value, right, we decided, you know what? I don't want this program running anymore.
We got an error we didn't like.
We didn't expect. We're bailing out of here. We're done. We send a signaling mechanism to any other steps that might be in the pipeline, that perhaps could be wrapping filter, whatever it is. We're not doing that here, but you can actually see, hey, if I had other things, wrapping filter, whatever it is, I could send this done signal, right, to everybody, say, hey, we're out of here, we're bailing, right? And then we move on, and then basically our program can now basically shut down cleanly, right? So these are a lot of cool tricks and tips, right? Let's see if we can actually summarize this into a handful of key takeaways.
Let's do it.
All right, so the first thing I would say is start simple.
I love this one.
Start simple.
I love it.
You saw us, we just used the net.dal. We found the one thing in the standard library that we needed to use for this. We had a port that we just hard coded into the program. We said, hey, what's the simplest thing that could work? And we could validate the idea and then basically build from there.
We evolved from a V1 that we're putting into production on day one. We evolved it. Maybe we fast forwarded through 3 years of production experience here.
Right.
We evolved it. We got more complex as we needed to as production bugs came out or as requirements grew.
Indeed.
Should we do a 1, 2, 3?
1, 2, 3. Yeah.
Identify the 1, 2, 3. Embarrassingly parallel.
Exactly. We're having way too much fun with this.
Oh, yeah.
Yeah. So not every problem you encounter, right, is going to be suitable, right, for concurrency, right? And when you do, you need to identify the parts of your code that actually can run, right, in parallel. That's a good candidate for concurrency.
And a lot of that is when they don't have dependencies with each other.
Exactly.
Right?
If there's no dependency from one to the next, that's usually a good spot, right, for contemplating concurrency. What's the next one?
Avoid runaway
routines.
Yes. That goes back to like always make sure you know when you're scheduling them, at least when you're scheduling them and when they're going to be done.
Exactly. And as you saw us basically saying, throwing a bunch of routines, at the task, and the operating system basically saying, you're using up way too many file handles. In that case, that was a constraint that we're violating, right, with our program. So you need to understand, and what is the context in which my program is going to run? What are the resources that I'm going to have available, right? What's the network throughput I'm working with? What's the database constraints? What's the latency? Whatever the case may be, identify the constraints within which your program is actually going to execute, so that when you have routines doing the work, you actually know what boundaries are they going to bump up against.
And another thing to remember, if you're coming from C, C++, or Java, or other operating systems that give you access to OS threads, Go routines are not OS threads, right? So the operating system is not going to automatically schedule your Go routines. The operating system is not going to automatically limit your Go routines. The Go runtime lets you have lots and lots of Go routines.
Indeed. So leverage the standard library, right? We didn't need to go far. Yeah, that was pretty much it. The only thing that was foreign, if you want to call it that, was the semaphore that came from the Golang X.
Yeah.
But pretty much everything is standard library.
Yeah.
Use the more advanced pattern as needed.
And that's key, the last two words there, as needed. We evolved from the simple thing. And it kind of goes back to the first bullet point.
Yep.
We evolved from the simplest solution as we needed to. As we found out that, well, a user might come and test in production and give us 10,000 ports to scan. Well, that's not going to work on our server or on our laptop. So we need to add more patterns to manage that requirement.
Exactly. So the repository with all the source code and even the things we didn't have time to go over is all available at this URL. And this is my Twitter handle, and this is Aaron's. Feel free to get in touch with us, especially those that are new to the community.
Yeah.
We welcome you. This is a safe place, and definitely reach out to us. Don't hesitate. Don't be shy. Right?
We're hopefully more than happy to talk about this stuff.
Happy.
If you couldn't tell, we love this stuff. Concurrency is our jam. Distributed systems is our jam. So please reach out if you want to talk about this stuff. If you have questions, if you want to work through a problem, anything.
Absolutely. And I think that's all we got. So
I
think you. Wait, did we forget somebody? I think we forgot somebody.
We left Erik. Erik. We forgot about you.
I'm just saying.
You want to come over here?
Come on in the middle.
We
got a third
system.
We forgot him.
No, seriously, I couldn't be happier to spend the week here with these two.
Likewise, yeah.
It's been a fantastic conference. I wish we could have done it in person. Hopefully next year we can. I know you've got to see a lot of our faces, but first off, I want to thank the production crew that's been working on this conference year round. Heather, Jose, Julie from Convention Designs that have been working on this year round, replanned the whole thing with us in 2 months.
Truly heroes.
When we went to virtual. Yeah.
They
and
did a lot.
2 years in a row replanning the conference.
I think we said at the outset of this conference, they may have planned 5 conferences for 2 years or something along those lines.
Yeah, exactly.
So thank you to them. Thank you.
You see the three of us standing here, and we were at the desk, but there's a lot of people here that you don't see. We've got Ross here behind the camera.
Hey, Ross.
We've got Matt and camera running the audio and video boards out there. I don't think they have a camera on themselves.
Nope.
We've got Matt over there furiously editing videos so that hopefully we can get all of these to you on our YouTube channel within the next week or so. And also Jose and Julie are sitting out here outside this window too.
I mean, they're the ones that bring this content to you. They're the ones who make us look really good. They're the ones who make our job easy. Which is,
despite the shirt.
Despite the shirt.
Yeah, despite the shirt. How do you invite this shirt to come up here with you?
We don't have a wardrobe person, so I don't know.
In fact, you are the wardrobe person. By you wearing that, we don't even have to think about our wardrobe.
I make you look good too.
Exactly. Just throw anything on, anything, really. A bathrobe bathrobe, anything.
Please don't come in a bathrobe.
That's been done.
That's
Remember
actually
Brian
been
and I
done. Oh,
opened
yeah, I do.
last year in
I do.
bathrobes? Yeah, that was pretty funny.
I'm trying to forget, but now it's back.
Now it's
Thanks to
it's
you.
all coming
Yeah.
back. It's all coming back.
Yeah.
And thank you to our sponsors. We couldn't do this without you. This first year, like being able to bring this to you completely for free.
Yeah.
So we couldn't do this without our sponsors. If you haven't gone and shown them love, please do. Go to the sponsors page on the GopherCon website. Go check out their sites, see what they've got going on. I think some of the giveaways might be going on. I don't know whether they've done the drawings yet. If you're looking for a job, please go talk to them. That's the overwhelming majority of the reason why our sponsors come here.
Yeah, check them out in Discord as well. I think the CrowdStrike contest might be over now, but
hopefully,
hopefully there's not any more horrible generics code out there. But I'll be studying it. I'll be watching all
what
of
not
the
to do.
generics authors out there. What not to do. Yeah.
Thank you to all of our speakers, those that were able to fly into the studio and have some fun with us for the last couple of days. Thank you to the speakers that weren't able to make it and were able to get us recordings and things like that,
Stellar
like on
recordings.
very short notice, like
Yeah.
the production quality of these things. Thank you to the editors that have been like furiously working on getting these things ready.
Yeah. Lightning Talk speakers, thank you so much for contributing there. Should we do one more thank you to Mark? I think maybe.
All right, he gets one more,
One
and
more,
that's it.
and that's
Okay.
it. Yeah.
All right. Should we do a 1, 2, 3, and then
Thank you, Mark.
Okay.
1, 2, 3.
Thank you, Mark.
I hope he sees that and cringes. Yeah. Oh man.
I know he puts a ton of work into it. He's really passionate about doing the lightning talks, both in person and continuing to do it virtually. If you run into him on Discord or on Slack, throw him a thank you. Talk to him about lightning talks next year.
Yeah, everyone here in the GopherCon family is always looking for new lightning talks, for new content. Again, it's a great way to get started into speaking. If you're new, it's a great way. Even if you've spoken a lot before, it's a great way to test out a new idea. As Johnny said earlier, it's a great way to challenge yourself, to cut down your content or your idea to 7 minutes.
Yeah.
Good luck with that. That is tough. So then it's another one there for you.
Yeah, and the Go Time team.
Yeah.
Indeed. Yeah.
Of which they are missing one.
I know, but hey, couldn't be in two places at once. I haven't figured out that trick yet.
You had to choose who you love more, and we came out.
Hey! I didn't say that. Matt,
Matt's gonna be like, you chose that.
You chose blue and gray, man.
Oh man! But absolutely, that team was basically its own sort of operation going on as well, and behind the scenes, and making sure that this conference went off as well as it did. Big thank you to them as well.
Indeed. And thank you to everybody.
Everybody thank all of you for coming and hanging out. I know that the last 2 years have been tough on everybody. I know there's probably a lot of virtual conference fatigue at this point. But we appreciate you watching. We appreciate you hanging out and interacting with us in Discord and heckling us a little bit in the peanut gallery. I don't know why I amazingly like being heckled.
Same.
It's weird.
Yeah.
Maybe
Same. It tells us that you love us. Yeah. He who heckles loves. He or anyone. He or she who heckles loves.
Or it validates our imposter syndrome. Like,
Yeah,
no, you
yeah.
you really are. You really are an imposter.
You really are an imposter.
Right.
Don't worry. You don't have to think about it anymore. You're an imposter.
Everybody
You're
knows
definitely
now.
an imposter.
That's
Everybody
good.
knows now.
You know, we all know.
Yeah.
We're good. We're good.
Yeah, you don't
we
need to
accept
worry
you as you
anymore.
are. So that's a wrap. Thank you so much, everybody. Thanks again to the Learn TV team.
videos. We're going to have recordings.
Oh,
up,
yes.
right?
Recordings will be up probably in
Yeah.
about a week.
Okay, wonderful.
So,
Sweet. Yeah.
But
So
thanks
we missed
again to the Learn TV team for putting us up in
Thank
the studio.
Thank you to
and-
Microsoft. Thank you to Capital One. Thank you to Salesforce for the captioning. We certainly couldn't do this on short notice without the help of those folks and the rest of the sponsors too.
All right. Thanks, everybody. We'll see you next year, hopefully in person.
Yes.